So there is a message up now that the meeting is now being streamlined live on the YouTube. So we obviously have many more viewers than we see over here at this meeting. So there must be several who have joined on the YouTube. Professor Srinivas, are you there? Vishwanathan? Dr. Vishwanathan?
Yes, sir.
Dr. Vishwanathan, can you call?
Sir, I will call Dean, sir, and I will find it out.
Yes, yes. So if one of you will connect to, yes, thanks.
Sir, namaste, sir. Sir, we are waiting and logging in, sir. Yeah, thank you, sir. Sir is logging, sir.
Very nice.
Yeah, some problem maybe, so he is logging. So just now.
Yeah, perfect, no problem.
I too was having some network problems, sir, in logging.
Yes.
Yeah, I think people are facing some problem, but they are logging in.
Yeah.
Lot many are messaging from our department that they are logging in.
Okay.
Just no. It's fine, no? Yeah. Sir, good morning.
Good morning.
Good morning, Professor. Sir, you hear my voice?
Yes. Yes.
Good morning, sir.
Good morning, everybody.
You can come down around 10:30. Bani, bani. No problem. Okay. You come to the dental block 6th floor. Dental block 6th floor.
There's probably continued technical problem, but I'm sure Professor Srinivas will be joining us very soon. Vaibhav, can you call him again just to
One
find
second.
out?
One second. 1 second.
Thanks.
1 second. Sir, you are able to log in? Eh? Oh, okay. Okay, fine. Sir, I will tell. Sir, namaste, sir. Sir is saying that there is some network problem. He's not able to log in, sir.
Okay, so I guess we will begin the session, and Professor Srinivas will certainly join us as soon as he can. I certainly hope that he can sort out the technical problem sometime soon. So we had a great start yesterday. We had a wonderful session, very exciting keynote address followed by three very important talks on devices which are being built by our colleagues over here for futuristic applications. And we were to have the inaugural address by the Honorable Vice Chancellor, Professor K.N.B. Murthy, but yesterday he was tied up with some other meetings and he was not able to join us. But we are very privileged to have him join us this morning. So thank you very much, Professor Murthy. He, of course, needs no introduction. He is the one who oversees the entire university's academic program. So I will not even make an attempt to introduce him because everybody knows him so well. So Professor Murthy, may I request you to please deliver your inaugural address?
Yeah, thank you very much. Thank you, Professor Deshmukh, Professor Srinivas, my dear faculty colleagues. I'm extremely happy to be with all of you today morning. Although I was supposed to join you yesterday afternoon, I had a series of meetings which got extended, and from 11:30 the meeting got rescheduled to 12:30. Then the meeting went on up to almost 2:30. Then I briefly present for the talk by Professor Viraj Kumar and Dr. Rajini. And after that, I had one more meeting. Then I had to exit and move out of the in-house symposium. The in-house symposium is a fantastic idea wherein it's a kind of meeting or a conference which is conducted in-house. I was just trying to look at the exact meaning of symposium, then also in-house symposium. Is it being done elsewhere, kind of thing? Ultimately, the answer that I got is the following. The in-house symposium or a symposium itself is a meeting or a conference on a particular subject. In this case, it's advanced trends in science and technology, where the meeting or the conference is conducted over a period of typically for 1 day, probably extended up for 2 days. I think it's 1.5 days here. And the in-house symposium is normally a smaller one, a focused one. Obviously, the audience are presenters where they present their research and other things. Thereby, it's a kind of an event where the experts would join together, deliberate on the kind of research that's happening in the university. I'm sure in the 1.5 days, a lot of information will be presented, exchanged. There will be lots of questions that are being asked. I see a lot of benefits from these kinds of events. First of all, I need to congratulate Professor Deshmukh for initiating this and driving it through. This, symposium is a kind of platform for the budding researchers to take away a lot of inputs and adopt some of them in their research careers. What exactly we are trying to do, at least in DSU, as you're aware that Dayanand Sagar University is a state private university. We would like to position Dayanand Sagar University differently. Possible this in-house symposium is one such activity where a uniqueness is being secured or acquired in the university. I don't see these kinds of things happening elsewhere. When we say uniqueness, it's necessary for us to conduct few things which will improve or stimulate the intellectual activity in the university. University is one place where the exchange of ideas are going to happen. The exchange of knowledge is going to happen. All in all, there will be some applications that are derived across disciplines. I'm sure this symposium would give an idea with regard to the kind of research being done by various researchers within the university, because it's an in-house symposium. You get to know the quality of research being done, the broad research area, and obviously you get a few inputs, few ideas from the research work. Probably you can find an opportunity to work with a researcher who is very close to your research domain. And when we talk of bringing that uniqueness for the university, I think we need to bring in the culture of research and culture of intellectual activities. And you all aware that the culture is one thing which needs to evolve, needs to develop in a university for taking it to next level and also significantly contribute to the body of knowledge of the topic that we have considered, or the body of knowledge for doing something good for the common people. When I say culture, in my understanding, culture is all about an environment for intellectual discussions, an environment which is going to value that intellectual discussions very much, is an environment which is going to support that intellectual activity, is also being respected. I think if we can have that deliberations, then value for the work, support for the work, and respect for the work, I'm sure it's going to do a lot of good for the university. I would sincerely request the faculty of DSU to look at through 2 or 3 broad things while making presentations. One thing all of the presenters need to understand is, instead of going deep into technical matters, please understand there will be lots of people from various backgrounds. Therefore, try to start off with an introduction where anybody and everybody will be able to understand. Then try to make that presentation so that the application domains and other things can be understood by the audience. In my understanding, there are about 3 questions that you need to answer. One, why is the research that you're doing is important? Why that research area? What? Second, what are the kind of the methodology that you've used? What is the significance of that? The third, you may have to answer the question like, what are its applications? The application part of it. If we can broadly answer these 3 questions, I'm sure the audience would appreciate the kind of work that's been done, the kind of focus or the interest that you have taken in that. The second thing that's also required for the audience to pick up and understand is the following. One, each of the presenters I'm seeing about 16 in-house presentations and 1 external presenter that was there yesterday. These 16 presenters will present the subject matter differently. You try to understand the style of presentation of each one of them, and also look at the creativity of designing their presentations. What kind of slides have been prepared? How much of text is there in the presentation? In other words, it helps you to pick up that style of presentation and whichever you like most, because each one of us have our own method of presenting, style of presenting, and possibly you gives you a fair idea with regard to the presentation style, so that it's really good. There are multiple ways. I've seen people presenting in different formats and different styles. Some of them would put out the entire text on in the presentation, the slides, and start reading it. And in between they try to explain what they're talking about. Few others would only put few points, try to talk about each point in detail. I've also seen people or the researchers putting only diagrams and try to explain the diagrams. I've also seen people using only animations and trying to explain the kind of things. Therefore, there are multiple styles, and each one of them would have their own presentation style. Possibly the audience should pick up the style which you like most. Eventually, you need to have your own style of presentation, incorporating some of the best presentation that were made here. I think that gives you an opportunity to pick up that art of presenting, make it really effective. There are also multiple formats that are being used. I think in one particular case where I've seen, there'll be 7 slides and 7 minutes, where there were only 7 slides allowed. Within 7 minutes, you need to complete your presentation. In those 7 slides, you need to put everything that you have done. In those 7 minutes, you must be in a position to explain your research work. That's one mode that I have seen. The other mode that I have seen is 100 minutes and 10 topics. 10 topics, 100 minutes. 10 minutes for each topic, where exactly after 10 minutes the person has to move out. On 10 different subjects, related subjects. I've also seen where the restrictions have been put in some of these things, where you are allowed to use only 5 points per slide and 5 slides, and presentation for about 10 minutes. In multiple formats that are being used. Overall, I'm just trying to see this in-house symposium is one which gives a lot of opportunity for the budding researchers in multiple ways. One, you go through the presentations and try to develop or pick up the style of presentation which you like most. That's one thing which I see. Second, you try to see a kind of research that's being done by co-researchers, probably collaborate with them and work with them and try to be a part of the research group and contribute significantly. The third benefit that I see is you see an application area for some of the work being done by your colleagues or faculty colleagues, and possibly extend that application, apply those applications or work on those applications using the concept that are being presented here. That also gives you an opportunity to explore new research domains. The other thing that I also see is in terms of developing your own art of doing research. I think eventually you need to build that, develop that style. And that's exactly what happens when you ultimately you try to develop your own stamp in terms of doing your research, in the sense that's exactly what happens to all of us when we do our research, when we do our PhD, when we work with our research supervisors, and we start looking at their research style, research culture, research methodology, and what they want you to specify, stress, kind of a thing. I think they clearly say this point needs to be stressed more and this point needs to be stressed less. I think they will start understanding the art of writing research papers and art of making the research presentations. Similarly, over a period of time, you need to develop your own style. Pass on that particular style to your research student. Help your research student to develop their own style of art of doing this. Eventually, I think each one of us need to keep 2-3 points in mind, wherein we contribute to the body of knowledge, number one. Second, whatever research that we do needs to benefit the common people, directly or indirectly, and be sure that that's eventually is going to happen. Last, identifying those researchers working in the same similar kind of domain, probably get together, explore new opportunities, and collaborate and start working together to do a better quality research than what's been done eventually. And I strongly see there are two things. Universal research is the one which is key for identifying or predicting the future directions. If I see distinctly, I think before 90s, the universal research was considered to be the research which used to give the directions for the technology development, for several other things. And the industry used to adopt the research that's been done in the university. After 90s, I see the kind of research that's been carried out in the industry is far ahead of the research that's being done in the university. I think with this time now, the university research is taking over again. I think it is necessary for us to start working on few things without worrying about the other aspects of it. You need to work on some fundamental kind of research domains or fundamental research, wherein you start predicting the future, start identifying those things which are important, which are critical to be solved. All in all, I think it's a good initiative. I wish this initiative is a grand success, and also request Professor Deshmukh to ensure that it's going to become a annual kind of a activity. And finally, I see this in-house symposium is of the DSU, by the DSU and for the DSU. I think mostly that's the kind of message that I would like to give, and congratulate each one of you, and try to derive some benefits of these initiatives. And at the end of this symposium, probably write down few outcomes and evaluate those outcomes against the objectives that we had set forth, and try to learn from those, the gaps that are going to be there, so that those gaps are going to be addressed in the next symposium. And it has to become a kind of a model for other universities to follow. And also it helps majority of the students to pick up the interest in doing research. And I wish this activity a grand success, and thank the organizers for inviting me to be a part of this event, and assure you all the support from the university for all such initiatives in the future. Thank you. Thank you very much.
Thank you so
very
much.
much. Professor Srinivas has joined us, so I will request him to conduct the proceedings for the rest of the session.
Surely.
Thank you, Professor Murthy.
Yeah. Sir, thank you very much, sir. Vice Chancellor, sir. Your presence has added a lot of grace to the event. And I'm sure this event is a step forward in the definition of building a great university that you have always been talking about. We can assure you that we'll all work together to meet the dreams of the university. So once again, thank you for your gracing the occasion and addressing the audience. Now we have the plenary talk by Professor Deshmukh. Can I request Professor Viraj to please introduce Professor Deshmukh?
I think Vijay Kumar.
Is Viraj around?
Vijay Kumar.
No, I thought Viraj is going to introduce you.
It's Dr. Vijay Kumar, Department of Physics.
Oh, sorry. Sorry. Yeah, one more apology from my side. Yeah, Professor Vijay Kumar will introduce Professor Deshmukh. Can you please take over, Professor Vijay?
Yes, sir. Yeah. So is audible, sir? My voice is audible?
Yes, very much, very much.
Sir, good morning all. First of all, greetings from Department of Physics and School of Engineering. We're going to organizing in-house symposium on the applications of science and engineering. I hope it is a multidisciplinary program multidisciplinary symposium. I think it is useful for all the departments. Now, once again, it is my immense pleasure to introduce our great distinguished professor, Professor Deshmukh ji. The Professor Deshmukh ji is served IIT Madras for over 3 decades and also IIT Mandi and IIT Tirupati on deputation. Professor Deshmukh's research group is one of the world's largest in the field of relativistic quantum theory, studies of atomic photoionization. His group has made very important contributions to the understanding of ultra-fast atomic dynamics. His expertise in relativistic quantum man-body theory, and also is a reviewer for so many international journals, and is published at topmost international Scopus indexed journals and review papers. And Professor Deshmukh ji is currently working on scattering time delay in quantum information processing. So for this small brief, I will thank our Professor Deshmukh ji to take initiation to organizing this program, and also I will thank for all the members to participate in this great event. Thank you all. I request Professor Deshmukh ji start the program.
Yes, thank you, Professor Vijay Kumar, and good morning and greetings to everybody. Thank you all for enabling this opportunity for me to make a presentation this morning. And I will be talking about chaos and uncertainty in impending breakthroughs. So we are looking at the future, and one of the main things that will dictate the outcome of major advances in science, engineering, and technology are going to be very strongly influenced by chaos and uncertainty. And there is nothing unsettling about this. On the contrary, this is something which will really provide major breakthroughs in future. So let me just quickly remind you of the earthquake in 2011 in Japan. And this was an earthquake of 9 Richter. So this was not too long ago. I'm sure you all remember that. And one of the things it did to the earth is that the length of the day shortened by 1.8 microseconds. Then the earthquake in Chile in 2010 shortened the day by 1.26 microseconds. This was 8.8 Richter. Sumatra earthquake in 2004 shortened the length of the day by 6.8 microseconds. So the speed with which the earth rotates, which constitutes the overall time interval for what we call as a day, that sort of changes because of various events. There are these tectonic plates inside the Earth's stomach which move around. There has been continental drift, and there has been an entire change of shape of the continents. But continuously, these things keep happening, and the mass distribution inside the Earth changes, which changes the moment of inertia, and therefore also the angular velocity. And there are other things. There are tidal forces on the waters on the Earth due to the moon, and all of this causes the length of the day to change. And the term which is responsible for it depends on the rate at which the angular velocity of the Earth changes, which is d omega by dt, and you have the cross product with the position vector here. And this is called as a correction, which is called as the leap second correction. So every 4 years we make a leap year correction, so that we add a day to February. We have the 29th of February in every leap year. We had one this year. But every now and then one has to make what is called as a leap second correction. And this is organized by the International Earth Rotation and Reference System Service, the IERS, and they decide when to introduce a leap second correction. This happens typically once in every 1.5 years, more or less, but it's not a fixed day like 29th of February, but the IERS tells us when this correction is to be done. So the Earth was slower than the atomic clocks by 0.16 seconds, and this is where we are coming close to the standardization of the GPS and the atomic clocks, which are running everything in today's technology world. So the Earth was slower than atomic clocks by 0.1 seconds in 2005, by 0.3 seconds in 2006, 0.32 seconds in 2008, and so on. And one has to do a recalibration based on this. And even our ISRO's NAVIC device, which is like the GPS system, which we recently heard about from Dr. Kasturi Rangan. In all of these devices, these corrections have to be made. Even the trading on NASDAQ and the New York Stock Exchange, in fact, had to be suspended on 30th June 2012 because the clocks were not synchronized. And these clocks are the one which determine banking and everything. At what time does trading start? At 9 o'clock New York time. Then it's, if that time is shifted even slightly, then it affects the whole banking system and trading across the world. So these are very important consequences if you are not having phase locked devices. And these phase lock devices, a typical one is the phase lock loop, which I'm sure most engineers will be familiar with. There are analog and also digital phase lock loops. And the PLL systems, they control many things. They're used in computer clock synchronization, demodulation, interlocking computer clocks, and they are used in telecommunications, cybersecurity protocols. So you see how important these things are, and they can be affected by small things. The most recent thing that I would like to share with you is that the coronavirus lockdowns have actually changed the way how matter moves on Earth. So here is a graph which tells us, you remember Corona lockdown began around March 28, March 14, the schools shut down. So this is the curve in Belgium. This is the ground displacement in nanometers, and it actually came down. So this is an article in Nature in the March issue earlier this year. So what is going to control this is that many of these devices are vulnerable to chaos, and these are non-linear dynamical effects, and chaotic events can really affect all engineering applications. And it's very important for all of us to be familiar with this and to take this into our studies for devising future applications. Anything that we develop which is of importance in this, what happens is if you have a phase or frequency modulated input signal, then the digital phase lock loop equation becomes non-autonomous and chaos can occur. So chaos is a very important aspect of engineering for the future. And there's a lot of literature and reviews and articles in modern journals about this. And I would like to quote Gerd Binning, who got a Nobel Prize for designing the scanning tunneling microscope. And he says that I'm convinced that chaos research will bring about a revolution in natural sciences similar to that produced by quantum theory. So this is extremely important. Your equations look very simple, but you can have a very complex behavior. And let me quickly share with you that the modern methods of research are observation and analysis. People like Galileo and Balmer and C.V. Raman are some of the most spectacular exponents of this method. There is also the method of modeling, the works of Newton, Maxwell, Schrödinger, Einstein, and so on. But then mathematics plays a huge role in learning about nature. And you can get so much about the laws of nature just by looking at numbers like pi, like the Euler's number, exponential number, or the fine structure constant alpha. And also the manner in which these numbers are arranged, not just what these numbers are, but how these numbers are arranged. And Eugene Wigner points out that the miracle of the appropriateness of the language of mathematics for the formulations of the laws of physics is a wonderful gift that we neither understand nor deserve. But it's a great gift. And look at the arrangement of numbers, the Varaha-Mihir's arrangements of numbers. So he arranged these numbers, and you recognize these. I'm sure you're all familiar with this. Many people call this arrangement as Pascal's triangle, but before Pascal, this is there in scripted literature on palm leaves, and Varaha-Mihir is the first person who did it. And you can learn so much from these numbers. You can learn so much from the Fibonacci numbers. So if you look at these numbers, 1, 2, 3, 5, 8, the sum of the two numbers is the next number. 1 plus 2 is 3, 2 plus 2 is 5, and so on. And if you look at the book, The Art of Computer Programming by Knuth, then he points out that these numbers were actually known before Fibonacci to Gopal, before this is in the 12th century, and to Hemachandra also in the 12th century. They have actually specified these numbers in the rhythm of n beats, the percussion instruments and so on. So these have been known. A lot of work has been done in India, and all this is an important integral aspect of the study of chaos. Recently, just a few weeks ago, there was this huge conference arranged by the government of India, the Vaishwik Bharatiya Vaigyanik Summit, Vaibhav as it was called, and chaos was huge topic in this symposium. I was pointing out how much you can learn from these numbers. So look at these numbers. These are just ratios of two sides of a rectangle. And if you take the ratio of the shorter side to the longer side, and if you insert a line over here so that you are left with a square over here, then you get from this very simple relationship a quadratic relation for phi. Phi is this ratio. And this quadratic equation has got a certain solution which you can just keep writing. This is the golden ratio, and the Fibonacci numbers are such that the numbers are arranged in such a manner that the ratio of consecutive numbers converges to this golden ratio. So all this is coming from the understanding of numbers. And look what these numbers do to us. They're giving us laws of nature. They're telling us how nature presents itself. So here is a sunflower. Here is, these are various cones, shells. So they all have shapes and designs which are determined by the golden ratio, which is coming straight out of Fibonacci numbers. And many of these things come from nonlinear dynamics. When you're dealing with maps, if you look at the equation for the golden ratio, you notice that you get a phi here and another phi here, and you can replace this phi by the same expression, and you get a similar expression. So this is like deja vu. The same thing appearing again and again, like a cauliflower, that you peel it, and the more you peel, and this is nature, and this is what our target of interest is. We want to understand nature. We have to live with nature, and these numbers are telling us how to interpret nature. So there is a deja vu in this. So these are called as fractals, and they are involved in how a dynamical system evolves with time toward an attractor. So how the ratio of successive numbers in Fibonacci sequence converges is the evolution of the dynamical system, which in this case is a set of numbers, and how they converge to the attractor, which is in this case the golden ratio. So this was a question which was posed to Henry Poincaré by the King of Sweden. And the question was, if you just have a three-body system, the sun, moon, and the earth. I mean, everybody knows that if you take any two bodies, sun and the earth, then the solution is given by the Kepler-Newton problem, and you know that the solution is an ellipse. and it is an exact solution. But the moment you have a third body, like you include the gravitational interaction involving the third body, whether it is Moon or Jupiter or anything else, then it turns out that the solution really becomes chaotic. And the same initial condition. So here are two curves which show that they start from initial conditions which are very close by, and you expect the evolution to go more or less together, but then it could also happen that the evolution diverges. And this is the butterfly effect. A small change in the initial condition can change what happens somewhere else. So because the small effects can cascade. So, but the butterfly effect is just that there is a little change in the atmosphere due to the flutter of the butterfly, but the effects can cascade as they travel across the globe, and you may have a storm caused in Brazil or some other part of the world. So this is chaos, and this is going to play a huge role in our studies of future of this thing. I'm left with just a few minutes, so I'm going to skip several of my slides, but I will be happy to discuss them with those of you who are interested. The other thing, I would like to point out the importance of fractals and chaos in engineering. This is of great importance to the School of Engineering. But I will quickly like to go over to, oh, here is a nice figure. I want to show it because my student has generated these plots. This is Avia from ICER, and she has generated these Mandelbrot plots, which are fractals. So I want to move on quickly and spend a few minutes on the other uncertainty, which is going to determine future developments in science, engineering, and technology. So all of our classical computing is based on 0 and 1. It is either this or that, and the switch is on or off. And everything is binary, like Arjun's question, do I fight or do I not fight? Or Hamlet's question, to be or not to be. But now, nature is not as simple as that, okay, you can say that it is either this or that. You need to talk about a cat which is dead and alive, and the future of computing lies in quantum computing, because nature is quantum mechanical. It observes quantum laws, and the unit of calculation is not going to be 1 or 0, but the quantum bit, because you have the possibility of a cat being dead or alive, and it is typically in a state of superposition. And this is quantum entanglement, which leads to, which it has resulted in a huge transition. So if you look at the developments in computers from Charles Babbage, then to Alan Turing, some regard him as even the father of the artificial intelligence. And then in the early 1980s, Feynman said that nature is not classical, and you want to make a simulation of nature, you would better make it using quantum laws. So this is the beginning of the quantum computers, and this was in the early 80s. And then in the mid 90s, Peter Shor built the first quantum algorithm for discrete logarithms and factoring, and Love Kumar Grover, who studied at IIT Delhi, he developed one of the first quantum computing algorithm. This was like a search algorithm for database search. And since then, since the late 90s, quantum computers are being built. These are, you do not use the digital electronic gates like the AND gates, the NAND gates, and so on. So these are replaced by quantum gates, which are essentially unitary transformations on what is called as a Poincare sphere or the block sphere. So Deutsch was one of the first ones to build a quantum algorithm. And now, of course, this is an older quantum computer which was built. This was an ion trap quantum information processor. This was built almost 20 years ago. And now, of course, there is a very neck-to-neck competition between IBM and Google, and even Honeywell is into this competition to build quantum gates, quantum circuits, and quantum computers. So they are in huge competition. The chemists will be very happy to know that Hartree-Fock has been done on Google's computer quite recently. This was 28th of August 2020 is when this was reported in Science, and they used a 12 qubits machine to get this calculation. This is a scalable algorithm. I would like to thank my collaborators and students who have participated in understanding various studies. I want to conclude this because we have a very busy schedule for the rest of the day, but I'm certainly available for discussions on these topics. Right now, we are interested in looking at time delays in quantum collisions and what kind of impact they have on quantum information processing. And these will ultimately put limits on the speed at which quantum computers can deliver a result. So these are some very exciting topics we are working on. So these are very new things. Experiments have been done very recently. This is quantum dots have been used in just this last year. There is a paper in Physical Review Letters by Strauss group. They used a single quantum dot. This is a great candidate to build a quantum computer. So I'm going to conclude my talk over here. I will be happy to take a few questions if there is time. Otherwise, you can ask me the questions later as well. Thank you all very much. Professor Srinivas.
Thank you so much, sir. It was such a pleasure, and you have brought a IIT kind of quality and style to the university. We are extremely grateful to you. It was very educative and very informative. Thanks again, sir, for the effort that you have spent in giving us an excellent presentation.
Thank you.
Now we have a session starting. Our session coordinator is Dr. Vishwanath today, and the theme of the session from 10:05 to 10:45 is going to be recent trends in material research for industrial applications. And the session will be chaired by Dr. Anand Solomon, the chairman of the chemistry department. And can I request Dr. Vishwanath to please take over?
Yes, sir.
Thank you.
Yeah, I now request Dr. Anand Solomon, Chairman, Department of Chemistry, to chair this session. Over to you, sir.
Anand?
Dr. Anand Solomon?
No.
Now, am I audible now?
Yes.
Yeah.
Very
Yes.
much.
Sorry.
Yes.
Good morning, everyone. The first speaker for this morning session is Professor B.V.N. Ramkumar, the chairman of Aerospace Engineering. He has his PhD from Indian Institute of Technology, Madras, and he has a total of 20 years of teaching, research, and industrial experience. His research areas of specialization include gas turbine heat transfer, turbo machinery, and computational fluid dynamics. Today, he will be speaking to us on cooling technologies used in gas turbines. Can I now invite Professor Ramkumar to deliver his talk? Professor Ramkumar.
Good morning. Thanks, Professor Anand, and thank you, the organizers, for giving me the opportunity. Today, I'm trying to explain something about my area of interest. That's the gas turbine cooling. Let me just share whether I can share my desk, Anand sir.
Yes, sir. You'll be.
Yeah. You're also a co-host, so you should be.
That option is there.
Yeah. Let's see. Okay. Hopefully, you're able to see.
Yes.
Yes, sir.
Yeah, it's visible, sir.
Okay.
Starting with conclusions.
Yes. Okay. Yeah. Thanks a lot. And once again, let me start my talk on the topic of cooling technologies used in the gas turbines. As you know, I'm representing the aerospace engineering, and the application what I'm speaking today is connected with the aerospace engineering. This is the overall content. I just want to, as we are all professors, so we want to give you something for the introduction for any topic. So I will try to spend some time about the introduction to the gas turbines. Then I will try to go to the need for cooling, then various cooling techniques used in the gas turbines. Beauty is initially technologies are developed for the gas turbines, but those technologies nowadays they are trying to use even for the laptops. So that kind of the technologies, cooling technologies, what we use. I will try to show some technologies. Then I just to show you the what my contributions in this topic. Then end up with the conclusions. Gas turbines. Gas turbines are kind of the power producing machines. They find very, very wide applications. The important application is the aero propulsion. You all know that engine for the aircrafts is the gas turbine. There are many kinds of the propulsion engines, variants I can say. Those are the turboprop, turbofan, turbojet, turboshaft, and some micro gas turbines. Though I'm not really covering all these things, but just to give you a flavor, I just thought of showing you these things. Apart from the aero propulsion, the important application is the power generation, land-based power generation. You all know that the steam power plants, apart from that, nowadays it's a combined cycle. In the combined cycle, people are going for the steam and gas turbines for the power generation. And the other application is in the marine, for the marine also, marine propulsion, marine, getting the power, people are using the gas turbines. And other even small applications like micro gas turbines, they are really used in the auxiliary power units, which are again in the aero applications. By seeing so many applications, we just want to see what are the great things for the gas turbine. Why people are preferring the gas turbines than the IC engines. There are some points here I just try to show you. This is very easy to generate the thrust, and we have the very high power to weight ratio. So that means for the same power, we have the lighter vehicles. So you always know propulsion for aero, it's very, very important. Weight should be as low as possible. It has the less frontal area, and apart from all these things, they have the high efficiencies compared to the other engines. And the other thing is regarding the maintenance, unplanned maintenance we avoid, many times we avoid. Okay, very few unplanned overalls. So these are the big benefits for the gas turbines. Here I just tried to show you the operation of a gas turbine. Gas turbine works on the principle of the Brayton cycle. This is the different components of the gas turbine. In the gas turbine, we have a fan which takes the air inside. Then we have a compressor. There, we compress the air, and the high pressure air is sent to the combustor. In the combustor, we supply the heat energy, and thereby you will get the very hot fluids. And that high pressure and high temperature fluids, combustor fuels, those will be sent to the turbine, where we extract the energy from these hot flue gases. And ultimately that flue gases goes through the exhaust, and where it is a kind of the nozzle, it gives you the high velocity jet. So thereby we will get the thrust. So basically the function of the turbine is rotate your compressors and the fan. And ultimately the hot air which is coming at the nozzle, that gives you the jet. That creates the jet, and that gives you the thrust. So the same thing we are trying to show on a cycle here, the thermodynamic cycle here. 1 to 2 is the compression, then 2 to 3 is the kind of the combustor chamber, constant pressure heating. Then the 3 to 4 is the expansion in the turbine. And 4 to 1, it's basically, again, it's coming to the process section. Okay, and so these are the, when you compare this with the ICE engines, more or less the same thing here. In ICE engines also, you will have the intake, then compression, combustion, and exhaust. More or less, operations are similar, but the equipment what we use are different. And ICE engines are very difficult for the balance and all. But the gas turbines, you have the very good balance because all are rotating components, and more or less they have the symmetry. So because of that, gas turbines has the very important applications in the aero. Again, this is the same thing what I mentioned here. We have a fan here, compressor here, then we have a combustor, then turbine, and hot fluids go here. The important parameters, performance parameters for any gas turbine, I just mentioned a few of the parameters here. One is like a specific thrust, second one is the specific fuel consumption, and the efficiency. You all know that for any engines, these are the kind of the parameters, performance parameters, key indicators. Specific thrust, as we know that we all, we need to get a thrust. Thrust is nothing but the forward motion, forward force, basically. So the thrust for the unit mass is called as the specific thrust. So we always look for the higher the specific thrust. We always try to design our engines to get the higher specific thrust. When it comes to the specific fuel consumption, it's like our petrol consumption or the diesel consumption for the our ICE engine. Same way here. Specific fuel consumption is nothing but the fuel consumed per unit thrust. So we need to look for the lower specific fuel consumption. So that's the penalty for us. So the lower the fuel we use, that's a good engine for us. So we need to look for the lower specific fuel consumption, SFC. Okay. Then other thing is efficiency. We all know that efficiency is a kind of the output to the input ratio. So for the same input, we try to get the more output. So efficiency, we want to try to increase. So these three important parameters, one is a specific thrust. We try to maximize that as much as possible. Next one is the fuel consumption. It's kind of the reciprocal of the first one. We need to look for the as small as possible. And the efficiency we want to try to increase. How do we do that? Yeah, this graph just show you the different pressures and the different temperatures, operating temperatures. And then you can see the SFC values. This is with the operating temperatures, 1200, 1400, 1600, and 1800. Just imagine the temperatures. Now the operating temperatures in the gas turbines are 1800 Kelvin. It's a really huge number. In the next slide, I will just show you. It's like lava, more than the lava temperature. You can just imagine the lava, how hot it will be. So the gas temperatures, what we are speaking in the gas turbines, are still hotter than the lava temperature. Okay, so we are trying to have the high temperatures and the high pressure ratios. In the compressor, we are looking for the high pressure ratios. With that, we will have the lower specific fuel. Basically, SFC values are the lower. So there are different developments happen. I'm not really giving the all the things, but just to mention here, pressure ratio, we always look for having the higher pressure ratios and the higher temperatures. Okay, and there are multiple ways to do that. And one way is looking for the cooled blades. I will just mention what it is. Okay, these are the primary requirements for the any engine material. Especially for the gas turbines, we need to have the high specific strength, creep resistance. Creep is very, very important factor for the gas turbines. They work with the different temperatures and they work with the rotation. So all that makes the very, very harsh environment for the gas turbine. So the materials what we select is it should have the creep resistance, high creep resistance, high corrosion resistance, then low density, high stiffness, good fabricability, low cost, reproducible performance. You all know that getting such kind of material is very, very difficult. Okay, and many times we need to compromise many things here. Here, I just wanted to show you the different materials what we use for the gas turbines. Fan blades, compressor vanes, combustor, turbine blade, disc and vanes, shafts, casings. These are the different components. And when it comes to the fan blades, nowadays people are going for the super plasticine formed titanium alloy, and now people are working with the composite materials, fan blades. Okay, and when it comes to the compressor vanes, they operate with the relatively high pressures and the temperatures. People use the nickel-based super alloys for the compressor vanes. Combustor, it is the hottest part in the entire turbine. So there we go for the very high temperature. We go for the to withstand that kind of the temperatures. We go for the nickel-based super alloys. Similarly, on the turbines blades, nickel-based super alloys we use, and the shafts and these things are relatively cool parts. There we go for the steel or aluminum, those things. Yeah, so the important thing here is nickel-based alloys. These are the best materials what we have, which meets our requirement. But the problem here is the creep resistance is 1000 degrees centigrade. So they can't, withstand the high temperatures, and they can't really withstand. They have the sufficient resistance to the creep if the temperature is more than 1000 degrees centigrade. Keep it in your mind. Even nickel-based super alloys, they can't really withstand more than 1000 degrees centigrade. And here again, different parts. I just try to show you the different materials. Titanium alloys for the fans, different colors, and I just try to show you the different materials here. And if you see, this we call that as the cold section, and this entire thing we call as the hot section. In the hot sections, temperatures are high, pressures are high, and you see these are the very red regions. Those are the non-corrosion resistance steel. Okay, here the hot sections. When it comes to the hot sections, high pressure compressors, turbines, combustor chamber, and the turbines, all these are the high temperature. So we are looking for the heat resisting and the refractory alloys now. Okay, so these I just tried to show you the harsh conditions which are shown in the earlier slides. The turbine blades operate at a higher 1600 degrees centigrade. So it's a kind of the, it's a very, very high, even it is hotter than your lava temperatures. And apart from that, we are looking for a service life of 10,000 to 20,000 hours. So it's a very big requirement. So we try to use the nickel base. That's the best alloy what we have in the present days. And then when it comes to the manufacturing point of view, we always look for the single crystal. That's the blades will be cast with the single crystal alloys. Manufacturing, while making manufacturing, we try to go for the single crystal. And apart from these things, the third one is a very important thing what I'm trying to explain. These are to be cooled to allow the increase in temperature. Why we need cooling? Basically, all these materials can withstand 1000 degrees centigrade, but our operating temperatures are 1600 degrees centigrade. So to protect our materials, we need cooling. We need to maintain the blade temperatures below the 1000 degrees centigrade. Okay, and apart from that, the other technique people use is the using the coatings. We call them as the thermal barrier coatings. So that's the another way of looking. Okay, still people are working for the new materials which can withstand all these things without any difficulty, but still that day is very far. Okay, these are the different operating temperatures, and with the year how it's a progress I try to show here. If you don't use any cooling system, now my operating temperature will be something like 1100 degrees centigrade. Beyond that you can't go. But 1100 degrees centigrade, if you operate, your efficiencies are low. Then cooling system got introduced, and with that cooling, I will try to explain to you something about the cooling. Film cooling and the other cooling techniques. Now we increased the operating temperature to around 1300. Then we use the thermal barrier coatings. With cooling and thermal barrier coatings, now we are capable to go for the operating temperatures of 1500 degrees centigrade. And down the line, CMCs, people are trying, and if we are successful with that, it's ceramic materials basically. So they are trying to go for the still higher temperatures. As I mentioned, we always look for the high pressures and high temperatures to get the more efficiency. Okay, now cooling, as I mentioned, the important thing is we need to protect our material. The outside temperature is 1600, but our blade can withstand 1000 degrees centigrade. So we need to, in order to protect the material, blades or anything, to avoid the burning, so we need to maintain the surface temperatures of these things to 1000 degrees centigrade. How do we do that? We call that as a blade cooling technology. In the blade cooling technology, what we do is we take some air from the compressor and we try to send this air through the different components. Here you have a turbine stator, and this is the turbine rotor. Okay, basically, even though we are saying cooling, cooling doesn't mean that it's minus temperatures. It's not that way. In the heat transfer, it's always relative terms. Operating temperature is 1600, and the temperatures what we take from the compressor is around 800 degrees centigrade. So that's why we call that as the cooling. So temperature is you have a temperature difference. There are different techniques for the cooling. Internal cooling and the external cooling. In the internal cooling, there are a lot of new methods have come up: impingement cooling, convection cooling. And in the external cooling, we have the film cooling, effusion cooling. The cooling, what I am saying is, to just give you a typical size. Typical size of a turbine blade is a kind of the 1.5 inch. So this entire size is something like a high pressure turbine. I'm just saying. It's a kind of the 1.5 to 2 inch. Within that, you will see a lot of intricate cooling we provide. So this is the again turbine entry temperature, how it is changing with the different cooling techniques. Yeah, and when it comes to the cooling, first one is the impingement cooling. In the impingement cooling, what we do is we keep a impingement tube and we supply the cooling air here. And this tube will have a orifices here. So what happens is as the cooling, just before saying, all the blades, whatever we are using in the turbine blades, a kind of the hollow blades, you can just see here. It has a very small thickness, and inside the space, we try to use for the arranging the cooling. Okay, so this is the one type of cooling is the jet impingement cooling. And we will have a insert here, and we will send the cooling air here. As the cooling air goes, that air comes inside and impinges here. So it forms a jet here. So this is the just I try to show you. So that jet will come and hits the surface. Okay, so this is called impingement cooling. Okay, there are different regions. I don't want to mention. Give the entire details here. You can contact me for any further discussion. And here, the beauty of impingement jet is you will have the very high heat transfer where it is impacting or impinging. So you are sending the cool air and treat this is your blade surface, and it hits here. So the place where it hits, you will have the very high heat transfer rates. Okay, that's what you can see. These are the peaks. So if you have the multiple jets, you will have the multiple heat transfer rates. These are the jet locations. You can see the jet locations, you will have the very high Nusselt numbers, that means very high heat transfer coefficients. And in impingement systems, the people have come up with the different configurations. Some people tried with the round jet, then slot jet. Instead of the single jet, people tried for the multiple jets, and then different surfaces, concave surface, convex surface. So people have tried with all these systems. I'm fortunate, I worked on all these systems, single jet, multiple jets, and the jet impinging on the kind of the concave surface. I did all my experiments on that. During my PhD, I did both experiments and simulations for the jet impingement. And the other part is the having a turbulator here. Turbulator, you can just see here, this is a blade, turbine blade, and inside you will provide some projected surfaces. Those are called as the turbulators. To just give you a small analogy, it's like you are on the road, you will have the humps now. The same way you will have the turbulators here. What do we use here? Thing is, when you have the flow, then what it happens is whenever there is a a stoppage, then what happens? The fluid gets separated, and you will have the boundary layer here. So this boundary layer you need to break and rearrange. So by playing with the boundary layer, you can increase the high heat transfer rates. So turbulator is another way of reducing the temperatures. So basically what it does, it increases the surface area, it creates the turbulence. You always know that something is getting separated and you will have a turbulence here. Higher the turbulence, the better for the heat transfer. But keep in your mind, whenever there is a turbulence, it also have the penalty on the pressure. So we need to have a kind of the balance between the pressure and the heat transfer rates.
Sorry to interrupt, sir.
Yeah.
So could you please complete it soon, because we are running out of time.
Oh, sorry. Yeah, 5 minutes more. Yeah, there are different other turbulator arrangements. People started with the straight one, then people tried with the inclined one. Then they tried with the different configurations here. This is a straight, but this is the cut one, and here is a kind of the V type. So there are so many configurations people have tried on that. And apart from that, people also have tried with the serpentine passages. So again, I'm not giving the complete information, but only thing is serpentine passages means it goes like this, then it takes the turn. So these are, it's very, very complicated system used in the blades. And as I mentioned, the size is a kind of the 1.5 inch to 2 inch. Within that, you need to keep so many the complex geometries. And the other technique is the film cooling. Film cooling, you will have the films here. So whatever the air comes in, and that goes to these films, and it will create a blanket. So it's something like this. So jet comes like this, and it creates a blanket, and that is called as a film. So here you have the high temperatures, but you have the low temperature here. Thereby you can protect the surface here. And again, there are so many shapes for the film cooling. I'm not trying to give all the information. The other part is the turbine, thermal barrier coatings. Zirconium-based coatings are widely used for the gas turbine. This is the substrate, and this is the coating. In between, you will have the bond coat, and this is a film cooling. Okay, I just give 2 minutes. I will take more. This is the patent we submitted on the turbulators when I was working with Honeywell. I did that work actually. This is a US patent, and yeah, it's basically what we did is we came with the new turbulator design, lifted the turbulators, we said. So this helped us in getting the reducing the penalty on the pressure. You have the high temperature, high heat transfer rates, but lower lower pressures. And we also have made some defensive publication. And again, it's from the Honeywell. It is in between the kind of the general publication and the patent. So to protect our knowledge, this is another means of protecting our IP, defensive publication. And apart from that, there are so many publications. I'm not really going through all that, but this is my Google Scholar. You can go through that. Okay, so yeah, with that, I'm trying to close that. Just to conclude that gas turbines operate very, very high temperatures and pressures. So in order to protect the materials, we need the complex cooling systems. Otherwise, no material can withstand that much temperatures. So there are different techniques used: impingement cooling, tabulator cooling, pin-fin cooling, film cooling. There are many techniques that are getting used. And in addition to that, people are using the thermal barrier coatings. And down the line, the new innovations are coming up with the different shapes of the film holes, lattice work cooling, mist cooling. This is the multi-phase cooling. So yeah, with that, yeah, I can close my presentation. And if you have any questions, I'm happy to take 1-2 questions.
Vishwanath, I think in view of the time,
Yes, sir.
we need to just proceed to the next one.
Okay, sir. Thanks a lot. Once again, thanks for giving me the opportunity.
Thank you, Professor Ram.
Vishwanath, just 1 second. I just want to make an announcement. I request all our faculty colleagues to please come to the puja after the presentation of Dr. Ashok. Right? Next is Dr. Ashok, right?
Yes, sir.
Okay. After his presentation, I request everybody to come there. In half an hour, we'll finish the puja, and then we'll get back to the symposium again. Thank you so much.
Thank you, Professor Ram Kumar, for the educative and informative talk. Our next speaker for this session is Dr. Ashoka from Department of Chemistry. He had his PhD degree from Bangalore University, and he has 2 postdocs abroad. And his research area of specialization is materials electrochemistry, energy storage and conversion, and electrochemical sensors. He has a DST SCRB funded project and a VGST funded projects. And I now invite Professor Ashok to deliver a talk on development of high performance nanostructured non-precious metal oxides for water electrolysis. Dr. Ashok.
Thank you, sir. Am I audible?
Yes, you are audible.
Yeah, thank you. So I need to share my screen. Yeah, good morning to all present here. So I'll be talking about nanostructured non-precious metal oxide for water electrolysis. Probably, before going to that, I work on material electrochemistry. We have a small lab in SY campus where we look mainly on the energy storage, where we look lithium ion, sodium ion battery, and also multivalent batteries and electrochemical sensor. This we generally look for mostly look for an IV metal ion sensor in aqueous samples, and also a biomolecular sensor. And the final one is energy conversion, where we work on hydrogen generation through water electrolysis. And thanks to SCRB, VGST, and DSU for financial support to set up this lab in this campus. So probably this is the right picture. You can see routinely we see in Delhi. This may be due to the people say crop burning, but additionally, this also due to the excess use of fossil fuels. I mean, petroleum or diesel fuels. What we use in the this petroleum or diesel fuels in our vehicles, that liberates or releases a lot of greenhouse effects, such as carbon dioxide, carbon monoxide, oxides of nitrogen, and oxides of sulfurs. And these greenhouse gases ultimately leads to the what we call a global warming, and in turn, it is a climate change. Then maybe with this is the one impact of the use of this fossil fuel. The other impact is it may deplete in future. I mean, it may no longer available probably later. So what is the alternative? So if you look this way, there is a recent press release by DST. They surveyed some of the things where the emission of carbon monoxide into the atmosphere largely comes from the power sector, maybe a coal burning, and a few extent it is from the industries, and also the third it is from the transportation. And if you look at the NOx emission, that is the oxides of nitrogen, majorly from the transport, that is from the vehicles, and next to that is the power. And similarly, SOx, it's from the again power plants. So what is the alternative? If you look this, probably people are looking now carbon-free fuels like carbon dioxide emission, zero carbon dioxide emission fuels. Where if you look probably hydrogen. This is the one table which gives you the importance of this hydrogen fuel over natural carbon-based fuels like natural gas, petrol, or coal, or wood. Okay, so look at here, 142 is the highest number compared to this, whatever the specific energy we get from the hydrogen fuel. And these are the two slides which tells you maybe advantages and uses of this hydrogen fuel. So what we interested is maybe in the transportation, at least for the transportation, can we use this hydrogen as a fuel? Yes, generally this hydrogen we use in the transportation, probably it works based on the fuel cell. In fuel cell, what we do, we have an anode and cathode, and to the anode and cathode we passes hydrogen and oxygen and at the two ends. Then ultimately there is a redox reaction which releases a lot of energy. That energy will be used to run the vehicles. But problem is that what are the sources of this hydrogen? Yes, hydrogen is a good fuel, but how do you produce this hydrogen? If you look at the literature, most of the hydrogen produced from a carbon-based fuels like reformation of methane, or burning of steam burning of methane, or coal gasification, or partial oxidation of hydrocarbons. Don't look this these reactions. Maybe you may not much familiar because audience are most of them from engineer background. So what I wanted to convey is most of these carbon-based fuels, what they do, they burn at high temperature, maybe 700 to 1000 degrees centigrade in presence of oxygen and a steam. So the product you look is carbon monoxide, carbon dioxide, and hydrogen. Whatever the hydrogen you are getting from this burning may not be pure hydrogen. And secondly, we are releasing a lot of greenhouse gases into the atmosphere. So what is the alternative to produce a pure hydrogen without any greenhouse gases? So there are two methods. The one is a photocatalytic water splitting. Here what we do, they take a photocatalyst and put it in the water, then they expose to the UV radiation or maybe a sunlight. That the sunlight will absorb by your photocatalyst, that will decompose water into hydrogen and oxygen. This is the one way, but this is again a seasonal dependent, and it is not that effective because there is a rapid recombination of the electron holes. Then the performance is not that good. Whereas the other one is electrochemical water splitting. It is simple. We take an anode and cathode, and the active material will be coated on the anode and cathode. Then you apply a little potential. That potential will break, the applied potential will break the water into hydrogen at cathode and oxygen at anode. That's what we call it as an OER, oxygen liberation. At anode, we call it as oxygen evolution reaction, and hydrogen liberate at anode, we call it as hydrogen evolution reaction. This is at cathode. If you look at the literature, 48% of hydrogen produced from natural gases, 30% from the oils, and 18% from the coal, but only 4% from the chemical water splitting or electrolysis of water. This is mainly because of the lack of the efficient catalyst. If you look at the catalyst, it is well reported that a precious metal like iridium and ruthenium. It's not ruthenium, it is a rhodium. Rhodium oxides are well established catalysts for oxygen evolution reaction. But problem is that these are the precious metals and the scarcity and high cost, and it is not suitable for the long-term application. I mean, it is catalytically unstable after a certain time. So because of these drawbacks of the well-established catalyst, people are looking non-precious metals like cobalt, nickel, iron, and manganese. Yes, this cobalt iron, nickel, or manganese oxide-based catalysts are a very good catalyst for both OER and HER reactions. But problem associated with this oxide metal catalysts are lack of conductivity. If you look at electrochemical reaction, generally the electrochemical reaction happens on the surface of the electrode. And if the active material, this is the gray line indicates the current collector, these particles indicates the active material. So when we coat this active material on the surface of the electrode, what happens? Then we immerse this into a water solution. Then we apply a potential. If this material is not a good conductor, then there won't be a charge transfer. Because the overall electrochemical performance is depending upon the charge transfer between your electrode, that is current collector, and the electroactive material. So because of this nickel oxide, you take manganese oxide, they have very good active sites to split water, but the problem is the conductivity. So what people did to increase the conductivity, they're trying to coat some kind of conducting polymers inside that, and making some kind of composites with a carbon nanotube and composites with a graphene oxide or graphene, whatever, graphene oxide. And also people tried with a transient metal doping to enhance the conductivity of the active material to get a better performance with respect to water oxidation. But problem is that whatever the method here they're developing, if you yesterday Bashal was talking about graphene or graphene oxide, to prepare this graphene oxide, people spending 7 to 8 days just to prepare it, then separation, drying, it takes almost 10 to 15 days. And second thing is, it is a physical mixing. They're not growing as a from the solution. It is physically mixing. When we do a physical mixing, it is not homogeneous. Then when it is not homogeneous, the performance is not reliable or reproducible. So when we look all these problems, what I thought, can we do some kind of prepare some kind of synthetic protocol which gives the homogeneous distribution of this kind of conducting material in the metal oxides? In that direction, what we tried, we have used the solution combustion synthesis. It's a very simple method. It works on propellant chemistry. What they do, they take oxidizer and they take a reducer, they mix it. When they mix it, there will be a redox reaction which releases a lot of heat. That heat will be used for whatever the process we required. So generally we use here metal nitrates as an oxidizer and organic fuels as an reducer. When I mix these two and put it at probably 500 degrees centigrade, I'll get a metal oxide. But what we did, this is a routine way of synthesizing the material using this method. But what happens, people use this, keeping in at 500 degrees centigrade or 6, whatever the temperature, it depends depending upon the material, for a long time, like half an hour, 1 hour, 2 hours, just to get rid of all the carbon and to get a pure nanostructured or nanoparticles of metal oxide. But what we thought, can we arrest this reaction maybe in between some time, maybe a 4 minute, 5 minute, or maybe a 10 minute, so that we can have some kind of carbon-based material inside that. So that way, I think I'll just show you the video. What we did, maybe let me mute it. This is the basically a simple manganese nitrate or maybe a cobalt nitrate we took. We took both, of course, but here we are talking about a cobalt nitrate and a small amount of citric acid with a calculated amount. We put it at 500 degrees. After mixing homogeneous, we put it at 500 degrees centigrade. What will happen? Initially, the water will evaporate. Then there is a gel formation. That gel will occupy. I'll just show you. I'll just move this to a little. Let it go. Let it go. Yeah. Once all the water evaporates, the slowly you can see the formation of gel on the surface. It will expand to the whole beaker. Then it will expand to the whole beaker. Okay, it occupies whole beaker. Then what happens? The people leave it in the oven for an hours together to get rid of all the carbon. What I did, after 4 minutes, I just take it out. I just took it out because my intention is to enhance the conductivity of the material by retaining some kind of conducting carbon, whether I can get it. So that way, I just take it out 4 minutes. Then I characterize this material. So where You see, if you look, this is the material. The hexagonal indicates that it is a graphene kind of material, basically a conducting carbon. We call it as an, or you can call it as a graphene oxide. Then on which our cobalt oxide is anchored. So the proper bonding between this cobalt oxide with the graphene oxide, the overall conductivity of the material is increases. And additionally, when I disperse this in the water, we'll get a kind of suspension and clear dispersion so that it will be used for preparing the electrode. So once we prepare this, I mean, I just wanted to, these are the two graphs. This is the one IR and this is the one Raman spectra indicates the presence of this graphite carbon. These are the two peaks related to the graphite carbon. And these are the transmission electron microscope image of the cobalt oxide. Look at this. This is graphene oxide and these are the cobalt oxide. But that means the cobalt oxide particles are completely anchored on the surface of the graphene oxide. Thereby, there will be a good electrical wiring between the cobalt oxide and the graphite, conducting graphite that ultimately enhances the conductivity. After preparing this material, what we did, we took that material, as I said previously, we put it in a water and we disperse it. And generally people use kind of glassy carbon electrode or nickel foam or stainless steel foam kind of things to prepare this electrode. What we did, those are the very expensive. So what I thought of using a kind of compact and simple electrode, which is composed of working electrode, reference electrode, and the counter electrode. If you look at it, this is we call it as a screen printed electrode. The gray line indicates the reference electrode, and this is the counter electrode. The middle block circle indicates working electrode, on which we have drop tested our synthesized material ink actually. Then we dried for an 30 minutes to 40 minutes to get a proper adhesion on the electrode surface. Then the added modified electrode is put in a water, connected to the electrochemical workstation. There we applied potential and measure the current. Look at here. This is the graph indicates the water splitting reaction. This is the graph against potential. So look at here, till it is a flat. That means there is no oxidation or reduction reaction. There is no water splitting. Then there is a sudden increase in the current. This sudden increase in the current indicates it is YR reaction. Basically, if I go for a negative direction, it gives an HAR reactions. Okay, and this is the performance of the electrode. As I said earlier, I used to say, I said the conductivity of the material enhances. This is the charge transfer resistance against this material. This is what bulk material, which showing around 868, and the nano cobalt oxide it is about 325, and the graphite carbon modified cobalt oxide showing 143 ohm. Generally, the lesser the resistance, higher the performance towards water splitting. And this is the over potential. Lesser the over potential, higher will be the water splitting performance. And look at here, the higher performance of our graphite carbon or modified cobalt oxide is due to the one is the lower resistance and other one is the high surface area. So this is a small piece of work we published in International Journal of Hydrogen Energy recently in the last month, and this is else for publications. This is this piece of work. And finally, this is the guy Srinivas and Srinivas Sagar. These are the three PhD students working with me, and he is the guy who is working on water splitting reaction. And thanks to Craigie Banks and Samuel from Manchester Metropolitan University, they're providing me a lot of help. With respect to the characterization and also the screen printed electrode. In fact, they supplied actually. So with this, I think I'll conclude my work. So thank you very much for your kind attention. I can happily take any questions related to my presentation.
Okay, if there are no questions, we will thank Dr. Ashok for his sharing his research experience and output. And we conclude this session now, and we shall adjourn for the Ayudha Puja celebration. We'll meet once again after the celebration is over to continue the session.
I thank Dr. Anand Solomon, Chairman, Department of Chemistry, for chairing the session. We'll be back with the session 3 at 11:45 a.m. 11:45 we'll log in again. Thank you.
Madam, after vehicle कैसे मैडम?
यहाँ पे पूजा है।
हाँ अभी मैं बता दूंगा उस पूजा के बाद।
अभी नहीं है क्या?
अभी थोड़ी देर में 5 मिनट में 5-10
हम
मिनट
लोग वहीं
में।
पर
कैसे मैडम आप? मैडम एक मिनट, कल पहुंचे थे ना बराबर घर? मुझे बहुत खुशी है। अरे भाई मैंने नहीं देखी थी लाइफ। आप बराबर पहुंचे ना? अरे बाप रे मुझे बहुत डर लग रहा था।
मुझे कुछ डर लग रहा था, चिल्लाते हो।
देखो एसी ऑन कर दिया था ना?
हाँ ये ठीक है, वो बताया नहीं तो हम वो चल जाता ना।
टेक केयर मैम, ध्यान रखिए।
Welcome back. I now request Dr. Ram Kumar, Chairman, Department of Aerospace Engineering, to chair this session. The theme of this session is Advances in Interdisciplinary Research. Dr. Ram Kumar, sir.
Yeah. Good morning. Once again, welcome. Now we have getting into the second session for today. We have a total 6 presentations in this session. We have Dr. Sarvana Bhavan from Mechanical Engineering. Then the second presentation from the Dr. Viraj Kumar from Department of Computer Science and Engineering. Third one is from the Komala, Dr. Komala. Next one is Dr. Surya Narayana from Aerospace Engineering. Then we have the Dr. Amarnain Srinivas from the Chemistry and Dr. Deepika from Mathematics. Let us start with our sessions with Dr. Sarvana Bhavan. Dr. Sarvana Bhavan, he is working with mechanical engineering in our School of Engineering. He has total years of experience, 14 years of experience. It includes research and the academic experience. He received his PhD from NIT Surathkal, National Institute of Technology, Surathkal. And his present research areas include manufacturing science, composites. Basically, he works more on the composites, then 3D printing and powder technology. It's a great pleasure inviting him for the today's session. Dr. Sarvana?
Yes, sir.
Yeah. His talk is on the recent development in the natural fiber composites. Thank you. It's over to Sarvana, Dr. Sarvana.
Yeah. Thank you, sir. Thank you, sir. I thank the organizer team for giving me an opportunity in giving a brief talk on my topic. My specialization was in the area of natural fiber composites. I had did my work in PhD in natural fiber composites in the NIT Surat. So I will be giving a glance view on the recent development in natural fiber composites. What are the recent applications in natural fiber composites, and what we can do in this natural fiber composites. So this is my just abstract, simple view. Natural fiber composites do have a great demand in recent years because of the wide applications of composite in resource sectors, ranging from automotive, structural, and building materials. Properties such as low specific weight, relatively high strength, biodegradable, and low production cost are in favor for these natural fiber composites. Yes, of course, it has some disadvantages, which has moisture control, hot absorption, and processing temperature. But this can be minimized by restructuring the chemical treatment with natural fibers. The major challenge of the fiber is to improve the matrix fiber interface addition and to have a good property of interface addition. Apart from this, natural fiber composites are environment friendly, sustainable, and do have physical and mechanical properties compared to man-made fibers. So this is a general view of the composite materials. Composite materials have wide applications in aerospace, then water turbines, in sports and other manufacturing sectors. Just give a glance view of composite materials. What are composite materials? These are materials made from two or more constituent materials that remain separate and are distinct while forming a single component. Example, in the figure you have seen the glass fibers mixed into polymer resin to have a good fiber matrix interface. This is how what is the composite concept. All you need is a matrix and a fiber. Matrix can be a thermoset polymer or thermopolymer or a metal matrix or a polymer matrix. Fibers, you have different kind of fibers: man-made fibers, carbon fibers, then again natural fibers, glass fibers. And when you mix this thing and you have a suitable reinforcement and manufacturing by different kind of methods like hand layer, pultrusion, filament winding, you can produce a composite. So this is just a view of a composite. It can be classified into particle reinforced, fiber reinforced, and structural. I'm focusing more on structural composites. Structural composites in the form of laminates or sandwich panels. So this is again the reinforcement material. Reinforced material should have a high stiffness and strength. It will have a good particle shape, and it will also preserve the desirable properties of polymer matrix. The reinforcement in man-made fibers can be a glass fiber, carbon fibers, and aramid fibers. Now you have a boron fibers or polyethylene fibers. This is how the alignment can be dispersed or arranged. It can be laminated by applying 0, 30, 60, 45 degree. Just keep. And these are some of the production of producing the fabrication of composites by vacuum assisted resistant transfer molding. It can be done by hand layer or a pultrusion method or a compression molding. I focus more on VATM, vacuum assisted resist transfer molding. I did work on hand layer also and compression molding. These are most three prominently used upcoming production methods of composites. Natural fibers are promptly consist of cellulose, hemicellulose, and lignin. It can be a leaf fibers or a bast fibers or seed fibers or else from the fruit fibers. Apart from these plant fibers, it can be also done by animal fibers such as chicken feathers and other things. The importance of these natural fibers are that they do exhibit good high tensile strength and stiffness. And why so much interest in natural fiber composites is that they are green, they are sustainable. Sustainable means these natural fibers can be renewed, and they do have net negative greenhouse gas emissions and improve the properties of plastic, and the last one, the low cost, and which are easily available. Natural fibers can be classified in majority in two types: animal fibers and mineral fibers. And these are very rare to do, but we focused my research focused on vegetable fibers. I've done more work on vegetable fibers, which includes bast fiber, leaf fiber, seed fiber, or grass stem fibers. These are the importance of these vegetable fibers are they're easily available, and the processing of these fibers is also very easy to get the fibers. So you do have some of the photos with the fibers are being shown here. You have a hemp fiber, sisal fiber, coconut coir fiber, and other fibers. Apart from this, you can see the cellulose percentage of these fibers with sisal, abaca, banana, pineapple, rami, hemp. Rami hemp, although are not Indian fibers, they do exist mostly in European countries. But jute, cotton, sisal, we do have a lot of these prominent fibers which can be done. Lot of work can be focused on these fibers in getting a composite material. Coming to the mechanical and physical properties of these fibers, you can see the jute fibers, they do have a tensile strength of 393 to 800 MPa with Young's modulus of 13 to 26.5. Much of the work was focused on jute fibers and coconut fibers. Coconut fibers do have a tensile strength of 140 to 225 MPa with Young's modulus of 3 to 5 GPa. So seeing these properties, mechanical properties, it can be said that they are almost equivalent to man-made fibers, example of carbon fibers and the glass fibers. They can also compete in industrial sectors like automotive sectors or as sports or other sectors of industries. So apart from this, you can see the difference between the natural fiber to synthetic fiber. Natural fibers are biodegradable with a low density at price. Whereas the synthetic fibers, they have the advantage of moisture resistance and good mechanical properties. But coming to disadvantages of natural fibers, you can see that natural fibers, they do have a inhomogeneous quality and a dimensional instability. Synthetic fibers, they are difficult to recycle and relatively high price. Apart from that, you can see some of the typical properties of these bast fibers compared to glass fibers. This table shows a comparison between the existing man-made fibers to the natural fibers. You can see the properties of density. Density plays an important role here, which is widely appreciable. Where when compared to E modulus or tensile strength, quite appreciable compared to the man-made fibers or traditional fibers. Now coming to the cross section of these fibers, you do have a primarily three layers. The primary layer, secondary layer, and tertiary layer. With the plant fibers, it can be either a bast fiber, a stem fiber, or other three fibers. You can see the most components of these fibers consist of the cellulose, pectins, hemicellulose, lignins, and wax. Okay, and if you try to remove out some part of the waxes and other things by some chemical treatment, it can be a good fiber material. Because plant fibers have a lot of moisture absorption and water swelling characteristics. But if we go to remove this chemical treatment of these fibers, I think so much of the things can be minimized. Water swelling characteristics or the moisture absorption characteristics can be minimized with chemical treatment of these fibers. Apart from this, we work more on biocomposites also. Biocomposites, it can be degradable easily. Okay, it can be a partial biocomposite or the fully biocomposites. Fully biocomposites such as green fibers, which are the elements of renewable fibers, and partly biocomposites are man-made fibers, little bit synthetic with the biopolymer in it. Again, the reinforcement can be a particles. These fibers can be a particles or a fiber, which are continuous chop or chop, and the alignment can be made either 1D or 2D woven structure or non-woven structure. So we did work on ISO standards. Based upon the ISO standards, some of the work have been carried out with bio-based, biodegradable, and compostable kind of fibers. So some of the chemical treatments, of course, you have to do with chemical treatments on these fibers. Some of the chemical treatments such as alkali treatment, acetylation treatment, benzolation treatment, enzyme treatment, grafting methods, isocyanate, mercerization, silane, sodium chloride. These are some of the most prominently used chemical treatments for these natural fibers. I don't know because we have to remove some of the portion to make it good wetting to the matrix. Okay, henceforth, these chemical treatments have been carried out. Example, if you do alkali treatment, they can reduce the lignin content. If you do acetation treatment, it can improve the tensile and frictional strength. If you do benzolization, it can improve hydrophobicity. Likewise, heat treatment has their own specific thing to modify the fiber structure. And again, this treatment depends upon the cost or what type of cost you're putting it to get it done. The most commercial one is the alkali one because of it is of low cost and it do have some good fiber matrix adhesion and thermal stability and heat resistivity. So applications of these natural fiber composites, it can be in marine structure, automotive, aerospace, and other applications. This is the fiber taken from hemp fiber, done by the other researchers. These hemp fibers are mostly used in automotive sectors, interior parts of automotive sectors. These are the fibers used. Apart from automotive sectors, you can see each fibers have they play a role, an important role in automotive sectors like abaca, banana, coconut, cotton, flax, sisal. Much of the fibers are being used in interior part of the automotive sector, like soundproofing, insulation, plastic retainer, body panels, and door panels. So this is again a graph chart showing the production of vegetable fibers by each country. In the graph, you can see that China is playing a major role. Almost 29% of the fibers are being done by these Chinese people. Then India's contribution to natural fibers are 9%, with Bangladesh 14%. So these are some of the countries playing a major role of production of natural fibers in making composite. Apart from these natural fibers, we can use these natural fibers in other applications such as containers, boxes, racing bicycle, musical instruments, winter sports, mobile phone casing, and of course nowadays these natural fibers are used in house construction. In much of the European countries such as Canada or other France or other European countries, they do construct most of the house in wood, having a good stability. So natural fibers, again we have different applications. I told, just skip it out. Okay, then these natural fibers, why it's so important? Because they do have reduced carbon dioxide footprint, and it is greenable, renewable, eco-friendly, sustainable. Again, this is one of the slides showing on the different applications of natural fibers by biopackaging product, cardboard, nylon, then roof made from bamboo, and the other interior parts of automotive. Apart from this, natural fibers can also go for cellulose nanofibers. You can make fibers, cellulose of nanofibers from natural fibers. You can make fibers powder, then do alkaline treatment and do some bleaching action, then combine again alkaline treatment with bleaching action, do acid hydrolysis treatment. When you do this kind of treatment, at the last, you can get cellulose nanofibers. So nowadays, much work is focused on cellulose nanofibers. Again, these natural fibers can also be good in water treatment, nanocomposites for water treatment. You can use nanocomposites from fibers from plant for water treatment. Much of the work is also going on there. Again,
Professor Sarvana,
yes,
if
sir.
you don't mind, can you just speed up?
Yeah. I'll just come to my work. Okay. So what I've done is I've taken some. These are the few work done here in our college in DSU, and much of the MTech students or PhD students have done this. So what they did, they have taken the vetiver fiber mixed with polymer, epoxy, then processed it, and they formed a material, and they did the tensile and degradation analysis. So this is the fiber taken out. They have made these fibers the hand lab technique and vacuum assisted resin transfer molding. And then they did chemical treatments. You can see the raw fibers and chemical treated fibers. The Young's models of raw fibers is 0.8, whereas chemical treatment is 0.9. This clearly shows that of course you have to go for chemical treatment of these fibers to get better mechanical strength. And this is some of the graphs again showing the flexural property of these fibers with the raw and chemical treatment. You can see the maximum flexural modulus is 1.1 for raw, and chemical treatment is 1.2. Good GPA. And the thermal degradation analysis, again we have done thermal degradation by using TGA technique. For vetiver fiber, we did for two types of degradation: initial degradation and secondary degradation. Much of the components are removed by primary degradation, and secondary degradation. What happened? More complicated parts are removed, and the maximum temperature for raw fiber is 52 centigrade, and the chemical treatment is 69 degrees centigrade. Okay, this is again the fibers showing the picture of the fibers done, and with the different percentage of 2%, 4%, 6%. Okay, and again we have done bending test. Much of this work are carried in DS itself. So this is the much you can see the tensile, the bending strength. For two, this is the first one is a 2%, the second one is a 4%, the third one is 6%. The 4% was a good one to show. And the comparison graph for 2, 6, and 8. Okay, this is for sandwich computers. I have told no, we worked on the structured applications. We did for laminate and also for sandwich samples. So this is again graph showing the compression strength for different samples from 2, 4, 6, 8%. So coming to a conclusion, I can say that these materials are new materials. They do have a good transition to across the world to obtain new kind of material. They are strong, lightweight, and effective method to meet standards and other restrictions. And apart from that, these are some of our reference. Green. So thank you all for your some work I've done on biocomposites. I'll let you show some SCM on biocomposites with polylactic acid, PLA. These are some of the work. It's still going on with biocomposites and with PLA and PP, polypropylene and polylactic acid. Some of the work is still going on. I'll just put some minor results on biocomposite materials. So with this, I thank the convener and the team for giving me the opportunity in presenting my work in natural fiber composites. Thank you.
Oh, thank you, Professor Sarvana.
Yes, sir.
If there are any quick questions, maybe one or two, probably we can allow. Any quick questions you have? Maybe you can unmute yourself and raise a question, one or two. Yeah, anyhow, you can meet Professor Sarvana and have a discussion, further discussions on that in view of the time. Then I didn't really hear anyone about the question. I will stop then. Thanks, Professor Sarvana. You covered in a short time, you covered a lot, many things. You started with the introduction, then classifications, and then you covered the fabrication, and you also mentioned about your works. Thanks a lot and keep doing a great job.
Thank you, sir.
Thanks
a
lot.
Sir. Thank you, sir. Thank you.
Yeah, the next lecture is from Professor Viraj Kumar. It's a great honor for me to introduce Viraj Kumar to the today's session. Dr. Viraj Kumar is a research professor in the Department of Computer Science and Engineering in our DSU. His primary research interests are in educational technology and the computer science education. Prior to joining DSU, Dr. Viraj Kumar was a visiting professor at IISc Bangalore during 2018 to 2020, where he continues to teach undergraduate computer science courses. He was invited to serve on 2 task groups of the Karnataka Knowledge Commission in 2014 and 2016, and then 2017. In 2017, he served as the consultant to the committee to draft the National Education Policy 2020. We all know about the implementation of the 2020. It's a great honor to him. Since 2015, Dr. Viraj Kumar has been an active contributor to ACM India and was elected to ACM India Council in 2020. It's a short introduction, but yeah, we will spend more time on his presentation. Welcome, sir, Dr. Viraj Kumar. Over to you.
Thank you so much. Thank you so much. Thank you to the organizers of Deshmukh, the whole team that's responsible for putting this together. Thank you, and it's very nice to be with you here today. I have a very short presentation because I would like to spend as much of my time discussing the implications of this work. In particular, I'm hoping that there are many collaborations we can start through this, and I'm actually very actively looking for partners in this space. So I just want to very briefly tell you what this is. So as the subtitle of this talk is, conveying instructor intent to students. So it's about education. So what do I mean by instructor intent? I'll give you an example, right? So this is an example from an actual course. I was teaching a course in theory of computing. I know not everyone here is a computer scientist, so I will briefly explain what the technical meaning of the question I gave as a homework problem was. But basically, I think all of us, will have this kind of situation in our teaching where, we are asking our students to essentially do some kind of a creative design thing. In this case, I was asking them to design a particular kind of a machine called a deterministic finite automaton. And just to help you understand precisely, what this is. So this is like a machine that will be able to accept certain kinds of inputs, right? So these inputs in this case are very simplistic. They're just some sequence of zeros and ones. So binary strings, and this is what one of these machines looks like. So for this particular question that I asked my students to solve as a homework problem in an undergraduate course, this was the diagram I was expecting them to come up with. So this is the skill that I was teaching, right? And obviously there are similar skills in other domains, design a circuit that has these properties, design a function that has these properties, all kinds of problems where we are asking students to design something that meets a certain specification. So just to briefly show you what these things actually look like. So each of these circles is called a state, and then the circle with the triangle next to it, the leftmost one, is the starting state. So we start from that state and we read a 1 and we jump from state Q0 to Q1, and we read a 0 and we jump from Q1 to Q2. And so you can see that, as this machine starts off at state Q0 and it reads a sequence of zeros and ones, it jumps around from state to state. And if it ever reaches a state which has a double circle, which in this diagram is only state Q0, then we say that it has accepted the input, right? So the question I had asked my students to do in this particular course was design a machine which accepts, these sequence of zeros and ones where every one is followed by 2 consecutive zeros, right? And this is a very typical type of problem in this course, right? Now, why is this interesting and what does this have to do with conveying instructor intent? See, my intent was when I gave that question, I said I thought that the English that I had given was quite clear, that I meant that every one is immediately followed by at least 2 consecutive zeros, right? But this is not true. I mean, now that you look at it, you can see that these words that I have put in bold were missing in my original statement. And what actually happened, and this is, the true story that led to this line of research, is one of my students who was very brilliant. She got 0 on this homework problem, right? And the reason she got 0 is because she took the same English that I had given and misinterpreted my intent. Here is what she thought I was saying. She thought I was asking for a machine where every one is eventually followed by exactly 2 zeros. So the words in bold she has misinterpreted, and it's obviously not her fault, right? This is my fault. I have failed to convey intent in terms of what I was asking. I thought, my sentence was perfectly clear. Anyway, my student, as I said, who was quite brilliant, spent much more time than I thought, because the eventual answer for her version of the question is a little bit more complicated. I mean, it has 1 extra state, and we're getting some of these arrows right turns out to be not so easy in this case, right? So she ended up solving a much harder problem. And of course, she was quite disappointed when she got a 0. And then we had this very productive discussion, and we realized that, the fault lay with me, and I had failed to convey intent. My intent for the question. And so she said, can we do something about this? Because, obviously this shouldn't happen in general, but can we develop a tool to prevent this happening? And that's got us started thinking about this. So here is the solution that we could have come up with. And this is perhaps a very simple solution. And this is actually something that we can do. And here's the idea. So imagine this is the student. So she's sitting working on this solution, and what she could do is, of course, she could post her solution to a server, and on the server I could have had my model solution, and then I just do this comparison, and for these particular kinds of problems involving DFAs, you can actually answer this question exactly, and you could tell the student you got it 100% correct, or you could tell the student no, it's not correct, and maybe you could even give some kind of feedback. right? So this is obviously one solution, but it has many downsides, right? So obviously from the institution side, we have to maintain some sort of a cloud-based or server, maintain our own server. For the student, it means that each time they are trying to check their solution, they need internet connection. So those students who have a reliable internet, are at a big advantage. So there is an equity issue over here. So is it possible to get rid of some of these requirements? So this is one downside. The other downside is, how much is the right amount of feedback to provide? So although this is a very simple solution, we chose not to do this. And the paper that I'm basing this talk on was something we did in 2015. That's the reference to it. And this is what the student proposed. By the way, the student, Aditi, was first author on that paper. So this was our solution. So imagine on the left, we have the instructor. And so the instructor has some model solution in her head. And on the right, we have the student, and the solution in this case has some other solution in his head. And so how do we get rid of these downsides? Well, what we do is, in this paper, we propose the following technique. So it turns out that for these machines, these DFAs, there is a unique answer. You can take the model answer, and even though you can express it in a few different ways, you can always algorithmically convert it into a unique solution, right? So we start with that. If the instructor solution is not already minimized, we minimize it. And then we take this and we apply a cryptographic hash on it, right? And so what the student does is, when the student downloads the question, the homework assignment, they also download this hash of the answer. And basically what a hash is it's a compressed version of the data, and it's very difficult to go from the compressed version. In fact, it's impossible technically, in some technical sense, to go from that to the original data, right? But what the student can do on their side is take their solution and also minimize it. Again, this is something they can do at the click of a button, and then apply the same hash. And if they have got the same answer, these should be exactly the same, right? And that's what the hash function ensures. So this was a very simple solution, and when we looked at the downsides, we were able to get rid of this constant requiring of internet from the student side, right? It was a one-time download of the question and the solution, and the institution doesn't have to maintain a server, because all this checking calculation, everything to the right of this vertical blue line, happens on the student's own side, right? So on his or her own laptop or desktop or whatever computing system they have on their side, right? There's a question mark here for this approach in terms of how much feedback you can provide. So it turns out the only feedback you can provide to the student is, yes, your answer was correct, or no, your answer was not correct, because you don't actually have the instructor's solution. You only have a hash of it on the student side, and because you only have a hash of it, you really can't do anything with that hash. And so it's just a binary. It's the same answer or not the same answer. So in the case of my student, in the doubt she had, at least she would have figured out, after coming up with that different solution, she would have figured out that, okay, her solution is not the same as the one I had in mind. She would still not know the one I had in mind, but at least she would know that there is something different, and maybe she could have asked a question, at that point. So that is what we were thinking of, right? Now, all this is fine. I mean, at least it's a partial solution, but it actually has another downside. I mean, of course, it's only restricted to this kind of domain, because in this, for this whole approach to work, we needed this technical point of unique minimization, which, only a few kinds of problems have. I mean, if you think of most other domains, I mean, if I ask you a maths question, for example, if I ask my students, create a function that has certain properties. I mean, there is no fixed answer, right? They could have come up with many different functions as long as it has all those properties. So this is a very specialized domain, and it's not clear this could apply. But this was an undergraduate research paper we did in 2015. So here's what I really want to talk about is, a better solution. And this is what we're currently working on. And my current goal is to try and convert this into a joint DST proposal, which hopefully some of us can get together, because obviously my domain expertise is only in computing and computing education, as was mentioned at the start. So I would very much like to try and find opportunities to partner with some of you if you think you have interesting educational problems along these lines. So let me explain what the general approach is. So again, on the instructor side, you have a solution in mind. I'm thinking of this as some string, right? I mean, it could be a piece of code, it could be some LaTeX, describing some mathematics symbols, it could be whatever, right? Some representation of a circuit or whatever it is, right? And on the right, we have the student who's thinking of some solution, which we're going to call try. Okay, so the solution and try. And what we do is we make use of a technique in computing called obfuscation. So there are approaches to this. This is an area of computer security, which is not my domain expertise, but I know enough about how to apply it, right? So this would be the part that I would add to the project. So we essentially we take the instructor solution and we package it inside an obfuscated checker. And we give that as the download option to the student, right? So the student downloads the question as well as this obfuscated checker. And on their side, all they do is they run the obfuscated checker with their try. Okay, and the obfuscated checker can do much more sophisticated kinds of feedback, in terms of not just 0-1 answers, but much more importantly, because it has obfuscation in it, the students cannot sort of undo the code and figure out what the actual solution was. So they cannot peer inside it and figure out what the actual solution was, right? So this applies to any domain where students are doing some creative task and they're creating digital artifacts, right? So the previous speakers, when they were talking about, for instance, creating natural fibers and this kind of thing, I mean, those are physical artifacts, so so it wouldn't apply there. So any domain where students are creating these digital artifacts, according to some conditions that are given, some constraints, and then somehow we have a notion of checking if they have done the right thing in some step-by-step algorithmic manner. So examples are, write a program, of course, or a SQL query, or some maths thing, as I said, write a function that has this property, or draw a graph, or give a matrix, or whatever it is, something like that. Even circuits, right? And there are probably many applications in sciences as well. So again, I'm reaching out to all of you. If you think you see any potential, and maybe we have a few minutes for questions, we can try and address some ideas even here. So as I said, we can do much more than just right-wrong feedback. So especially if this artifact is something that, you can in some sense execute like a program, then you can even ask, the student can ask on their side, well, what happens if I give it an input X, right? So this is something that you can actually run because the checker is executable on the student side. So it's not just a static thing. It could be an interactive thing. It could have some dynamic elements to it, the artifact that is being produced. So this is my last slide. As I said, it is challenging, of course, to convey intent. I mean, we try our best. Of course, there's language issues. Even if I think I'm doing a good job phrasing my question, maybe I have made some mistake in the language. I gave you an example. My student may have unfamiliarity with English, maybe may not be very fluent in English. So that imposes a challenge, right? And of course, so now we're doing all this remotely in this COVID time. So it becomes even harder. In the past, they could have come to our office and clarified the doubt face to face. Obviously, that is a very effective means of communication, which is no longer easily available to us. So what I want to do, as I said, is propose, give a proposal to DST, which has to be, in my view, something that we can make multidisciplinary. So can we do this across multiple disciplines? So I'm, as I said, explicitly asking all of you, we're all interested in doing research. So if you can think of something that has these elements, creating some digital artifact that meets certain conditions, and for which you can sort of algorithmically, meaning step-by-step check the correctness of it, please do send me an email. I'd be very, very happy to discuss. So whatever time is left, if any, I would love to discuss if there are questions. Thank you so much.
Thank you, Professor Viraj. I think there is a question in the chat box.
Yes.
Does the teacher know dynamically what the obfuscated checker defects?
Sorry, I didn't quite follow I was trying to open the chat box myself, but
Yes, please. Yes, please.
Just a minute, please. Maybe I have to end my presentation or something. So does the teacher know dynamically what the obfuscated checker detects? So if the question, Professor Deshmukh, is that, is the checker reporting back instantly? It's not reporting back instantly because that would require the student to be connected online. But certainly, the checker is checking properties locally on the student's side. So I don't know if I'm answering the question exactly as you meant it. I think your mic is muted, sir. If you would like to unmute, maybe you can ask it directly.
Meanwhile, a couple of other questions are also there in the chat box, Professor Viraj.
Yeah. So Dr. Chitnis is saying, connection with zero knowledge proofs. Yeah. So I'm actually, this is in some sense, Dr. Chitnis, it's actually much simpler. Some of those, I mean, we were looking at some of those ideas as well around this, and maybe there is a neat solution around those lines as well. I actually haven't, I didn't end up exploring it further beyond that point. So maybe we can have a discussion on that. All right. So
another question from Reja, Dr. Reja, is it possible to check the slow learner and the fast learner? I think that's a good question. Yeah.
Well, so that would require some. I mean, you could, in principle, do things along those lines as well. So, as I said, this notion of a checker is it doesn't have to just be functional correctness. I mean, it could be, it could involve things like how quickly did they at least get to this part of the solution, and so you could involve some amount of timing, and it could involve things like that. So it could certainly collect that kind of information. And then one of the nice things is, it's an excellent point, Dr. Deja. One of the things you could do over there is you could give that feedback just to the student, right? I mean, so there's some privacy issues here also. So you could give that feedback just to the student. Since all this calculation and computation is happening on the local machine, there is no question of, necessarily sending it all to a server and doing the analytics all on the server side, right? So you could potentially do this there, and that could be an excellent point. It's a very good point that you've made, right? Okay, and Dr. Deshmukh is saying, I seem to have kind of answered that first question. So a follow-up is, would it be helpful to program the checker to guide the student? Again, an excellent suggestion, Dr. Deshmukh. That is again, in principle, possible. So if it fails a check, you could give some sort of guidance to the student on that. So a lot of the intelligence would have to be baked into the checker. Again, in certain domains, this may be it may be possible to do it in a very general way. So in this very limited case of DFAs, for example, you can build a very generic checker that will work exactly in the same way for any input, any student solution, comma, model solution pair, right? It would work exactly the same way. Whereas for other domains, you may have to particularize it, on a per question basis, which could be, very, very expensive, right? So I believe, I believe one can, Dr. Deshmukh, I've managed to unmute you if you have any.
Yeah, thanks. Yeah. No, very, very interesting talk, Viraj. I really enjoyed it. I think it's great potential for teaching.
Great, and
tremendous potential. Yes.
And much more. As I said, I hope we can have some follow-up discussions. Please do email me. As I said, I'm very keen to push this proposal through, and if anyone has ideas, please let's discuss. Yeah, thank you so much.
Thanks a lot, Professor Viraj. It's a nice talk, and as you are requesting the others to join with you in the proposal, that's definitely, it's a great move. And the request all the faculty members who are ever interested, please be in touch with Professor Viraj and work on that. Okay, thanks a lot. Thank you once again. Moving to the next topic. Today we have the next speaker is Dr. Komala. She is working with the mathematics department, and she is going to present her talk on Darcy-Bernard double diffusive monogamy convection with the Soret effect in a composite layer system. And to just give a few words about Dr. Komala, as I mentioned, she is working with the mathematics department in our DSU, and she has 14 years of total experience. She submitted her thesis for PhD from the Bharatiya University, Coimbatore, Tamil Nadu. And her major research areas of specialization are fluid dynamics. With these few words, I welcome Dr. Komala to take over. Dr. Komala, it's over to you.
Thank you, sir. Good afternoon, all. So the presentation topic is Darcy-Bernard double diffusive Marangoni convection with Soret effect in a composite system. So to start with, we all know that free convection is a sort of convection in the absence of external forces. So the natural convection is due to the buoyancy force within the fluid. Marangoni convection is a kind of heat transfer by the surface tension. So surface tension is a property of a liquid and it depends on the temperature and concentration of mineralizer added to the liquid. In free convection, density variations in the fluid causes the hot fluid to move in an upward direction and the cold fluid to move in downward direction. In most of the natural convection problems, the flow is mainly driven by either a temperature or concentration variation in the fluid system. So such type of convection problem, we call them as single component diffusive or convection problems. Natural convection, which are driven by both heat and salt transfer, is referred as double diffusive convection. So in our problem, we are considering double diffusion. That means both heat and salt will be diffused. So double diffusion convection can be found in wide range of situations. In nature, we come across such flows in oceans, lakes, solar pond, atmosphere, and so on. In industry, we find such flows in chemical processes, crystal growth, energy storage, material processing, and so on. The diffusive convection is possible only when the temperature distribution is hydrostatistically unstable. So when we have this temperature distribution unstable, the convection sets into the system. So along with this convection, we are going to consider the Soret effect. The Soret effect is nothing but the diffusion of concentration, and it is due to the presence of temperature gradient. Now we will see what is a composite system. A composite system is a system which consists of two layers. So we have a bottom layer, which will be obviously a porous medium, and we have an upper fluid layer. A porous layer is a solid matrix with interconnected void spaces. Now this porous medium have many interesting properties, of which permeability and porosity plays a very important role from the perspective of diffusion and convection. So beach sand, human lungs, wood, limestone are the naturally occurring porous medium, and we have many man-made porous mediums also, like storage device, thermal insulation system, and so on. Now this is the physical configuration of the system which we consider in this problem. So it's a composite system, so we have two layers. So the bottom layer is porous layer, which is of height dm. We are taking the height to be dm. And the upper surface or the upper layer is fluid layer, it's only fluid, and the depth of this region is d. We are considering the coordinate system with the origin at the interface of these two layers and z-axis vertically upwards. Now, these are the governing equations for fluid layer and for porous layer. So we are considering continuity equation, momentum equation, heat equation, concentration equation, which is analogous to heat equation, and equation of state. Now these governing equations are linearized and made dimensionless. The dimensionless equations are rendered to normal mode analysis. After this, we obtain ordinary differential equations. So the ordinary differential equations are this. So the first three equations are for fluid layer, and the next three set of equations are for porous medium. So from this equation, we can see that the velocity equation, W of Z and Wm of Z, they are independent of temperature and concentration. So these equations can be solved by using some of the known methods. Then the obtained expression for W and Wm are made use to find out the temperature distribution and the concentration distribution. So these are the distribution expression, these are the velocity distribution, and these are the temperature distribution expressions, and these are the concentration distributions. The constants which are there, which are found here, are solved using the boundary conditions. So these are the boundary conditions which we are considering. So using this boundary condition, we will find out the thermal Marangoni number m. So this expression for m involves the velocity distribution, temperature distribution, and concentration distribution. So the expression is obtained in this way. Now, with respect to this obtained thermal Marangoni number, we are going to plot the graph with respect to the depth ratio for different physical parameters. Now we will see some of them. So this is the graph which shows the effect of horizontal wave number on thermal Marangoni number m. So the thermal Marangoni number is considered along y-axis and wave number is considered along the, depth ratio is considered along the x-axis. So this depth ratio is nothing but the ratio of the depth or the height of the fluid layer to the height of the porous medium. So when we increase this wave number, horizontal wave number A, the thermal Marangoni number also increases. Since the thermal Marangoni number is increasing, we say that the system is stabilized. Or in other words, we can say that the convection is retarded. It is slowed down. Okay, the convection sets in for a longer time. So the system remains to be stable. On the other hand, we see that the curves are widely diverging. So that means what? As we increase the depth ratio, the effect of wave number will be more. So that means when we have a system with fluid layer dominant, we can have this effect of A prominent. So next we have a graph which is plotted again depth ratio versus Marangoni number with the parameter solute Marangoni number. So as we can see here, as we increase this solute Marangoni number, again the thermal Marangoni number increases. So we can conclude that the system will be stable. Now this is the graph with respect to the Darcy number. As the Darcy number increases, the thermal Marangoni number is decreasing. So we say that the system is unstable. Similarly, this is the graph which shows the effect of Sauret parameter of the fluid layer. So with the increase in Sauret parameter, the thermal Marangoni number decreases, making the system unstable. And this is the graph for Sauret parameter of the porous layer. Now, based on these graphs, we have the following conclusions. The Darcy number, the Darcy-Bernard Marangoni convection is accelerated by increasing the physical parameters such as Darcy number, Sauret parameter of fluid layer, and Sauret parameter of the porous layer. And this makes the system unstable. So with respect to the increase in horizontal wave number and solute Marangoni number, the system is stable. And the curves for horizontal wave number, solute Marangoni number, Darcy number are diverging curves, and we say that the effect will be more for porous layer dominant system. Whereas with Sauret parameter of porous layer, we find the effect to be more in fluid layer dominant systems. So these are few references. Any questions?
Thank you, madam. It's a wonderful session. And there is one question in the chat box. Any example for the stability of convection?
Like, sir? Sir, this is an theory concept, sir. It is not application oriented. So we have not done any experiment on this.
Okay. Dr. Manjunatha, maybe you can unmute yourself and you can raise the question, whether it's answered by otherwise maybe you can unmute yourself. And there is one more question from the Dr. Rija. whether we can increase surface tension of the water by using this concept.
If we are increasing the surface tension, then the concept will not come under natural convection. So it becomes a forced convection.
Looks like Dr. Manjunath is looking for the definition of the stability convection.
See, the stability of the system we are discussing with respect to the thermal Marangoni number. So the thermal Marangoni number is nothing but the ratio of surface tension to the viscous drag into the rate of heat diffusion. So we say that the system is stable when the surface tension gradient is sufficiently well. Once we break down that gradient level, the convection sets in. That is called as the convection process, stability. So till the convection sets in, we say that the system is stable. Once the convection sets in, the system becomes disturbed. You can see the wave number, all those things in that stage. So that is called as stability.
Thank you, madam. Thanks a lot. Any other questions? Okay, thanks a lot.
Thank you very much, sir. Thank you.
Thanks, madam, and wishing you all the best for your thesis. Thanks a lot.
Thank you. Thank you.
Moving to the next speaker of today's session, we have Dr. Surya Narayana, GK. He's from Aerospace Engineering, and his topic is on direct absorption of carbon dioxide from the atmosphere. A small introduction about the Dr. Surya. Dr. Surya, as I mentioned, he is working with our department, Aerospace Engineering, and he had a great experience in the wind tunnel testing. He has altogether 37 years of experience. He majorly worked on the experimental aerodynamics. He received his PhD from IISc, Bangalore, and his major areas of research areas include experimental aerodynamics, subsonic to the supersonic wide range. Then along with that, he's more into the innovation, especially with the involving the test techniques and the multidisciplinary engineering. Yeah, and the other one is the aerodynamic drag reduction. He has come up with it. His students are working with the drag reduction, aerodynamic drag reduction. With this short introduction, I'm handing over the session to the Professor Surya Narayana. Professor Surya, you can.
Yeah, thank you very much. And before I start, let me thank the organizers, particularly Professor Deshmukh, for taking this initiative. And I think this is a very good idea that we interact with each other at a scientific level through discussions, in forums like this. Otherwise, we don't get an opportunity to know what others are doing and whether we can draw any inspiration or any knowledge from our colleagues. I think this is a good forum. So let me start my presentation. So the topic I've picked up for today is direct absorption of carbon dioxide from the atmosphere. So I'm going to cover a little bit of background, then what's the solution approach we are looking at, and a little bit on the proof of concept that we have developed, and some preliminary evaluations and what's the way forward. So this is what I would like to show today. And unlike a purely academic work, this is more of an industrial activity because as you know, one of the charters of our institution is to promote startups and create new ideas and create new employment opportunities and help entrepreneurs to come up with the new and innovative products. So that's the focus for this work. Okay, so we have a big team. Besides me, we have Mr. Faisal, who is a startup entrepreneur, and he's a director of a company called Clenvi Private Limited. In fact, this company was founded on 1/1/2020 after we demonstrated the results to him. Then we have Mr. Vinayak in our Autodesk, and we have Dr. Farhan Zamir, who works in the School of Basic and Applied Sciences in the other campus. Then we have Professor Solomon. These are the faculty members. Then we have students from automobile engineering. These are a set of very bright students. And these are the guys who developed a go-kart last year, and they also won some awards. Then we have two students from DSU, one Nitin who passed out last year, and we have a current student who is in aerospace department. All these people have helped us in progressing this project. Okay, first let me give a little background. There are two threats faced by humanity today. One is climate change, other is environmental pollution. And there has been a lot of talk going on these two topics. And even our Honorable Prime Minister Modi has signed the Paris Accord in 2015, as per which the country is required to reduce our emissions by a very significant amount. And what is being done is, the promotion of battery-driven vehicles and electric vehicles to reduce emission from automobiles. Of course, that's one way of preventing or reducing what's being done. But the problem is, what are we going to do with something which is already existing? We have already damaged the environment, and what are we going to do about it? That's a very serious aspect which not many people in the world are looking at. All right, so there are two aspects. One is climate change, other is pollution. They are related, but not necessarily related. So climate change is largely due to what are called greenhouse gases, and these are largely water vapor, nitrous oxide, methane, chlorofluorocarbons, and carbon dioxide. Now, among these, carbon dioxide is a very minor component. In fact, the percentage of carbon dioxide in the atmosphere is just 0.04%. But this 0.04% seems to be a very, very important parameter. Quite often, small problems are the ones which need more attention than bigger problems. So that way, the carbon dioxide is one of the largest crooks for causing climate change, and it has been established so. The sources of carbon dioxide are from our own respiration, from human beings, animals, etc., volcanic eruptions, deforestation, land use changes. For example, forests have been cut down to create agricultural land. We can't go back now. We can't convert agricultural land into forests anymore. It's an irreversible change. And burning of fossil fuels. Okay, humans have increased the carbon dioxide concentration by something like 47% since the Industrial Revolution began. And the most important cause for climate change has been identified to be carbon dioxide. So this will give you some idea how the carbon dioxide levels have changed in the atmosphere. The records are here from 800,000 years ago. And you may wonder how someone got this data from such a long time ago. Okay, what has happened is carbon dioxide has dissolved in Arctic oceans and in Antarctic areas, and that has been dug out, and carbon dating has been done by specialists, and they have established this kind of pattern, which was there 800,000 years ago. So the most important thing is that for millennia, the atmospheric carbon dioxide has never risen below this level, of which is 300 parts per million. And after around 1940-45, it started rising, and current level, this is actually 2015 level, and this is about 400. And in fact, if you see the next slide, okay, here this is in the last 400,000 years, and what used to be less than 300 is now 400. In fact, in the last 2-3 years, it has reached 415. Close to 415 to 420 is what we have measured in our own campus. Okay, then, okay, what is the consequence of this climate change? Everybody knows, but I just want to quickly glance through what are the potential dangers. One is forest fires, wildfires, and long periods of drought in some areas, and very heavy rains in certain places, and extended periods of intensified tropical storms like what we are seeing now in Bangalore for the last few days. These are the results of climate change. And to give you an example, a few examples of environmental pollution, this is the data taken at 9 o'clock today in Delhi. You can see that the air quality is 578 when it's described as hazardous. Now, this is a map of the pollution level or the AQI level at various locations in Delhi, and you can get an idea that it's a fairly dangerous situation. The interesting thing is that the air quality index, it actually monitors several parameters like what you see here, particulate matter, which are of dimension 2.5 micron and above, 10 microns and above, then ozone, nitrous oxide, sulfur oxide, and carbon monoxide. Now, each each particular component has a certain permissible level or an acceptable level, beyond which it is considered as dangerous or hazardous and so on. And about 500 is the upper limit for this category, for this classification. And anything above, there is no description except one word, that is hazardous. That means even if it is 1000, it's called hazardous. Even if it is 501, it's called hazardous. So this is only a rough indicator to show that this is a very serious concern. In fact, in Delhi, during the stubble burning process, which happens typically in the month of November, it has crossed 800. So Delhi pollution is notorious, and people have got all kinds of diseases because of pollution. And in fact, the Delhi Pollution Control Board gets a lot of banging from the courts for not taking appropriate precautions. And we are reading in newspapers what all is happening in Delhi with respect to pollution. And this is another city. This is Mumbai at 9 o'clock today, and the number is 162. In fact, Bangalore is very good. I didn't show that today. It's about 58, which is pretty healthy. This is because of yesterday's rains, and the data I'm looking at is of today. But if you take over a long period of time, you find that Bangalore has also crossed 500. So that's the danger we are living in. So what happened was we are all aware of this problem, but how did we pick up this approach, whatever we are trying to do? What happened was, we have this Autodesk facility where we meet with a lot of startups, and many industrialists come there with their own problems, and they are posed to the faculty and especially to Mr. Vinayak. And that way we have a very vibrant center. We come across a lot of people with lots of problems, and this could be taken up by faculty, or this could be taken up by Vinayak or whoever it is. So it depends on the particular interest of the faculty to pick up whatever problems they want. So exactly, I think August last year, one startup came to us, that is Mr. Faisal, and he said he has an idea that you can use a chemical to absorb carbon dioxide directly from the atmosphere. But he said, I don't know how to use this concept. I mean, how do we work it out? How do we make an equipment which makes use of this concept? So we said, okay, let's do one thing. You sign a MOU between DSU and yourself, and let's try to build a proof of concept. We have some idea how it can be done. So we'll build a proof of concept device, and let's see how it performs. And if it performs well, then let's see how to take it further. So we had this agreement, and in fact, it got over during September this year, and we were going to renew that agreement. Okay, so what the solution approach we had was, okay, let's look at a concept where you have an exhaust fan to drive an airflow. We picked up a exhaust fan which is available in the university. It was actually a leftover part of some student activity, so we picked up from there. And then we also picked up one submersible pump which can pump the chemical, to the system. So what we have is basically an equipment which is vertical. I'm going to show you in the next slide. And we thought, in industry, especially in heat transfer systems or cooling towers, they use what's called a fill. A PVC fill is a set of segment where you have multiple PVC sheets which are corrugated and they are curved in a certain fashion. Now, what happens is when you spray a liquid on that, it gets distributed over a large surface. Basically, you're creating a large wetted area. And so we thought, okay, let's make the liquid to go down. This chemical, we'll pump it up a device and spray it from the top to bottom with some simple spray mechanism. And we'll suck the air from bottom to the top. So this should promote a surface reaction between the carbon dioxide present in the atmosphere and the chemical, and we should be getting a purer purer air at the exit. Now, when we started this, there was no money. In fact, even startup had very little money. So we said, okay, you don't worry about instrumentation. Let's use some innovative way to measure to find out whether the chemical has really absorbed carbon dioxide or not. So that was a very simplistic approach. So we made a device which has a dimension of 1.5 feet by 1.5 feet by 7 feet. And the flow area across this device is 1 foot by 1 foot. And we carried out tests in a carbon dioxide rich area. In fact, our basement of block A is extremely rich in carbon dioxide. The reason being that first thing, it's not very well ventilated, unlike the block B basement. And many people who come there, they, especially in summer, they run their air conditioner sitting inside the car, especially chauffeurs. So there's no way for the carbon dioxide and other gases to escape in an easy fashion. So it's very rich in carbon dioxide. Then we thought, okay, let's do one thing. We'll do this test and acquire data of the sample. We collect samples from this chemical over certain periods of time. and we will do the analysis and see whether we can scale it up. That was the approach. So this is a device, what you're seeing here. This is a filter segment. This has got 3 filters. You can also have, these are actually called bag filters. Bag filters are somewhat, they're more like bag, but it's more of a fluffy kind of material, which blocks the particles from getting inside. Then we have 2 air filters of different filter dimensions, mesh size. Then we have this PVC fills, or actually 3 segments. And so the air is sucked from the bottom to the top, and we have a tank here which collects the fluid with the chemical. And using a submersible pump, you can collect this pump and collect this fuel and fluid, and then pump it to the top, and with some tubing system. And we have this elimination section where the water droplets, even if they have, if there are some, we actually wanted to put a filter, additional filter to remove some particles which may be coming out. For example, we might want to put some additional carbon filters on top. Then this is a chemical section where the reaction is happening. This is the device. Then this is the, so we built a device of this design. So what you're seeing is the actual device. So you have the tank here, and this is the air filter segment, and this is the chemical segment, and we did not have the elimination section. That's going to come later on. So we did experiments in the basement of block A, and then took these samples for chemical analysis. And we approached the School of Biochemistry in our main campus, Campus 1. And this is a result of what we got. So here we took the chemical which was fully saturated. By gut feel, we could feel that chemical is getting saturated. There was no further sort of absorption going on. This happened purely by gut feel. I think if you are an engineer, you'll have a lot of gut feel, so that way it worked out. So initially, when the chemical was in the pristine condition, it had a pH value of about 12.5, indicating that it's a highly basic solution. And as the time went by, you find that it's sort of dropping and then saturating. And we also made conductance measurements. These are very simple experiments to do in a chemical laboratory. So the conductance ratio, that is with respect to the initial value, you can see that it started coming down, which is an indication that the chemical is becoming more and more basic. Okay, then what we did was, okay, from this numbers, you can evaluate how much carbon dioxide it has absorbed. And that plot looks like this. So you can see that initially it was 0. There was because there is no reaction happening, and over a period of time you could see that it absorbs about 22%. So if we calculate the based on these numbers, if you estimate the actual carbon dioxide it would absorb over a period of 1 year. Suppose we run this equipment for 1 year continuously, 24/7. Then how much carbon dioxide can it absorb? That calculations, estimations have been done, and that works out to about 5 tons per year. Now, considering the requirement in the whole world, where the source is a few hundred billions of tons of carbon dioxide, 5 tons is nothing. It's not even a small fraction of the requirement. Therefore, we need to look at large number of such systems, and each system should be capable of doing much more than five tons. So, with this background, we estimated that we should have a larger prototype of more like 3 feet by 3 feet, and it requires a different power supply. And target is to make a device which will remove 50 tons of carbon dioxide per year. So this, okay, now how do we know that the chemical has actually absorbed the carbon dioxide? This is an indirect estimation. The direct proof for checking this is to boil the liquid which has absorbed carbon dioxide and measure how much is the output from this device. So we took a small sample and boiled it in the laboratory, and we had a carbon dioxide sensor, a standard sensor, and took a small amount, I think 50 milliliters or something like that, in a small cup. And to our surprise, not really surprise, to our happiness, what we found was that 400 was the level which when we started. So this 420, 415 is the carbon dioxide which is already present in the atmosphere. So the chemical is not doing anything about it. But as you start boiling, it picks up heat, and this is the time taken for the chemical to come to a boiling condition. And this happens at about 92 degrees. and then you find that the peak value is 1200 ppm, and then slowly it drops off because all the chemical has discarded the carbon dioxide. Now you are back to the initial condition. So this is extremely encouraging because this shows a way by which you can recycle the chemical. So if the state of the chemical at this point and this point are the same, then this gives a good idea that whatever chemical you have used as a raw material can be reused, or it can be recycled, it can be turned out as a product for some other application. So there is a new sort of approach to this work. So the evaluation, so we evaluated for pollution. This is also a very exciting activity. So what we did was, this chemical is quite expensive. It's not that cheap, and the cheapest chemical you can think of is actually water. So we used the recycled water from our campus and did some experiments. So what we did was, behind our campus, we set up this device, and behind block A, we set up this device and burned some material here like stationery and all that, and created very bad air around this. And we measured the PM particles at the entry, and we also measured the PM particles at the exit. And we used only water here. In fact, we didn't use this pump. We used the garden water line and then connected here to see what's happening. And to our pleasant surprise, what we found was that the input, though the input level of PM10 2.5 was around 1000, what was coming out from the device was actually less than 100. So this shows a very excellent possibility of using this as a device for indoor indoor filtering. Now, as you know, once upon a time, the big hospitals were set up outside cities because they wanted good air and good atmosphere for patients to recover. But unfortunately, cities have grown so big that the hospitals now are sitting in highly polluted areas. One good example is the Victoria Hospital in Bangalore. It sits in a very highly polluted area. Now, if you have such a device, let's say you put it in a ward or in an operation theater or in some recovery area, where you can purify the air. So you are actually using water, and you are drawing air from the from the environment, purifying it and releasing a purer form of the air without particulate matter. So we feel that this is a very good industrial device which can be properly handled by a startup. So the next approach, what we are planning to do is like this. This patent was filed for the process of using the chemical. This patent, we told the entrepreneur, this is your chemical, you brought this, so you file it in your name. We have no objection. So patent has been filed last year. And the startup founded a company called Clenvi Private Limited. In fact, it was registered on 1/1/2020, just 9 months ago. And we are now planning to develop this into a full-scale prototype, which should remove 50 tons of carbon dioxide per year. The device is being designed right now and in various stages of device. Now, when you think of a device, there are multiple options. You can have a vertical chamber with multiple inlets. So it looks like the Chinese air filtration tower, what people are aware of. So these are the various types of designs we are looking at. And, it requires the lot of funding. Each unit costs about 15 lakhs when you want to scale it up. And we also want to make it self-driven in the sense that it should be driven by a solar plant. So integrating the solar plant, and right now we have used a DC system. They're all DC motors. So we need to go for proper drives to run the system. And we need power source, which we want to use, so for which we want to use solar. And so these are the big ideas that we have in mind. And we have approached various agencies for funding. One is MSME Foundation, which is in IDEC of Campus One, which is actually to be funded by Government of Karnataka. And applications are with them. They have other priorities right now. They are not looking at that. And we have applied for corporate support research fund from Infosys. And we came to know that this project is one of the projects which they have approved from Infosys. But this was about 6 months ago, and they're also not corresponding with us anymore because I think they have their own priorities. And we have also made presentations to pollution control boards in Delhi, Kolkata, and Bangalore. And they're showing great interest. And in fact, some investors in Kolkata are coming to us next week to see the device. So a lot of business activity is also picked up in relation to this. And what is the way forward? The way forward is to establish a proper technology for recycling the saturated chemical to extract carbon dioxide in gaseous form. And there are certain challenges involved here because we don't know what is the purity of the carbon dioxide. In fact, what we have absorbed may not be just carbon dioxide, it could also be smaller amounts of other gases. Now, if you want to use, as you know, carbon dioxide is used in food and beverage industry. All the aerated drinks have carbon dioxide. And this chemical is also used in automobile industry and also in sugarcane industry. Now, to apply this in the food and beverage industry, you need to know how pure it is. So how do you establish the purity of carbon dioxide from the samples we have collected? That's one challenge. Then what's the technology to recycle? And we are saying that you just boil and you liberate the carbon dioxide. That's a good idea, but what's the device? What kind of industry do you require? What equipment do you require? So these are the things that have to be properly filled in. And then we want to supply this as a device for pollution, as an indoor pollution control device. And we want to deploy this in large areas with in multiple numbers, so that you are really handling the physical problem of removing carbon dioxide from the atmosphere. It is also important that any device developed today with present technologies, it has to be smart, meaning that it should be sitting on an IoT platform, it should be GPS enabled, it should have its own Wi-Fi, and it should communicate on mobile, so that the person who is marketing it or who is doing the servicing, he should sit in one point and he should know what is the status of the equipment, what is whether the propellant, whether the chemical has been consumed, whether there's a power supply going in, whether the chemical has got saturated, what's the input carbon dioxide, what is the output carbon dioxide level, what is the particulate matter that's coming in, what is going out. All these things, the maintenance person needs to know sitting in one place. For example, if the company is in Bangalore, you should know what's happening in Delhi if this equipment is in Delhi on an online basis. Therefore, there is a lot of need for new technologies which involves cloud data acquisition, cloud data processing, multiple sensor fusion into a common microprocessor chip. So there is a huge prospects coming up in this activity. And obviously multiple patents are possible, and we would like to have these patents between the DSU innovator and the private party, so that there is a direct use for these patents. Otherwise, quite often patents become purely paper patents, and they have very little. I mean, if any, they have only academic value. But we don't want to do this because it's an industrial development. So with that, I conclude my presentation, and I would like to thank the organizers, particularly Professor Deshmukh, for giving us this opportunity. Thank you. I see some questions in the chat box.
Yes, sir. Yeah, thanks a lot, sir. There are some questions in the chat box. Maybe we can go through that. One is with Professor Deshmukh. He was mentioning it's a wonderful device built here. Congratulations. I hope you get sufficient and rapid support to enable its applications. This device has great societal values. I hope this device gets into production. Scaling up would be great.
Yeah, thank you. Thank you for your comments. And we also require a lot of help from our faculty colleagues, because as you know, this becomes a highly multidisciplinary problem, because especially data fusion, data acquisition, data processing, and writing mobile applications and enabling it on mobile platform. This is a huge task which only computer guys can handle. So we need a lot of support from other faculties.
Yeah, and there is one more appreciation from Professor Viras. He's saying it's an excellent talk. Apart from that, he has another question saying that does the power consumption scale reasonably as the device size goes up?
Yes, sir. When we double the scale, the mass flow becomes 4 times and the power requirement becomes 4 times. And we are now looking at 3 times bigger. So it's going to be quite a bit of power intensive. We anticipate that every device would require about 5 kilowatts. So we are trying to get this from a solar device, which should be mountable in some place and draw power from there and use it for this purpose. That's the plan. About 5 kilowatts per unit, which can extract 50 tons of carbon dioxide. That's about the estimate what we have made.
there is another comment again from the Professor Deshmukh.
Yeah.
It's regarding the, I think you have mentioned, along with the carbon dioxide, something else might be there. So sir was mentioning, might there be toxic contaminations along with the carbon dioxide, which will become the matter of concern in food and beverage industries.
So let me answer that. We really do not know what all the things the chemical contains now. We know that it has carbon dioxide. I mean, the solvent which has absorbed carbon dioxide, we know it has carbon dioxide. Now, when we boil this and try to extract the carbon dioxide, we don't know what are the things in that. Okay, CO2 alone we have measured. There could be something else which we are not measured. So what we are trying to do is do what's called analysis, chemical analysis of this using latest equipment available. For example, there are chromatography equipments, there are several other apparatus available, mass spectroscopy is available, and these techniques are available. Using these techniques, what we would like to do is estimate the purity of carbon dioxide. Now, suppose we say we want to use it in beverage industry, I think it has to be at least 99% pure. Otherwise, food industry will not accept. At the same time, suppose it's only 50% purity. Then it has got certain other applications. For example, in agricultural area, in sugarcane industry, to extract something else, they use this chemical. That is one application. And yet another new application coming up is in the automobile sector, because what has been established is that if you use carbon dioxide to fill your tires, it's more efficient than either nitrogen or air, because you can compress this gas to very high pressures, and you can have a small container which can be a canister like thing. You carry that in your car, and if the tire deflates, use this device and inflate the car. You don't need to go to a petrol station and to a puncture shop, so-called puncture shop at all. So these are the new, in fact, US it's becoming popular, using carbon dioxide to fill the tires. So we need to explore. The bottom line is we should know what are the contents of this gas apart from CO2, and whether there are any toxic components in that. That also has to be looked at. And we have seen some literature on the chemical that has been used, and we have a source from US control agency which says that there are no toxic concerns here, except that it might irritate the skin. It says if you are in physical contact with the skin, with the chemical, it might sort of irritate the skin. Besides that, we don't see any major issue. So this can become a concern for people who are managing the system at the production site or the utilization area. So they have to take proper precautions and handle this.
Thank you, sir. In view of the time, I'm stopping the further questions. Guys, any interactions, feel free to speak with Dr. Surya. With this, I thank to Dr. Surya for taking the wonderful problem and explaining us the way you have taken out and the way ahead. Thanks a lot, sir. Wishing you all the best.
Thank you very much. Thank you.
Yeah. Moving to the next presentation, we have Professor Srinivasarao Amarneni. He is going to talk on protein adducts as a biomarker of exposure to organophosphorus pesticides. Before handing over, I just mentioned about the short profile of Dr. Srinivasarao. Dr. Srinivasarao Amarneni, he is associated with the Department of Chemistry in our Dayanasagara University. He received his master's MSc degree in inorganic chemistry and then PhD degree in chemistry from Andhra University, Visakhapatnam. He has about 22 years of teaching and research experience. He did a lot of interdisciplinary areas that includes analytical and environmental chemistry, bioanalytical chemistry, characterization of the protein and DNA adducts with neurotoxins like pesticides, PHs, and drugs, etc. And then he has collaborated with environmental biotechnology and phytochemistry. He received so many awards, to name a few. He is a awardee of international fellowships that includes DAD from the Germany, and he worked as the visiting researcher for Germany, and then Royal Society of Fellowship UK and the Royal Society of the Chemistry Developing World Fellowship to carry out the PDF research work at the Humboldt University, Germany. So there are many contributions from his side, and he received many projects from the UGC, JNU, IM Tech, and also from the UK. With these a few words, I'm handing over to Professor Srinivas.
Yeah, thank you, Professor. Good afternoon, all of you. Today, I'm going to present on the protein edits as a biomarkers of exposure to organophosphorus pesticides. The content of my presentation is a little bit about overview of the pesticides and pesticides and its impact on human health, and also motivation to take up my research study on this aspect. And also I'll speak a little about the protein adduct formation and its effect on the human health. And also based on this, I'm going to present the results of my research work on the formation and characterization of lysosome protein adducts with monocrotophos, which is organophosphorus pesticide. Finally, I would like to summarize and further future work. And the overview of this presentation, this presentation is that humans are often exposed to variety of the environmental chemicals, which includes the polycyclic aromatic hydrocarbons, pesticides, and microplastics, and that are present in the environment that contribute to the individual health risk for the diseases like cancer and neurological disorders. And out of the many environmental chemicals which are considered as a endocrine disruptive chemicals or considered as a neurotoxicant, and the greatest attention has been paid to the pesticides in the light of the wide usage of the pesticides in the agriculture. The pesticides are used in not only in the agriculture, and it also being used in the different sectors like domestic sector and also the public health sector also being used. And the pesticides are using for the to kill the insect in the agriculture to enhance the food grains. And these pesticides are classified into herbicides, insecticide, fungicides, and also the rodenticide. Based on the application of these pesticides, the name has been given. Further, the World Health Organization also classified the toxicity level of based on the toxicity of these compounds, low toxicity, moderate toxicity, and high toxicity of these pesticides. And in the pesticides, there are insecticides are classified into organochlorine pesticides, organophosphorus pesticides.
Sorry to interrupt.
Sure.
Sir, are you sharing any presentation?
Yeah, results I am going to present. Yeah.
Oh, okay. Till now, we are not really seeing any presentation from your side. That's fine, sir.
I have shared it.
Oh, is it? No, we are not able to see the.
I'm very sorry. I'm very sorry, sir.
Yes, sir. It's coming up now.
Yeah, I'm very sorry, sir.
No issues, sir. Carry on.
Yeah. Just again, I would like to recap the points which I mentioned, and over these all I mentioned already. And humans are often exposed to variety of chemicals that are present in the environment. That chemicals includes the pesticides, polycyclic aromatic hydrocarbons, and also the microplastic compounds, and which that contribute to the human health risk for the diseases like developmental disorders, and also it causes cancer or even it cause for that death also. And the out of the among the many neurotoxicant chemicals, and the greatest attention has been paid to the pesticides in the light of the widespread uses of the pesticides, and that they will be used in the different sectors: agriculture sector, domestic, and also the public health. And the pesticides are the application of the pesticides in the agriculture is to kill the insects to enhance the food grains to meet the demand of the demand for the food for the people in the world. And the pesticides are classified into herbicides, insecticides, fungicides, and also the rodenticides. This name has been given based on the application. Insects are again classified into two types. One is the organochlorine pesticide and also organophosphorus pesticides. Organophosphorus pesticides are considered, invented and discovered in 19th century, which includes the agenophos, methylchlorophos, monocrotophos, malathion. And these organophosphorus pesticides are being used in using in agriculture is even after the World War II. And the pesticides are human are exposed to these toxic chemicals through ingestion, inhalation, and also the dermal direct contact to the skin. And once these chemicals are enter into the human system, there is a possibility of the binding. There is a hypothesis possibility of the binding of these chemicals to the proteins or enzymes present in the biological system. And exposure to the organophosphorus compounds can lead to the serious neurological damage, cancer, or even death. And once the chemical enter into the biological system, and we have a particular enzymes detoxify the toxicants, particularly cytochrome P450 that present in more abundantly available in the liver. That chemical pesticides will convert it into the metabolites. That metabolites also have a highly potent inhibitor of the amino acid active sites in the protein. And that means once the pesticide enter into the human system, and because of the biosynthetic process in the body biological system, that converted into the metabolites. That metabolites also have a more tendency to interact with the amino acid, and which give amino acids in the protein, which has a more toxic than the parent compound. Organophosphorus may form adducts on the cellular proteins like albumin, serum albumin, lysozyme, and also the blood cholinesterase. Here, adduct is nothing but the formation of the complex between the neurotoxicant chemical, that is pesticide, and the proteins, and it forms a new product, new compound that will be the that gives a more toxicant to the biological system. That is the process of the formation of the adduct. It's a simple complex between the neurotoxicant, any chemical, which and also the protein. And once this complex formation is taking place between the protein and the neurotoxicant, and the function of the protein and structure of the protein will be stopped. So that will causing for the different diseases. And the organophosphorus insects are involved in many occupational poisoning cases. Human biological monitoring of the pesticide exposure has become essential with the objective to assess the exposure and health risk, and is an expanding area of the research. And there are there are many studies reported on the pesticide interaction with the protein, and which considered as a that studies demonstrated as that pesticides are causing, most of the pesticides are causing the neurotoxicity by forming the protein adduct formation. And the hypothesis for the formation of the for the neurotoxicity, and the mechanism of the adduct-based neurotoxicity is mainly due to the toxic neurotoxicant, that chemical is considered as electrophile, and also the amino acid in the protein considered as a nucleophile. It is electron donating and an electron accepting mechanism in between these two that leads to the formation of the protein adduct. Once this adduct formation is taking place, every protein has a specific function, and that function and the structure of that protein will be affected, or function also will be regulated by the formation of this adduct. And that adduct leads to the change in the protein structure and function. And the protein play a critical role in neuronal pathway function, and the protein changes are sufficient magnitude to result in pathway failure. and pathway failure leads to the new nerve cell damage. And other studies, there are some more studies demonstrated that the epidemiological studies and occupational studies, occupational studies and migration studies has demonstrated that these chemicals are causing for the carcinogenicity, and that is cancer, and finally it leads to the death also. And some more one more reference to support this study is that chemical induced DNA damage and also the human cancer risk based on the mutation that takes place in the DNA sequence and also the protein sequence with the neurotoxins like polycyclic aromatic hydrocarbons and also the pesticides. And another, this also supported my study, chronic reference for my study, chronic systemic pesticide exposure reproduce the future of the Parkinson diseases. There is a hypothesis, but it was not established clearly. Most of the pesticides are causing for the neurodevelopmental disorder and particularly Parkinson diseases. And the role of the cytochrome enzymes in endogenous signaling pathway and environmental carcinogenesis. This study also demonstrated the pesticides are causing for the cancer and neurological disorder. And yeah, there are many further supporting data is novel protein targets for the organophosphorus pesticide. So that means there is in a rat brain, there are specific proteins have a tendency to bind, more affinity to bind with organophosphorus pesticide. That proteins we can consider as a biomarker. What is the biomarker? Biomarker is that systematic collection of the biological sample to analyze the chemical, toxic chemical of our interest to quantify. So that gives you the that can be understand that gives the information about the toxicity exposure level and also the toxicity effect. There are many methods for the estimation of these protein adducts with the pesticide, particularly fluorescence methods and some other bioanalytical methods like circular dichromism, UV, IR spectrometers. And many epidemiological studies and also animal and cell culture studies models reported that pesticides have been demonstrated to be carcinogenic and neurological disorder. However, the results of these studies are still controversial. Their mechanism of action is not clear. Epidemiological studies reported that just it's a pesticides are binding to the proteins they reported, but what is the mechanism to bind between the pesticides and the protein of our interest are considered as a biomarker at a molecular level or atomic level has not been studied in detail. Therefore, new strategies in toxicological research are needed for efficient screening for adverse effects of pesticides on a complex living system. So biomarkers can be employed to identify causal associations and to make a better quantitative and quantitative estimates of those associated relevant to the level of the exposures. So once the adduct form in the biological system, if we quantify the how much concentration of adduct that present in that biological system, that can be used for the prediction of the health diseases in the future or the present, that can be utilized for the diagnosing the diseases in the coming years or present. I mean, for that particular person who is exposing to the chemicals. So this will enable us to deepen our understanding of the mechanism behind their carcinogenic potential. So they based on, I mean, by knowing the consequence of this chemical, that motivate us to take up the work on the particular topic. That my research results are biophysical aspect of lysozyme protein adducts with monocrotophs. So this work already published, and this study involves the proteins in the human body tend to bind to organophosphorus compounds, pesticides which cause a genotoxic cancer formation of DNA, and protein adducts are poorly understood. So that mechanism has not been studied clearly. For that will be the motivation to take up this work. formation of the adducts, which lead to the disruption of the structure and function of the DNA and protein and may cause cancer. As I mentioned earlier, once the adduct formation takes place, that function of the protein and structure of the protein or DNA will be disrupted. So that leads to the diseases or cancer or developmental disorders. Many studies suggested that the organophos pesticide for the adults who are characterized by the spectroscopy techniques like mass spectrometer or fluorescence spectrometers. There are some studies earlier previously, some studies showed in the earlier slides that demonstrated that the analytical methods they have used characterization by the spectroscopy techniques like a mass spectrometer and fluorescence methods. But there is a limited studies on the binding mechanism at molecular level, particularly protein crystal structure structure of the protein.
Professor Srinivas, on view of the time, may I request you to speed up?
I'll conclude within 5 minutes, sir. So the adduct with the organophos pesticide, the OP pesticides are particularly monocrotophos is recognized as actually hazardous pesticide with a human health risk. So as I told that the motivation for this work is that the protein lysosome is widely distributed in biological system. We have considered the lysosome because abundantly available and it has a good role in a biological system drug carrier also. So we consider the lysosome as a marker to study the interaction between the lysosome with the monocrotophos pesticide, and that by using the XRD technique, by crystallizing that protein with the lysosome protein with the pesticide and crystallize that crystallized the crystal was analyzed by using XRD, and we construct the model to know the interaction between the amino acids in the protein, and that is lysosome, and the protein. We have to establish that. So our objective is to analyze, characterize by using the XRD, to characterize that adductors by using the XRD to know the interaction at the atomic level. And also we have used the other bioanalytical technique as a complement to get the complementary data, fluorescence and also UV spectrometer and MALDI. And this study may be used to assess the human health risk associated with the pesticide use and its exposure. And experimental, we have used the different pHs to screen the crystallization, to crystal screening. And we crystal screening crystallized this protein with the lysosome protein with the monocrotophos pH 7.5, and buffer is the TRIS buffer. And the fluorescence quenching data suggested that as the protein is binding, the pesticide is binding to the lysosome protein, the fluorescence concentration will be decreasing. The fluorescence concentration will be decreasing. This we have collected the data, excitation wavelength at 280 nanometer, and that is a tryptophan excitation at that wavelength, and the emission wave spectra we get from between the wavelength between 300 to 500. So there will be a shift between the lambda. It shifted to the 348 nanometer. So that this indicates as the concentration of pesticide is increasing and that bind to the lysosome, the fluorescence will be decreasing. So that indicates there is a binding between the pesticide and also the lysosome protein. And these data, these fluorescence data is used to calculate the KD value to understand that binding, that complex is stable or not. To assess that, we use the Stern-Palmer plot to get the KD value to understand the stability of that. So we got the KD value, dissociation comes 3.87 micromolar, and that indicates that the complex which formed between these neurotoxin pesticide and the lysosome is more stable. And also we studied the UV visible spectra that also suggested there will be as the concentration of pesticide is increasing, the intensity absorption level is increasing because of the interaction between the protein and the lysosome and the pesticides. So another type of biophysical technique that we use to know that to any changes in the conformation or structure of the secondary structure of the lysozyme protein. So it is established that there will be we have as you've seen in the this diagram, as the concentration of the pesticide is increasing and the theta value is decreasing in negative level, so that indicates the alpha helical that secondary structure will be changing. So that is the supporting data for the XRD data. And also we have studied on Malditov analysis. We have incubated these pesticide along with the lysozyme monochromata pesticide along with the lysozyme.
Sir, may I request you to conclude, sir?
Yes.
It's already 1:35.
Yes.
Sorry for that.
This is the crystal data we have. This is a crystallized complex, and that method is the hanging drop method. And we have taken the data on XRD, and this is the modeled protein complex with the monocrotophos, and this is the leak plot, and this indicates the interaction between the protein and also the monocrotophos. So we found that there will be a covalent interaction between the tryptophan that position at 108 with the methoxy group in the phosphate in the monocrotophos have a strong interaction. In addition to this interaction, there will be many hydrophobic interactions also be prevail in this complex. So in conclusion, that in our study report, support demonstrated that there will be a strong covalent complex between the monocrotophos and also the lysozyme, and the spectroscopy techniques like UV and circular diagram Malditov, that techniques can be provided complementary data. So this work is referenced cited by some of the papers, which one of the cited, my paper is cited by cited in the one of the journal Acta Pharmacologia, is a Nature publishing group. And the future work, we want to quantify this adduct in the farmers who are continuously exposed to these chemicals. In vivo studies, we want to take forward this work further to quantify this adduct formation in the farmers. So, and last, I would like to share the sum of one point on this information. We have established the Water Technology Environment Research Center, and we are planning to go for the accreditation NABL and also Pollution Control Board. This was supported by our DSU management. So I would like to acknowledge all my management and administrator of the Dayananda Sagar University, and I would like to acknowledge all my co-authors and the funding agency. Thank you. And any questions?
Thank you, sir. Thanks to Professor Srinivas.
Yeah.
It's a wonderful talk. It's a very intensified talk. And at the same time, you have taken the social cause. We are really happy to see your studies and observations. There is a question from Professor Deshmukh, but in view of the time, I'm sorry for that. I'm not allowing to discuss that. You can do a kind of the offline discussion with him. Again, once again, thanks for your time. I understand that it's lunch time and you have not taken your lunch, and we can see your passion, sir. Really, thanks a lot.
Thank you, sir.
Yeah. Next speaker for the present session is Dr. Deepika. She's from Mathematics Department, and her talk is on the significance of a new topological index. Before handing over, I just want to give a very short profile of Dr. Deepika. As I mentioned, Dr. Deepika is with us in the Department of Mathematics, and she has a total experience of 5 years, teaching experience, and research experience of 6 years. And she did her PhD from Vijayanagara Sri Krishnadevaraya University, Ballari, and her major research areas of specialization include the discrete mathematics, especially the graph theory. With these a few lines, I'm handing over to Dr. Deepika. Dr. Deepika, please welcome.
Yeah, thank you, sir. I'm audible to everyone.
Yes, yes, please.
Yeah, thank you so much, sir. Uh, so my topic is on significance of a new topological index. So before going to know about the topological index and which is newly defined topological index, so I would like to share few things. So this topological indices of a graph started in India. A very few researchers have started in Karnataka. So especially my guide has started this area of topic, so it is continued now. Till now, it is continued. So this area of research is also doing in Kerala state and also Tamil Nadu. And outside India, so there are many researchers in Turkey and in Canada. So some research fellows are doing in this area. So before going to know about significance of a new topological index, I would like to give brief introduction. I will not take much time. So due to lack of time, this is the outline of my talk. So yeah, introduction, different types of topological indices, how to develop a topological index, and we are going to discuss a newly defined topological index and its applications. So before going to know about the topological index, we have to know what is a topological or topology, or we can say graph topology or molecular topology. So for suppose a molecule M is composed of n atoms, A1, A2, A3, etc. up to AN. So also for any two atoms AI and AJ, so we can decide which of the following two statements is correct. So usually what we will do is, suppose if you are considering a chemical structure, so we can interrelate with the mathematical aspects. So in the molecule M, there is a chemical bond between the atoms AI and AJ. Okay, so then we are going to conclude that we are going to take the value of those two. So if it is not adjacent, then we are going to consider it as a 0. So then the totality of information about the mutual connectedness of all pairs of atoms in a molecule determines the topology. So with this, I would like to straight away go with how to define a molecular topology. So represent each atom by a small circle and draw a line between any two circles which corresponds to chemically bonded atoms. So the diagram obtained in this manner is a graph. Since it represents the molecular topology, then it will be called as a molecular graph. So here in this talk, I'm just taking the molecular graph. So not only molecular graph, any kind of a network graph also we can consider to compute the topological index. So this is one example how we are considering the graph from a molecular structure. So this is the molecular structure of an ethanol. So this we have done the graph invariant. So here the number of atoms represented as an, I think you can see the circles, these are all atoms. So here we are going to consider it as an vertices or nodes. And the bond between two atoms we are to consider it as a line. So not only we can represent in any ways. Okay, so we can take graph isomorphism also. So with the same number of vertices, with the same number of edges, we can draw in any number of shape without changing the vertices and then edges. So this is the graph how it looks. So I just keep all this. Yeah. So graph invariant is nothing but every number which is uniquely determined a graph is called a graph invariant. So and now the topological indices, the whatever we have taken the graph invariants of a molecular graph, so that will be straight away applied in quantitative structure property relationship or quantitative structure activity relationship. So property relationship will be is nothing but the topological indices is also studied in physical science, as well as activity relationship is nothing but studied in chemical and biological science. So these are all usually we call it as an topological indices. Yeah, so this is a mathematical aspect. If we take a graph isomorphism, then there is no change in the value of an topological index. So I'll just show you the graph isomorphism. Here we have a 8 vertices with 12 edges. So here, so you can see the graph G. with the same number of vertices and with the same number of edges, we can do the graph isomorphism. So here we have mapped f of A is nothing but 1 here. So f of B is nothing but here 6. So same number of vertices, same number of edges, and also here we are going to define one more thing, degree of a vertex. So I think you all know about the degree of a vertex means for each degree. So how many adjacent vertices are there? So suppose if A, the degree will be 3. So if it is G, the degree will be 3. So the degree of an vertex will also doesn't change when we take the graph isomorphism. So now in topological indices we have different categories. So it is classified into distance based, degree based. So nowadays they are doing the neighborhood based indices. I'll just give you the example, simple examples how this distance based will be calculated, degree based will be calculated. Before that, what are the topological indices types? We'll just look into this model graph. So this usually topological indices is classified from the molecular descriptor. So molecular descriptor is nothing but characterizes the properties of a molecule. So from this we are doing the graph invariant, and from graph invariant means we in terms of mathematical objects. So we are going to consider atoms as a nodes, or we can say vertices, bonds, or lines, or edges. So and the classification definition is the classical definition of topological indices is topological indices are the graph invariant number calculated from the graph representing molecule bar network. So you can take any kind of standard graph. So now we'll look into how many different types of topological indices are there. So previous it was not in topological index. The first topological index is a Wiener index. We don't have name as topological indices. So the first index is a Wiener. Wiener is a name of a chemist. So full name is Harold Chemist. So in the year 1947, he introduced the boiling point of paraffin. So with the help of help of definition of a Wiener index. So this Wiener index is a distance-based graph. So with that we are going to compute. So what exactly it says, instead of doing the experimental result with this known definition, so we can directly find out the boiling point of a paraffin. And also straight away it is applied in the QSAR model, so quantitative structure activity relationship model. So thereafter, one by one, we have Hosea, a name of a mathematician, Zagreb. This is also one of the topological index. It is the name of a city. And thereafter, we have Randic connectivity, atom connectivity. Nowadays, coming to the present work, we have thousands together topological indices are introduced. So recently, among them, one of the indices are discrete Adriatic indices. So this is revealed by silicon gas probe. So and it has an application, lot of application in the chemical sciences, and we can say this is a best predictive property. And so these indices are tested by International Academy of Mathematical Chemistry. So this is about the brief introduction about the topological index or indices. So this is the website of International Academy of Mathematical Chemistry. So if you want to get the data sets of a chemical structures, we can, with the help of this website, we can get the data sets. Yeah, so I think let me zoom. Okay, so I think is it visible? As I told you, the first oldest topological index is a Wiener index. It is nothing but sum of all distance between pairs of vertices of U and V. In a mathematical prescription, we use U and V. It is a standard notation represented as a vertices. So W of G is equals to summation UV belongs to edge set. Capital E of G represents edge set. D of U comma V. So this D of U comma V is nothing but we are going to take the shortest path of all distance between pairs of vertices. So here I have given one example. Suppose I'll just give you an example how to calculate this. So if you see this molecular structure N-butane, This is an isomer. So if you consider this as an A, B, C, D, so then how to find the shortest distance between one vertex to another vertex? So suppose if I call this A to B, what is the distance? A to C, A to D. Like that, for remaining vertices also we have to find out the shortest path. This is a simple example which have given how to calculate the Wiener index, and this is a distance based. So similarly, we have degree based. So this is extension of Wiener index. This is modified version, and this is also a modified version. I just don't want to give brief explanation regarding this. So next, degree-based topological indices. As we have seen the Zagreb index. In Zagreb index, we have two versions. One is first Zagreb, second Zagreb. So this is a degree-based topological indices. So suppose if I consider some standard graph, this is a graph G. So degree vertices means summation U belongs to vertex set. So the vertex will be belongs to U belongs to vertex set G, and or we can consider this as an so it should be UV. So UV belongs to edge set E of G. This definition is same as this one. So here I have shown the how to calculate using this. Suppose if I take E1, so E1 having the degree, so E1 having n vertices, this and this, right? So the degree of this vertex is 2, and this degree of vertex of this vertex is 2. So 2 plus 2, and again if I take this line, again we have degree 2, 2. So like that, so four edges having 3 plus 2, this is degree, du and dv. So four number of edges having degree 2 plus 2. So and one number of edge having degree 3 plus 3. So total edges should be 9. 4 plus 1 is 9. So total number is 42. So similarly, second version M2 of G. So we have to multiply this. Same kind of we have to consider if we consider this graph. So this is the result we will get. So when we use the second version. So this is about the topological indices, how we calculate. So all these topological indices have an application in the field of QSAR or QSPR. So this is a few more topological indices. And so here, I have invented a new topological index. To define a new topological index, so we have certain conditions to develop a new topological indices. So all these are the conditions, direct structural interpretation. It has good correlation with at least one property. So it has good discrimination of isomers and so on. I don't want to discuss much about this.
Yeah,
Okay,
Professor
so,
Deepika, if you don't mind,
yes,
can
sir.
you just speed up a little bit?
Yes, sir.
Thanks a lot.
Okay, sure. So directly we'll move on to the main topic. So based on all these conditions, so I have defined a new index recently in the year 2019. I have invented this index named as Veerabhadraya Lokesha. So gratitude towards my group Lokesha. So I named it as an VL index. So this VL index, so using the mathematical properties, and also we have a good correlation with octane isomers and also polychlorinated biphenyls. So we have a correlation between this VL index and with this. So based on this, I can say this index also can be applied in the field of QSAR or QSPR. So this representation where DETF is denoted du plus dv minus 2 and df is equals to du into dv minus 2. So where du and dv are the degree vertices of u and v respectively. So I'll just show you the correlation table. So we know that if you, how can we say that two data having a good correlation, either it has to be value -1 or +1, either it will be negatively correlate or positively correlate. So based on this literature survey, so here we can say that VL index have highly correlated with the octane isomers and also chlorinated biphenyl. So here you can see the values. So just I have given the table values. So I think octane isomers having physical properties like boiling point, melting point, entropy value, enthalpy of vaporization. Among them, only these four properties are matching. So, and again, physical property of PCB, so relative retention time. So it has a good correlation with VL index. So based on this, we can say it has a good impact in the to study in the in QSAR or QSPR. So just I have given the table value. So we have a lot of groundwork we have done, because octane isomers having 18 molecular structures and the PCB having 209 molecular structures. So whatever we have this graph, we have applied the VL index. So whatever the numerical measure we got, so we have compared each these 18 values. We have compared with each melting point, boiling point, entropy value, enthalpy of vaporization, so on. So among those, I found these values having a good correlation. So with this, using a statistical package for social science, so I have done the correlation. So these are the correlation which I have done. So further, I have extended this work by analyzing or by finding the bounds, lower bounds and upper bounds by taking in standard graphs. So, and also I have considered some nanostructures like nanotube and graphene structures, and I have applied VL index. So, and I have computed results so that we can study the physical features of their nanostructures or whatever it may be. So recently, I have mentored for CSIR online summer research training program. So few students have participated from various institutions. So they have extended, using this VL index, they have extended work like analyzing VL index by taking graph transformation. So by finding the upper bounds and lower bounds. So on by thinking few molecular structures, so they have computed the results. So they have done nice work. So so in very soon we are going to publish these papers in a good impact journal. So this is about how I have defined a new topological index. And we have done some application part in biological science. So this is a paper, one of the paper. So using human liver, we have applied the topological indices. So this is a normal liver and this is a cirrhosis of the liver. So unhealthy liver, you can say. So based on this, we have done the graph invariant. You can see the model of healthy liver. This is an approximate, not the accurate one. So with this, we have applied the double graph operator to this model of healthy liver. So here exactly what we have done, we have using the model of healthy liver, we have applied the topological standard topological indices and computed the value. And if we go on remove the edge sets of healthy liver, so and we have computed the topological indices and we have got some results and we have done with the comparison. So and we have some conclusion with this. So I'll just move on to the final one. So in the case of cirrhosis of the fatty liver, it is observed that the edges ranges from 284 to 264. In all these cases, it is available to take suggestion and treatment of medical personnel. Thus, it can be deduced that work proposes a model which is effective in diagnosing the defects in the cirrhosis of the liver. So when we go on removing the edges, we are going to consider it as a detaching of the healthy liver. So it becomes to when we have a cirrhosis of the liver, so what will be the computational values, and we have compared with that so that we can understand its characterization. So similarly, one more paper we have done, so it is published in Proceedings of Janjian Mathematical Society, which is a Scopus journal. So here also we have considered structure of alveoli, which is a part of a lungs, and we have done the graph invariant. So again, we have considered the topological indices, computed, done the comparisons. So and still further, we have to know at what certain this will be applied in a biological science, that we have to know. So these are all based on the literature survey. We have done all these things. So thank you so much. So,
Thank you, Professor. Thank you,
yeah.
Professor Deepika.
Yes,
It's a
yes.
wonderful talk, and it's really great to know about index, VL index.
Yes, sir.
Yeah, wonderful.
Thank you.
In view of the time, I'm sorry not allowing the questions. Maybe I request the participants to have a offline discussion with Professor Deepika. With that, I think this is a time for the lunch. People are waiting for the lunch,
Yes, yes.
to have lunch. I'm really thankful to all the speakers. We had an excellent combination of the speakers. They represented with different departments. And we have my sincerest thanks to all of you. You presented your passion. That's really wonderful to know. And hopefully, as VC sir was mentioning, we will continue this as a kind of the yearly program, and we will have the more interactions. And not only during this time, I request people to have more interactions with the other people. With this, I'm ending the session. Probably I will handing over to Deshmukh sir. Professor Deshmukh, are you available? Otherwise, Professor Vishwanathan.
Yes, sir.
Yeah, what's our next plan?
Mute.
Yes, sir.
Dr. Deshmukh, sir?
No, I cannot unmute myself.
We are able to hear you, sir, now.
Oh, is it? All right. Oh, great. No, there is nothing I had to add. I'm very grateful to the chairman for conducting the session so beautifully. We had great talks, and let's rush for lunch and get back for the next section. So thank you all very much. Let me not hold you anymore. Thank you.
Thank you, sir. Thanks a
The
lot.
next session starts at 2:15 p.m.
Okay.
Yeah, quick lunch.
Thank you.
I think we can start the session. Monali?
Monali, madam? Monali? Dr. Monali?
Yeah. Good afternoon, everyone.
Good afternoon.
Yeah, now I request Dr. Vaibhav, who is the session chair for our next session. Please introduce other speakers.
Yeah. Thank you, Monali, madam. Thank you, PCD sir, for arranging such a nice in-house symposium. And as our new education policy also emphasize on interdisciplinary research, which in a new education policy 2020 emphasize on interdisciplinary research. This is a very productive step in that direction, and we are knowing other department what they are doing, and probably we can also collaborate with other department in this regard. And today's session is related to the today's session is related to the wireless network and sensor system. Here again we will be requiring a collaboration from computer science department, even from a CSE department, electronics department. Anyway we have this subject. So on this note, I will request Dr. Jasma to start the session. Before starting a session, I will like to introduce Jasma to the team. Dr. Jasma Balasangameshwara. She is in charge HOD of a CST department, Computer Science and Technology department, in charge HOD of a Computer Science and Technology department. She is having a total 13 years of experience. She had done a PhD from Anna University, and her research area specializations are distributed computing. Sorry, Jasma madam. Over to you, Jasma madam. Jasma madam, are you there? Jasma ma'am, are you there?
Yes, sir. Good afternoon, and thank you so much.
Yeah, thank you.
I'll begin my presentation.
Yeah, so madam, try to stick to 20 minutes, and after that there will be a question answer session.
Sure, sir. Sir, I think I'll actually make the co-host for me to present my screen.
Yeah, mom, I think you can present it, ma'am. Please check it out.
It's saying
Just
host
check it.
disabled attending screen sharing.
Okay, I'll just do that. Okay.
I will call Imtiaz.
Yes, sir. I'm calling him. I'm calling him.
Imtiaz sir. Can you give access to Jasma madam, or she will be presenting, sir? You had made a co-host, sir. Jasma Balasangameshwara. Jasma. You had made a madam. Jasma ma'am.
Yes, sir.
I think Jasma has spoken to Imtiaz. He's saying that you are already a co-host, so you can present it just right out.
No, sir. Here it says host disabled attendee screen sharing.
Imtiaz ji, Imtiaz. It is said that my madam is saying that it is disabled. Just look into it once.
Maybe she has logged out and logged in again. I have to make her.
Yeah, please. Yeah, please check it out. Thank you, sir.
Yeah, maybe I have given him all the names. Probably if somebody is logging out and logging in again, then the co-host goes off.
So just we have to bear with 2 minutes, and he will be giving the access to. I think our Jasma madam might have been logged in and logged out. That could be the reason. So we are getting the PCB sir, thanks a lot. We are getting a lot of knowledge in this type of session, sir. We were earlier not knowing what are the other colleagues doing and what are their areas of specialization, but because of this in-house symposium, we are able to know that what others are doing and probably how can we collaborate with them. This is and this is probably the first time we are having it in our university, sir. Probably we should have this type of sessions every 3 months, sir. That's my request to you. So everybody will get
there is a plan to have a faculty seminar on a regular basis, like once every month, and that series of seminars will begin very soon and it will continue. But I think if we are ready for Dr. Jaswan's talk, so let's.
Yes, sir. I'm
Dr.
ready
Jaswan,
and I'm
please.
sharing. Yes, sir.
Yes,
I'll
please.
start. Thank you
Yes.
so much.
Yes.
I would like to thank the organizers of IHS and Dr. Siddhi sir for providing me this opportunity. My title is Hybrid Policy for Fault-Tolerant Load Balancing in Grid Computing Environment. This is one of my publications during my PhD, which I completed in the year 2013. So I'll begin with the problem statement. Problem statement is heterogeneous distributed clusters require high efficient computing platform for computing intensive applications. When we are discussing about compute intensive applications, these are jobs which require high end compute resources, basically the CPU. So the limitations of this work was published in the year 2012 in the Elsevier journal. So the limitations of the existing work was the accuracy of job execution time and the effectiveness of load balancing. Before I go on to the existing work limitations, I would like to very briefly tell you what load balancing is. We have the concept of client server, where there's a server which accepts requests from several clients, and these clients actually send jobs or tasks to the server. And if there are multiple clients sending a set of jobs to the same server, the server gets apparently overloaded. You have the concept of multitasking and multi-processing. We are looking at the concept of multi-processing here. So we have to actually look at a way wherein if there are several servers, how the load on these servers can be balanced. And apparently, the accuracy on load balancing and job execution time was one of the loopholes of the existing work. The second was data distribution scheme, which had not been studied. And third, network and hardware failure also lead to jobs not being executed on the server. So that was the third one, which were the limitations of the existing work. So the contribution of this article to the existing work, to the existing literature, is arriving at a performance-driven load balancing approach with fault tolerance for dedicated and non-dedicated grid environments. So before I go on with what dedicated and non-dedicated grid environments are, I'd just like to take you an example of a non-dedicated grid environment. So all of you are able to see my screen, right? So this is an example of a non-dedicated grid environment called the World Community Grid. So what is a grid? Basically, it's a collection of compute devices. It can be a laptop, desktop, mobile phone, or a tablet as well. The resources, when I'm referring to the term resources, it means the CPU, memory, bandwidth. These are the typical resources which is required for any task or job to be executed. Example of a task or job can be as simple as a set of series of random numbers, an analysis on a series of random numbers, like adding the series of numbers. These numbers, if they are small in nature, say a sample size of 50 to 100, it becomes easy for a computer to perform the task. However, if it is running in petabytes and zettabytes, it becomes difficult. So here, World Community Grid is a platform by IBM, and we'll read about the kind of work that IBM World Community Grid is basically doing. So there's a small piece of code that can actually be installed on a computer, and then each computer, whenever it is idle, when I say idle, that means it is not performing any compute intensive application. How do I know my computer is performing or a laptop is performing a compute intensive application? You can go to the task manager, right click and check on properties, and you'll see the amount of compute resource used. So a small piece of code is installed on the computer. It can be on a desktop or any computing device. And that program actually uses the ideal cycle resources in order to solve a lot of problems. So we look at some of the problems that this is an example of a non-dedicated grid environment. It is not dedicated because here at the same time I can be running a MATLAB program, and at the same time the idle resources can be used to solve a lot of problems. So I look at some of the problems that can be solved. Actually, I have installed the software on my idle computers and desktops and part of it. So, so you have this Africa Rainfall Project and microbiome immunity project, stop tuberculosis, smash childhood cancer. So these are some of the problems that this non-dedicated world community grid is solving. And all that I have to do is to install a small piece of program which is supported by IBM on my computer. And whenever I'm not using my computer and the program has sufficient resources that it can use or rely on from my system, it will be part of pooled of the other set of resources, and then I'll get a certificate that I was, part of. When I say I have not done anything as such, it is that my computer on which the small piece of code was installed is part of the project. I also get the option of picking which project that I would like to contribute to: mapping, cancer markers, and so on. So this is about non-dedicated grid environments. I'll be giving a very quick overview of what a grid environment is in later stage. And dedicated is when you're using it 100% to solve a specific problem. So the major contributions of the work was it was able to estimate the resource efficiency in fault tolerant scheduling, and also eliminate the state information collection complexity of a code of a node. So coming, this is what I'll be covering. So introduction, what is grid computing? Grid computing, it uses a parallel processing architecture wherein CPU resources across networks, distributed heterogeneous resources from various regions of the world are put together to solve a particular problem. So when we talk about solving a problem, we're only discussing about solving one problem. Example, mapping cancer markers can be one problem for which lot of compute resources are put together, pooled together to solve one problem. So there's no chunking that happens like in cloud computing, wherein the GPU or the CPU say has 2 gigahertz, and then 1 gigahertz is used for one to solve one problem, and the remaining 1 gigahertz for other. It doesn't happen this way. Grid computing basically deals with parallel processing architecture where the entire grid systems are used to solve one problem. So this is the grid topology. Intra-grid is two buildings within the same office. It can be extra-grid, can be buildings across offices, and intra-grid is nothing but the internet. Okay, so the features of grid computing, it is geographically distributed, heterogeneous, meaning to say that the processing power of my mobile phone and laptop is different. So, it takes that into consideration. There should be resource coordination, transparent access, resource sharing, and so on. In the types of grids, today's emphasis will be on computational grids. There are other types of grids as well also. So I'll be focusing on computational grids, and we have already seen some of the applications on the World Community Grid, which is maintained by IBM. Okay, so we'll go into the literature survey. In the literature survey, I'll be only emphasizing on what this article is focused on. We'll be focusing on the dynamic structure of computational grid. When I talk about heterogeneity, it is resource, which is compute, job heterogeneity, and network heterogeneity. And we'll also be looking at different load schedulers and resource policies, as well as the job resource requirement. This article does not deal with security. Comes to classification of schedulers, this article is based on resource-oriented schedulers. What is a resource? I've already told that it is CPU, network, and memory. Memory can be RAM and ROM, and also hard disk. So now coming to grid scheduling. Out of all the techniques, the article emphasizes on immediate mode scheduling. Immediate mode scheduling is as soon as the job arrives, it should be scheduled. Non-preemptive, once the job is assigned to a server, it cannot be preempted. And the phases that are considered is resource discovery. That means when a job is pulled, what are the ideal resources that can be assigned to the job, selection of the system, and execution of the job. These are the three phases in which the scheduling on a grid happens. Now coming to types of scheduling, these are the different types: centralized, hierarchical, and decentralized. This article emphasizes on decentralized scheduling. Meaning of decentralized is the compute resources are distributed across geographies. And versus static versus dynamic. Dynamic scheduling, as in when the job arrives in real time, the scheduling happens. Okay, so now coming to load balancing. Load balancing is distribution of workload across servers to ensure that no server gets overloaded at any point in time. When you're talking about overloading, there is an algorithm which actually computes the threshold. Based on the threshold, we determine whether the server is underloaded or overloaded, and we're discussing the algorithm shortly. Okay. So again, when we come to load balancing algorithm classification, this article considers dynamic load balancing, non-preemptive at the grid level, and the information that we are referring to here is partial information because global information has an overhead, and that is one of the limitations that this article overcomes. And when it comes to sender initiated and receiver initiated, the load balancing is initiated when the server actually receives the load. We won't be going in detail on these policies. Okay. Now, along with load balancing, another important uh, constraint which is also considered in the article is fault tolerance. So let us say that a job is assigned to a server and the server fails, then it's likely that the job will not complete its execution. So this application also considers fault tolerant to ensure that there's a backup server. So there's a lot of primary work which is done already in this area, but basically we have taken a different approach that I'll be explaining to load balancing fault tolerant scheduling. Hence the term of the title of the paper is an hybrid policy. When we're talking about fault tolerance, there are two ways that we can actually achieve fault tolerance. One is passive scheme. Passive scheme is when the jobs are pooled in queue, we decide in advance as to which job has to be allocated to which server. Active is the jobs are transferred between the servers. So this article considers passive replication scheme. When we're talking about replication, the copy of a job is replicated across several servers based on some criteria, which will be discussed later as part of the algorithm. There are two ways that we can achieve passive replication. One is backup overloading, the other is resource reclaiming. Backup overloading, as the name says, we have a backup server which actually has a backup copy of the task or the job, and this is only activated if the server fails. And resource reclaiming is reclaiming the resources in any case if the server is unable to execute the job or if the server has failed. Okay, so the a model for hybrid fault tolerant load scheduling policy. The first one is the system model. We'll be discussing the design of the system. A site is a cluster. It can be a cluster with several resources, or it can be a cluster with just one compute node. So when we talk about a compute node, it can be one CPU or it can be a rack of CPUs put together, and the selection of slides. Then we have the application model. LB stands for load balancing, fault tolerant model. Here we are considering dynamic load balancing and the results. So we'll look at the model of what is considered in this paper. The design of the system environment. So this was simulated using the GridSim simulator. There is a simulator called GridSim, which helps in simulating the nodes. It is similar to, we have NS2 network simulator. Likewise, there's also a simulator called GridSim. So this was actually simulated on GridSim. So we had a grid environment. The details and the spec of the environment will be shared after the uh, algorithm is described. We had a grid scheduler, and there were two messages. One was a join message when a site would like to join, and a exit message when the site would like to reclaim or give off its resources. And the site, which when I talk about a site, it is a cluster, will also specify the time and level of its contribution. So I've considered the example of a non-dedicated grid environment and not a dedicated grid environment. A dedicated grid environment will only focus on solving one problem by using all of its resources. Non-dedicated grid environment will also focus on solving one problem at a time, except that its resources are not dedicated full time until the problem is completed. Okay, so sorry, this is not very clear. So I'll just quickly explain this diagram. We have a grid client, and what is the role of a grid client? It has to submit a job, and there is a local grid scheduler. The local grid scheduler is local to the cluster, and then there is a load balancing decision maker. The steps are numbered in the order, and the same paper is available online for download. You can go ahead and download it to check on the steps, as it is not clear here on the slide. There's a site selector. There's a program which actually selects the site based on criteria, and then a job is dispatched to the site, and the fault tolerant or detector keeps checking if the site is capable of executing, not executing. If it fails, then the information is a message is transmitted to the fault manager, and which will in turn inform the remote grid scheduler manager, and then a remote signed interface comes uh, takes care of this. All of these are small pieces of functions, modules which can be settings can be done on the grid computing platform. And finally, during this phase, if there is a fault that is identified, then the job is there's already a copy of the job on another server, and that server is a trigger is sent to the server to start executing the job. As we are taking a non-preemptive approach, a job should, whenever it's assigned to a server execution, then either the server has failed or the server has got overloaded. And the objective of this article is to ensure that balancing of the load happens. So we have the concept of defining effective sites. What is an effective site? A site which is capable of handling the job. So we have these parameters. When we talk about a variable is actually the different types of resources. Variable I can be a compute resource, storage, or it can be a network resource also. Now site selection. So as I mentioned, there is a derived threshold which is used to select appropriate sites, and anything above the threshold, a site value above the threshold, the site is considered to be non-effective. Below the threshold, the site is considered to be effective. So how does the derived threshold computed? It is computed based on load. How is the load measured? It is measured in terms of million instructions. Load is nothing but the number of jobs, and each job measurement is based on the job length, which is number of million instructions, and the resources which are required for job execution, and the sites which are within the threshold are considered effective. So this article considers a stable grid environment to consider whether the site is effective or not. An unstable environment is something called mean time to failure. If the sites have a high mean time to failure, then such environment having more number of such sites is considered an unstable grid environment. Okay, now coming to the dynamic load balancing policy used in this article. It is initiated when one of the following conditions are met. The site cannot continue to provide resources. The actual execution time of the job, the execution time is calculated in milliseconds, of a job exceeds the estimated execution time, or the site is overloaded. So the objective is to select it's an optimization problem where the objective is to select free effective sites. And once the job is assigned to an effective site, it is not removed until the site completes its execution. And we are using a passive backup approach, which is called the primary backup approach. That means there's a primary site as well as a backup site. And if the primary site is successful in executing the job, then the resources are reclaimed from the backup site. Okay, and we also use an information policy. In the diagram, we saw how the information exchange happens between various modules of the program. Okay, so now we have the concept of threshold. So how is the threshold computed? The source load, the load on the site is the source load, and then there is a table which is sorted on in the ascending order based on the load. We have the velocity, which is source load minus the lightest load, and we also compute the second lightest load, which is the load of the second ranked site in the set, and then we arrive at the threshold, which is lightest load minus second lightest load. And while the velocity is greater than the load threshold, we submit the job, and then we update the source load and the velocity. This is the load adjustment policy. Okay, now coming to the comparison, these are the existing works. Distributed fault model, tolerant model, which uses a replication strategy, and timer-based reservation scheme. We haven't used a timer-based reservation scheme. The meaning of timer-based reservation scheme is the resources are reserved for a certain amount of time, and there is this minimum completion time. According to this algorithm, a CPU resources are selected based on whichever job can be completed at the earliest. And then there's also another approach called min-min approaches. All these are existing works, and our work is compared against these existing works. Min-min is a combination of CPU resource and jobs that consume the minimum time. Okay, the assumptions for simulation. I think I'm running out of time, so these are some of the assumptions. I'll only go through the first one.
Jasma madam, can you please?
Yes,
I think time is up.
Yes. So also there is a resource efficiency estimation model, which is based on three values: -1, 0, and +1. -1 to indicate that the job is finished, 0 if there is no job, +1 the job is unfinished. There's a performance benefit function that is calculated. Trans in, trans out is the transmission of the incoming from the source side to the destination side, where the source side submits the job, the destination side has to execute and deliver back the result. And yes, coming to the fault tolerant model, we have the boundary schedules. This is to ensure that no two jobs overlap with each other. The timings of the jobs don't overlap with each other. Such thing is called as a overloadable backup. Again, this is another algorithm. So the boundary schedule is executed, it's invoked if and only if there is an existing schedule which is primary, which is the one to which the job was assigned, or it is non-overloadable backup schedule. Okay, the eligibility for a schedule, there are two eligibilities: if and only if there's a time window and there is no overlap between the primary schedule and the backup non-overloadable backup schedule, and they should not exist any primary schedule such that the start and the end time overlaps with the backup schedule. Of course, the experimental result was totally simulated using Blitzen. The number of resources considered was 1,000. Number of machines per resource. The job, these are the number of jobs. The job replicas was only one, which means to say one job and one replica. The job length is in million instructions. The processing capacity is also measured in million instructions per second. And the performance metrics, all of these are the performance metrics. The most important one were replication cost and reliability cost. So it defines the percentage of jobs that can be recovered when a failure occurs. So this actually refers to the ability of the algorithm to tolerate faults, and this represents the ability of the algorithm to minimize the processing time used for backup jobs, and of course the response time and load balancing time. So these are some of the metrics which are used and how the calculations were done. And a comparison of one article that was considered, which is called desired algorithm, the contributions of the algorithm and the limitations, and how this article overcame the limitations. And this is a detailed comparison of the other existing works that were used as part of the literature survey for coming up with this the research on this topic. So I would like to thank, and these are some references. Thank you. Any questions?
Thank you, madam. There is a question from our dean, sir. I think, in case where there are some local computing resources and the cloud, how do you optimize the local resources and the cloud resources? I think you can also see this question.
Yes, sir, I can see. Sir, if there are local resources, then if there is a job and this job can be executed optimally on the local resources subject to the availability of the resources on the local site, then the job is ideally transmitted to the local site. If the issue with cloud is basically these cloud resources are far away and the amount of time taken to transfer a job from a local site to the cloud is high. So it's an optimization problem where the objective function is to minimize the processing time, at the same time not overload the site. So first preference is given to local site, and if the local sites are already overloaded, then the next preference goes to cloud sites. When I say cloud, it is geographically distributed, and again in the cloud, this is concept of content network servers, So the servers which are the next closest to the local site is given preference to. Hope this answers your question, sir.
Yeah, thank you, Jasna ma'am, for a wonderful presentation. Now, can I request Dr. Pushpamala ma'am? If any other questions are there, it can be taken offline. Now I can, because of the time constraint, can I request Dr. Pushpamala ma'am to present? 1 second. Pushpamala madam, are you there? Pushpamala ma'am?
Yes, sir. Yes, sir. I'm there.
Yeah.
So can you see my screen?
Yes, ma'am, it is coming. Yeah, it's coming. Just a moment, ma'am. I will introduce you to the audience and then you can start the session. Dr. Pushpamala ma'am, Dr. Pushpamala is assistant professor in Department of Electronics and Telecommunication. She is having a total 13 years of experience. She had done a PhD from a JN University. Her research area of specializations are signal processing, environment modeling, and low power designing. She is also having a VGST project in our department. Over to you, Pushpamala ma'am.
Thank you, Vaibhav sir, for the warm introduction.
Yeah.
I would also like to thank the organizing committee and PCD sir for organizing such a wonderful event. First of all, before I begin my presentation, I would like to wish all the participants over here a very happy and prosperous Dasara. Now, I'll be talking on my VGST project. It is a pilot study what I'm doing. So the system which we are building is based on sensors to study the native environmental conditions of stagnant water. Now, the outline will be like we'll be introducing why we should study what is the need to study the environmental conditions of stagnant water. Then water network management, how do we do network management, and a pilot study for a geographical information system based solution, and the solution is completely based on a data set available for UK, and results what we are achieved, and some concluding remarks. Now, before I start the presentation, let us know what are the potential well water contaminants. I'm speaking about stagnant water. Stagnant water, an example of that is well water. So what are those contaminants and what are that implicants? So some of the contaminants are microorganisms, bacteria, viruses, parasites, nitrate and nitrates, which are nothing but chemical fertilizers, human sewage, animal waste fertilizers. These animal nitrate and nitrite fertilizers, if they run off into the underwater or the well waters, they cause something known as blue baby syndrome. Next, we have heavy metals, which is because of plumbing and service lines. Now, all our water is through our iron pipes, and some mining operations, petroleum refineries. The areas which have mining operations and petroleum refineries, they have more of this heavy metal content present in the water. Then some organic chemicals, ink, dyes, pesticides, radionuclides, fluorides are also present in stagnant water. Now, why should we think about water management? To avoid all these impacts of well water contaminants which we have discussed, we need to solve the issue. So we have to think about water management. So management can be done in two processes. One is water network management, and the other one is geographical system based solutions. Now, water network management we have to do through data collection, measurement, and analysis. The other one, what I'll be discussing, is geographical information based system based on supporting coordinated decisions. Now, this water network management, we have built a model to deal with this network management. It is a real-time study. Since it's still in the prototype, we have only considered dealing with turbidity, turbidity and pH of measuring the turbidity and pH of waters using sensors. Then we have tried to analyze the diffusion pattern of dissolved oxygen temperature of the stagnant water, and what is the hardware we have built, and how the cloud based data we have mapped the data onto the cloud. Now, the next part, what we are going to show is a surface database study, which is based on surface contaminants. What is the amount of contaminants present on the surface of the water, and how those contaminants vary throughout the year, or how those contaminants vary with respect to other parameters, wind and other things. Now, for the water network management, first we had to build a sensor model. So I've shown some sensors over here. One is the pH sensor, dissolved oxygen sensor. We have used turbidity sensor and some transmitter to transmit onto the cloud. And we had one BMP sensor also. It is a pressure sensor, pressure and temperature inbuilt sensor. We built a prototype like this, and for this prototype we had to design the PCB. It had to go on to the PCB. This was built on breadboard, and this was put on the PCB. So we can see the PCB architecture over here. I have the BMP sensor over here, and this is how PCB was built using Eagle tool, a PCB tool Eagle. Now, after the circuit is built, the circuit had to go into some sort of enclosure which can go into the waterproof enclosure, so that we can take the readings. Now, for that, one example of such thing which is already existing is the one built in Michigan State University. They've built this fish. This fish has one GPS model and DO sensor, dissolved oxygen sensor, and it has a Zigbee antenna. This fish was used to obtain the diffusion pattern of rhodamine B solution in saline water. Along with this DO sensor, they also had a TILOS sensor imbibed inside this fish, which was used to build the it was used to detect the diffusion pattern of rhodamine B in saline water. And this fish was left floating in the water, and they could obtain the diffusion pattern on the surface. So this is the surface diffusion pattern, initial diffusion pattern, and over a time how the diffusion has happened in this saline water they could detect. Now this study has not gone into specific impurities or specific contaminants present in water. I'm considering a study something about molecules greater than 2.5 micrometers. Now for this one, this is one fish which is available. So we built another structure known as, there's another structure known as glider. So for detecting this, I've used something known as the glider design. Now, why did I settle down for glider design than the other design, previous design was, this glider we could fabricate using 3D printing. So we went for this glider. And another thing is, you can see in this diagram that the glider provides for downwards movement. At the same time, it can also float on the surface. Considering this aspect of moving downwards and floating on the surface, it would be easier for me to capture the data. Henceforth, I've gone for this glider design. And the complete circuit PCB what I have made is placed inside this glider. This is a prototype of the glider. And here you can see we have the dissolved oxygen sensor, dissolved nitrogen oxide sensor, buoyancy controller. Now again, since it's a glider, we had to control the buoyancy also, whether it is floating or whether it is going underwater. So we had to go for this rotation thrust motor over here. We placed a rotation thrust motor. This controls the movement of the glider underwater, and the buoyancy controller which controls the movement of the device glider on the surface of the water. And we also had one linear thrust motor to propel the device forward. And the structure something came up like this, and we can see that the length of the structure was 78 millimeters. So it was a bit lengthy. So the next thing will be we had to reduce this. Tentatively, we had to divide the structure since we couldn't print it completely. We had to divide the structure into 4 blocks and join this using from after 3D printing. And we had kept one enclosure where we can place our circuitry. Below this, we had knobs. So we could open the knobs, automatic control of knobs, and make sure that the sensors could detect the quantities required, parameters associated with that. So this is something which we used for buoyancy chamber. It was again 3D printed. We used a rack and pinion method to build this buoyancy controller. For the testing purpose, we had used a syringe to check if the device was working fine. and the buoyancy could be meant, we could get the buoyancy, we could achieve buoyancy through this. And next thing is we had to capture the data. So we could capture the data. Once the data is available, we had to perform this analytics. So these data, whatever was captured from the device, if you can see the previous circuitry, I had a transmitter. So here I have a transmitter. The data collected from the transmitter is we transferred the data, or we store the data on the cloud over a period of 7 days to 15 days. Now once that we got the data, if you can see, we had to perform analytics. To perform the analytics, we had the first step was collecting the data, next was processing the data, next was storing the data. Then we could analyze and build our analytics and reports. So collecting the data was well and good going on with us, and it was put on the cloud, and we processed everything. Storing was also happening in whatever cloud IoT platform was available for us. We used Amazon IoT Core for connecting the devices, and that was run through Node MCU. And IoT analytics for making this whatever data we had captured, we had to make it error free. So we used IoT analytics for making it error free. Then we used another Amazon tool, which was QuickSight, that was used to we could get some results. It is like deductions. We could obtain some inferences from that. So we used Amazon QuickSight to detect inferences on the IoT data. Now, once the data is stored, there were different methods to analyze the data. We could bring our own custom analysis. We could run standard SQL queries and run machine learning approaches. Now, this project, first approach, what we have taken is we only taken few parameters. We have not currently considered the contaminants present in the water. We have only done a pilot study. So for that current data, we used standard SQL queries to build our analytics and reports. We took a database from GitHub, and it was a database for UK environmental conditions. For those conditions, we have run machine learning. We have run machine learning approaches. Now, what is the next thing? What we have to do is we have to map this machine learning analysis to the real-time data of real-time contaminant crust, which is present in stagnant water, which is still pending, and we build the analytic reports. So in the first part, what you have seen, I have shown the output values on IDE serial monitor and also on the IoT dashboard. So you can see that I've written standard SQL queries. I've adopted standard SQL queries, and here you can see that we have the pH values, different pH values, and other things. And this was our IoT analytics. The analytics I have shown over here is only for 24 hours. So it is starting from 8 a.m. to 2 p.m. What was the pH from 8 a.m. to 2 p.m.? What was the turbidity from 8 a.m. for 2 p.m.? Temperature and dissolved oxygen. This was measured for a standard well which is present in the house. So these are the values which we have got. And once these values were stored on the cloud, we tried to plot it. So when we could plot it, we have I've shown some plots for turbidity, temperature, dissolved oxygen, and pH. So we can see that this is the temperature plot from 11:55 to 10:45. Most of the time the temperature will remain warm, but except during duration of the night, duration of the night, where the temperature drops down, and later it neutralizes and it returns to the warmer conditions. So this is something we have got. This is another plot we have got against temperature with respect to time, detailed graph. Now, the second study, what we have done is a surface study of water insoluble particles. So here it is, we have a data set of 997 images, and the water insoluble particles, what we have considered is those particles which float on the surface of the water. Floating on the surface of the water means the density will be less than 997 kg per meter cube. And such particles are nothing but combustion compounds, organic particles, and metals. Currently, the study is focused on particles almost equivalent to 2.5 micrometers. Particles almost equivalent to 2.5 micrometers are also aerosolic in nature. So this measurements, this image what we have got, or the data set what we have got, has the data was captured using tapered element oscillating microbalance, or the other one was beta attenuation monitoring. Was though they were the devices that was adopted for accurate particulate matter measurement. Now again, PM is a term, particulate matter measurement is a term used for air, but I'm here using this term so that it is easy for analysis. And we have used machine learning approaches to build empirical models to predict the data. All this data set is related to surface impurities on the surface. Not in specific, it is not a particular image. So if we have to go for a particular impurity, if I have to narrow down whether I have some iron components floating on the surface, and what is the density, what is the amount of iron components present within the water, heavy metals, all such things, we have to go with some other analysis. So we have to narrow down on that particular set, what type of analysis we have to do. Probably we are assuming to go for thermal and thermal imaging. But even if we go for thermal imaging, I have to get the thermal profile for lead and other aerosolic components. Then only we can go for that. So if we have to adopt machine learning approaches, we have to get the data set also. So let us see how this will work out. And these are some of the experimental results what I've obtained for this data set which is available. So one such experiment is it is PM 2.5 measured over a month. So you can see it is measured for over a month, and the graph is something like this. There is a linear decrease in PM level in the 5th month. So this is from Jan to December. There is a linear decrease in the 5th month. Sometimes there is a spike in the values in the 6th month. See, 6th month we have some values, and in the December and in the Jan, the values will be almost similar. This will also give you something like cyclic approach. The PM values will be cyclic in nature. We'll come to that cyclic thing. And the maxima, there is a time when maxima is reached. So in 10th month there is a maxima is reached, and you can see most of the variations will be observed in 1st month and the 12th month. Now from this graph we could infer that the PM concentration was high during winter months, November, December and January, and it was low during summer and rainy seasons. The next one is variation of PM levels every hour in one day. So we have taken this variations for every hour and every hour. Now the spike of the values was observed in the 3rd and 4th hours of the day, and maximum was reached on the 17th hour. 17th hour will generally be 5 p.m. So it was generally reached during 5 p.m. as per UK timings. And the minimum was somewhere during 4 p.m. So where there is less amount of movement. And there were some variations observed during the 2nd, 3rd and 4th hour of the day. So from this graph, we could infer that the PM concentration is high during the peak hours of the day. Another thing is PM 2.5 varied according to the wind speed. So based on the speed of the wind, how this vary? So there was a linear decrease in PM level as the wind speed increases. And there was a spike of the values in the 7th speed unit. Again, the speed units, we have defined the speed unit, different speed unit, first 2, 3, 4, 5, 6, 7 we have done. We have defined different units. Maximum was reached in the highest speed level, and minimum was reached during the 34th speed level. That was 0 and 1. And we could see that the most of the variations were observed in the 1st and the 2nd speed level. And from this graph, we could infer that the PM concentration was high when the speed is low. And when the speed was high, the particulate matters were getting scattered over the area. And this is we obtained various graphs. So I've tried to place all those graphs in the facet grid. Whatever we have discussed over here, we did analysis for many such parameters, and all those parameters are placed in this facet grid over a time, hour, wind speed, temperature variation, and other parameters which is affecting the particulate matter. Next is we went for a clean plot, which is in terms of violin graphs. This was in terms of violin graph. So here you could see that when there was a decrease in PM level in the 5th month, we could see that there was a decrease in PM in the 5th month, but there was a further decrease in the PM in the 8th month. And some spike values was obtained in 6th month, which is also similar to the previous graphs, but this is a cleaner way of clean study. And the maximum was reached in the 11th and 12th, as we have seen in the previous graphs. And the other thing what I wanted to discuss is we were thinking about checking the nature of the PM concentration over the cycle. So over a cycle of 365 days. So to obtain this cyclic values, we had to go for converting. We had to get something known as 360-degree network, 360-degree figure. So for this, we couldn't use 0 to 360 degrees. So this direction, the circular figure was generated based on cardinal directions. And we got this cyclical direction and we converted into circular values. And this was how the cyclic variation looked for both month and hour. I've shown in one graph the cyclic variation of PM 2.5 for 1 month and 1 hour, and this was a similar one with fever values. So I would like to conclude my session. The current approach, what we are using is only robotic sensors with limited sensings and motion capability. But the next thing would be to upgrade it to higher sensing capabilities and something which would have better motion capability in calm waters. Then we have to perform investigations on adopting distributed control algorithms, so that using a distributed control algorithm, we can autonomously plan the motion path. Now, if this could be achieved, this same model can be used for monitoring the floating waters like rivers and riverbeds. We can use that. Again, when we come to distributed control algorithms, I would like to give an example. China developed one glider and it was left floating in I think China Sea, and it was there for around 30 days. It was left floating and the data was captured, and this was recently done. It was around 2018. So we could do something like that. We can think in that aspect. Now, this proposed platform, whatever is designed, is providing for remote environment monitoring of stagnant water bodies. If distributed control algorithms could be achieved, then we could monitor the water bodies, which is both stagnant as well as floating. And next one is imaging analysis for real-time images is currently the pending work which has to be done. So as I told, we have to go for thermal images. Once the profile is ready, we can go for that. Thank you.
Thank you, Pushpamala madam. Thank you so much. At present, there are no questions here, but we thank for your wonderful presentation. And it's your VGST sponsored project, and you are doing a good work into this direction. We have got a good knowledge onto this robotic platform that you are using. Thank you very much. If any questions are there, then please post your questions in the chat box. But at present, I am not seeing any questions here. There are 2-3 comments saying that good work and good presentation from Sarvana, from Rajeshri madam also. Excellent work, Pushpamala madam. So congratulations, Pushpamala madam. Thank you very much.
Yes, sir. Thank you, sir.
If any questions are there, you can take it offline with the Pushpamala madam. Thank you very much.
Thank
Now
you.
the next presentation is from Mr. Dr. Manu. Dr. Manu Ilappa. He is from CSE department. He's having 1 year of experience. Very nice. He had done his PhD from National Institute of Technology, Rourkela. Area of research are IoT, wireless, and networking. Over to Mr. Dr. Manu.
Thank you, sir.
Yeah, welcome, Mr. Manu.
Yeah, thank you, sir, for the
Are
introduction.
you able to share the slides, Manu?
Yeah. So once Pushpamala ma'am stop presenting.
Yeah.
Yeah, I'll start. Yeah, sir, can you see my screen?
Yes, Manu, we are able to see. Thank you, Manu.
Yeah.
Please carry on.
Yeah, thanks.
So Manu, you have 20 minutes with you. Try to finish in a given time.
Yeah. Thanks.
Because we are already running late
Yeah.
Next session was supposed to start at 3:15. I think PCD sir has to take a call whether we have to break for a tea or not. So that we will be able to finish.
No, sir. In a schedule, we don't have any break now.
Yeah, that's what I was thinking. If that 5 minutes can be compensated.
Yeah.
Thank you.
Thanks.
Over to you, Mr. Dr. Manu. All the best.
I'll be presenting about the networks, the design for the design of protocols for network survivability in WPAN, wireless personal area networks, specifically for IoT applications. This is actually my PhD work, which I have submitted, which I have defended in the last month in NIT Rourkela. So I'll be just explaining in an overview what exactly I have done, and I'll be presenting in brief what are the contributions, and I'll be focusing on the future directions that I have just identified to move on. Before I start, I would like to thank the organizing committee for giving me the opportunity to present in this event of symposium, so that I'll get the feedback and some suggestions from the other faculty group. And as I said, as a new researcher, fresh researcher, I would like to get some suggestions from the group. So to start with, these are the just introduction, the outline, but I'll be just explaining these contributions in a brief. I'll try to just cover the gist of these contributions. And to start with, as we all know, the wireless network, a broad area of wireless networks are classified based on their operating space, like local area network, metropolitan area network, wide area network. Particularly the personal area networks works in the personal operating space of a human being or the machines, a very limited area in the personal operating space. So again, based on the capability of the network, the data rate of the network, the personal area networks are further classified as the high rate, medium rate, and low rate. The medium rate WPAN, we all use the Bluetooth, which is for the communication between the handheld devices and all. And the high rate that WPAN are actually for the standard is for 802 for high rate WPAN is 802.15.4 IEEE standard, and it's for the multimedia communication, wideband communication. The data rate is around maximum of 255 Mbps, and we focus actually in this work we focus on the low rate WPAN, low rate wireless personal area networks, which is actually the standard is IEEE 802.15.4 standard with a maximum data rate of 250 kbps. And these WPAN technologies, there are many WPAN technologies like sensor networks and the broad area networks and M2M systems and RFID. These systems are together connected for a common objective, and it's a new the paradigm called Internet of Things. Actually, in the last decade, 2010, 2011, 2010 decade, and the early part of this decade, the idea was to have, the motto was anytime, anywhere, any media. But the idea of Internet of Things is to include the word anything into this motto. So to connect everything, connect the real world objects into the communicating network. So wireless personal area networks holds a big hand in getting this Internet of Things into existence. So the protocols at different layers for in the protocol stack of this WPAN has to be developed, jointly designed to facilitate this Internet of Things applications specifically. So one example application for Internet of Things can be like this. It can be a remote healthcare application. It can be a elderly care home or a hospital ward where many people are many patients are old age home. Many patients or many people are admitted to, and they may have weird body area network, and these body area networks forms a mesh networks, and this would be an application network where the actual application happens, and this would be connected to a gateway node, and it in turns connect to the internet backbone, and the multiple users can be using this the data from these networks, and they can give directions to the take carers or the persons who are the nurses, doctors, like that. So this is an example application, and for IoT actually there are many applications like home automation, smart cities, industry the manufacturing, the industry 4.0 manufacturing processes, and agriculture, smart agriculture, environmental pollution monitoring, like that. Many applications are there for IoT. And all these things when WPAN actually when we are talking about WPAN, the network survivability or because these devices are small sensor nodes and kind of less sophisticated devices, low power, low rate, less resource constrained devices. So it is important to make the system network survivability is an important attribute here to consider. Many researchers have pointed out as network survivability. Many researchers have different opinions, like network survivability. Some are pointing out like it is the connectedness of the network. And but actually for an overall view of network survivability, it has different stratifications. Like it has different at different aspects we have to get the networks survivable. So like the communication framework, the communication network framework has to be survivable, and the entire system should be fault tolerant. Like if any faulty node is there, it has to get recovered, or somehow the network's operation has to get recovered. And also the other aspect is the security aspect. Of course, it is a major concern in America and all. Many researchers has happening for the security aspects of IoT. So networks cannot be survivable without security aspects, without make it more secure. So in this research, I have focused on the communication framework, how to make it more suitable to enlarge, to prolong the network survivability. So this in the case of communication framework, this also has to we have to attain this at different levels, like the path survivability, the link survivability, and the node survivability, and also at the entire network topology level survivability. So the paths are in the routing paths, and the link between two nodes, two peer nodes of a hope, and the node itself, each single resource constrained node itself, we have to make it less congested with package burst, and as it is some network devices in IoT and WPAN would be of battery powered, so we have to use this energy, the energy efficiency, like the battery the lifetime prolonging. We have to make all these things into consideration. And the last contribution which I have proposed here, it's actually we developed a tool. It's a Python based tool which actually try to get the data from a functioning network and try to get the data about how the overall working of the topology is as good. We try to compare it, means whether it is working as think in the phase of the design process. So at different levels, topology level, node level, path level, and link level, we have to maintain the survivability of the network. So I'm just skipping this literature survey, and the objectives have to. But what I have done is we have developed a routing at the network layer, routing layer, and the channel allocation at the MAC layer, the channel allocation. We developed two protocols, and we could publish it in to internationally indexed SCI journals, the routing protocol and MAC protocol. The first two contributions, it has been published. And third contribution, what we have done is the developed protocols has been implemented in the real operating system of the real operating system, which is used to upload into the real sensors. Like Contiki OS is a real world operating system which can be installed in these wireless sensors. So I have implemented these developed protocols. In these works, we have tried the works using the network simulators. I've used the network simulators to 2.35 and NS2 2.35, and those protocols actually implemented in the real IoT operating system, that is Contiki OS, and also it has been uploaded to the real hardware modes, which is actually it's using a virtual lab. There is a virtual lab in France. They have a facility. It is called FIT IoT Lab. And we have implemented. We can access the operation is like they have mounted many sensor networks and they have connected that to the internet. We can access those networks, those nodes through the secure SSH connections. So we can actually upload our Contiki OS, our installed OS, which is having the routing and MAC protocol implemented. I'll be uploading that in, operating system into their modes. That their working is like that. So then we can do the experimentation. That is one contribution. Then, as I told you, I developed a software tool, a Python-based tool, it should be in Contiki OS itself. There is a simulation environment Kuja, and from that, using a collective view plugin is there. Using that, we can get the data, the functioning data of the network with each node, what is the remaining energy, what is the packet success probability of those nodes, and what is the next hop node towards the destination, and all those data, the IP address of the node, like all the data, the local data will be getting from the functioning network. And using those data, the entire topology has been reconstructed using the developed tool, and also checks how this the functioning has been made, and whether it is the performance metrics are reaching or not, like that. And if it is not, we can find out, we can pinpoint at this point there is a packet drop, like that. It uses the Python-based tools and the NetworkX module for the Python, from the Python library has been used to reconstruct the network structure from these local information. So in routing protocol, we have used, this is the routing choice selection path choosing factor. It is actually of 3 components. The survivability factor rho and the SINR value of the path between the first hop, the current node and the next hop node, and the congestion level at the next hop node with the weighting coefficients alpha, beta, gamma. And along with these three, this path choosing factor will be choosing the path which has the highest path choosing factor. The node will choose the next hop node as the next hop node for the data to be traversed towards the destination node. And it is a destination. The protocol works in three phases actually: the route setup phase, and the data communication phase, and the route maintenance. And in route setup phase, actually, it is a destination initiated process. The route setup is a destination initiated process, and it actually goes backward to use the principle of optimality. And while reaching the source node, it will be knowing the multiple paths towards the destination, and it will use the path which has the highest path choosing factor for the data communication in the communication phase. And this is the entire work, the flowchart for the entire working of the protocol. And during the maintenance phase, it will check for the threshold value. The threshold value is set for this survivability factors. Whether it is coming below that, it will reinitiate the route discovery, the route maintenance, so that the route is fresh and valid. So these are the algorithms, and we have compared with some the state of the art protocols, SGR, CDTM-RLB, and the directed diffusion. And these are we have done average delay, average end-to-end delay, throughput, and packet delivery ratio, and packet drop rate, and also for different alpha, beta, gamma coefficients. And we have seen when we are having all the equal importance for all the three factors in the PCF, we are getting the higher result. So that's the first contribution, survival path routing. And SACS, survivability aware channel allocation algorithm in the MAC layer, it actually works along with the routing layer. Like the SPR, the survivability path routing protocol, works at the upper layer, and SACA works at the lower level. And it actually, based on the, it uses the fuzzy-based fuzzy inference system for the channel characteristics evaluation. It uses three inputs, like the channel strength indicator, link quality indicator, and the path loss distance. And it chooses output for getting the average contention time. It uses actually the CSMA-CA algorithm for the IEEE 802.15.4 standard. And also to change the random number for the random number multiplied for the getting the waiting time. Again, it uses the node survivability factors, the application data rate, and the packet service rate at the next receiver node, and also the path survivability factor for the next next hop node towards the destination. So again, we have done comparison using the 802.15.4 algorithm and few other state-of-the-art algorithms, and we have taken the the application network is we try to create a simulation environment that replicates a hospital ward where many patients are admitted and kept under observation. So actually, they wears a 2 cross 2 meter square body area network, and they have different number of sensors attached to the body area networks. These are the sensors, and these are the data rate for those sensors, and these are get from the IEEE standard for this medical health informatics, IEEE standard for health informatics. And we have compared with the packet delivery ratio, average delay, throughput, and again, another simulation setup we have done because it's a MAC algorithm, to have the rigorous evaluation between the sender node and receiver node, we have increased the number of transmitter receiver pair in a single transmission range circle from 0 to 10 to have a rigorous evaluation. And the packet generation interval also varied to 100 milliseconds to 10 millisecond, and we have compared with the state-of-the-art algorithms. And as I told, the third contribution was it was implemented in the real Quantiki OS, which has been already developed, these as SPR and SSEA, which has been implemented in the Quantiki OS. And this is the protocol stack of the real Quantiki OS implementation. The physical layer, it has CC2420, 2538 and all. And the MAC layer, it has 3 layers: MAC layer, duty cycling, and framing. The framing for IEEE 802.15.4, it creates the frame as per the standard.
Okay, thank you.
Yeah. So at the MAC layer, we have used the CSMA. Yeah.
Mr. Manu, Dr. Manu, can you please speed up, because already it's more than 20 minutes.
Yeah. I'm going to conclude it.
Yeah, please try to conclude.
We have developed, we have implemented those routing protocol and MAC protocol in Quantiki OS, and it's tested in the hardware test bed. This node deployment for the FIT IoT lab, as I told you, in the Paris site in France, and these are the available sensors there, and we have used the M3 nodes, and we have compared with the experimental and simulated results. And as I told you, the last contribution was the simulation tool, which the software tool, Python-based tool, which actually, this is a reconstruction of a network. We can see where it actually link drops. We can pinpoint. When we are getting the data from the functioning network, it will be about our single node itself. So the tool is reconstructing the topology and reconstructing the performance. The red and giving a heat map kind of presentation. The red is bad and green is good, like that. So we can pinpoint it at which position it is having less performance, where is performance bottleneck is there. So that is it. For the future, for future work, for routing protocol, it can be actually extended to use the suboptimal paths. That is also actually in a new direction in routing protocols design. Use the suboptimal paths also sometime, so that it will not the optimal path, using optimal path every time will not be get energy depleted, and use the transition power control technique for the network survivability metrics. And in MAC protocol, we are trying to use, there is a new amendment in the standard 802.15.4 that is actually for industry 4.0. That's actually TSCH, time synchronized channel swapping. And we'll try to implement the SSEA in industry 4.0 scenario, and also use the in IEEE 15.4 itself. There is a use of TDMA, like the guaranteed time slots. We'll try to use for the starved networks, starved nodes. And also we'll try to use the information from the developed tool, Python-based tool, to give the feedback for the routing protocol and the channel allocation algorithm. So these are some references, and these are some of the disseminations we have published the 2 work in SEA journal, and that's it for the time being.
Thank you,
yeah.
young and budding researcher Dr. Manu.
Yeah.
We wish you all the best. Thank you. And present, there are no questions related to your presentation, but probably someone may contact you and may need some more information related to your work. Please try to help them.
Yes.
Thank you.
Yes.
Thank you.
You.
Over to you,
Dr. Monali, ma'am.
Thank you, sir. Thank you, Vaibhav, sir, for chairing this session. Now I request Dr. Jasma to chair our next session, which is about student innovation. Over to you, Jasma, madam.
Thank you, Monali ma'am. I'm audible, right?
Yes, yes.
Okay. Uh, Good afternoon. Today we'll have two special student innovation sessions by students from the Department of Computer Science and Engineering. The first is Anant Adiga. Anant Adiga will be talking about the prediction of COVID-19 using genetic deep learning convolutional neural networks, GDCNN, and then followed by Nairika, who will be discussing about an efficient framework to bifurcate healthy and diseased vegetables and fruits using multimodal approach. Both of them graduated in the year 2020. That means this year they graduated from the Department of Computer Science and Engineering. I'll briefly introduce Anant Adiga. Anant is currently working in Laos, India as a software engineer. Anant Adiga's research interest lies in machine learning, deep learning, CNN, and also in the areas of application-oriented techniques in the field of machine learning. So now I ask Anant Adiga to begin his session. Anant, are you here?
Yes, ma'am, I'm here.
Yeah, thank you. You can start.
Yes, ma'am, sharing my... is my screen visible, ma'am?
Yes, Anant, it is visible.
Yeah. A very warm welcome to everyone present here. Today I'm going to talk about prediction of COVID using genetic deep learning convolutional neural network. So let's begin with the data. We used X-ray images, like we had collected around 5,000 chest X-ray images, like until April and May. And images were in different resolution, like samples can be like 508 into 500, and there were many other dimension as well. So we chose one particular dimension. We cropped the images and made into 224 into 224. Yeah, and these images we collected from COVID chest X-ray data set. Currently, they have around 5,500 images, and we also gathered from other sources. There were many other publications that gave us the data. Everything was open source, so we collected so much of data, but there were some images which were not fit enough, so we discarded them. We had manually gone through the data and saw that if the images were right or wrong. And then these images were both certified images by radiologists. Only those images we kept it. Some were not certified, so we discarded them. So at last we had around 5,000 images. This is a sample image. The first row contains COVID positive patients. Second row, second, third, and fourth row contains non-COVID positive images. Through the naked eye, it's not possible to differentiate between a COVID positive and COVID negative. Only few people. Even the accuracy of radiologists is around 80 to 85%. So we need some machine learning and deep learning algorithm that could predict it with a higher accuracy. So we came up with this approach. On my left, it's a COVID positive image, and on my right, it's a COVID negative image. You can see that like I can't differentiate it, like so we need some technique. So here, let me just briefly introduce what is CNNs and deep learning. Difference between neural network and machine learning is basically machine learning deals with linear function, but deep learning and neural network can deal with non-linear function. Non-linear function can be anything. Let's say you have linear regression, which basically predicts a linear function. But in case of images, you need advanced techniques such as CNN. CNNs are basically used for images. It also gives us non-linear function as well. The non-linear function just came into existence like 15 to 20 years when we started to use activation functions such as ReLU sigmoid. During the period 2005 to 2006, the people have started moving from sigmoid function to ReLU function, and it changed deep learning drastically because ReLU was giving them higher predictions accuracy as well. But still we use sigmoid, and now researchers came up with softmax function, which is also useful in some scenarios, but still people use ReLU function. A small difference between classification and regression is that classification is used to detect object, basically yes or no questions like apple, oranges, something like that. Our problem was the classification because we had classification such as COVID positive and COVID negative. We also extended it to some other disease as well, like pneumonia, so that the accuracy goes higher because they come under the same roof. We tried with both the approach, and regression is predicting a value, maybe a price of a stock, something like that. Coming to CNN, it's only used for image classification, audio, and text classification as well. ANN, or also called as NNN, basically ANN stands for artificial neural networks. It can be used for anything. Deep NN basically means that having multiple hidden layers. Because the complexity increases, we call it deep because it's having deep hidden layers. Coming to the representation, this is a representation of a ANN, artificial neural network. The first layer is input. Input can be anything, CSV file, any text file, or in case of images, input is basically the pixel. Let's say I have 224 into 224 image. So my input will be 224 into 224, that is 50,000 input. That will be sent to the hidden layer. Hidden layer can be anything, like it can be 4 neurons, it can be 8 neurons. Basically, hidden layer consists of neurons, which calculates y is equal to mx plus c. A different version of it, weight into the input plus bias. We use bias typically 0 and 1, and weight, we start with a random value, maybe all zeros, all 1, or some value, and try to learn what kind of weight is useful. Once you get the output, let's say my input is like 50 and my output should be 100, which is a predicting a price, but my output is 75 after my algorithm calculates. So I have to go back, which is called as back propagation, and change the weight. Everything lies in terms of weight. If I change the value of weight, my prediction will get different. So deep learning uses back propagation, which learns from the mistake and corrects it. You might not reach 100% accuracy because there will be noise and other stuff. So yeah, deep learning can be used on many occasions. In case of images, I started with pixel, right? 224 into 224, and this will be given to the hidden layer. So we can't use this directly. We need some other layers as well. That's when we use CNNs. CNNs are basically neural networks with the added feature that is convolution. Convolution is a layer. Convolution is a combination of two layers. The first one is convolution layer, and the second one is max pooling layer. Pooling layer, which can be max, average. I'm going to explain that later. So convolution layer and pooling layer. And CNNs can be used for everything, like detecting audio, text, or anything. And nowadays people started to use it for other started to use it with GNN, which is a generative adaptive neural network, which produces the image. That's a different topic here. Coming to the convolution layer, why can't I just use neurons instead of convolution layer is that when I give like an image of 1080 into 1080 pixel, it becomes very huge. That's around a million of input, right? So to decrease that, we use convolution layer. Convolution layer also used to get the feature maps. I mean, on what to focus my area of search. So that's why I use convolution layer. Next, after the convolution layer, basically the resolution comes down from 224 to it might come to 222. So further decrease that convolution by not losing any valuable information, we use pooling. A pooling layer basically converts a large image into smaller image. Pooling can be anything like max pooling, average pooling, or min pooling. Coming to the convolution layer, we have to use something called as filter or kernel. Let's say this is my image, 6 into 6 image, and I multiply that with my filter. So yeah, the first box, we use dot product, which gives me around, let's say 3. And then we move on to the next one. So we call this as stride, by a stride of 1. Sometimes we might not be able to get last row, because if my kernel size is 5 to 5, it's very hard to get last column, right? So we might have to add a separate technique called as padding, basically filling the last column with zeros or 1 depending on the images. When the image is around greater than 200 pixel, obviously you have to go with padding. So we use 0 padding here. Intuitively, we think that it's going to change the prediction, but it actually increased the prediction, because adding zeros to something doesn't change the value. At last, we're going to add the values, right, using this convolution layer. And coming to the color, we have 3 colors like RGB, right? This convolution layer can be used with this also. Instead of using a single filter, we might have to use 3 filters here. Same way, filters. So filters can be anything. 5 to 5, this is like random numbers. Let's say I fill my first row and last row with only ones, and in between I fill with zeros. So my output will be only verticals, like vertical lines. If I change it to first column and third column as ones and others as 0, so it becomes, it will only give me a horizontal column. So these filters are learned by a whole network by using the backprop. So number of filters is very subjective. We have to also learn it. Sometimes we use optimizers. Sometimes you have to build it yourself, because let's say I use 128 filters. 128 filters may not be applicable for certain kind of data. I might have to come down to 64. That you have to learn by looking at the data. On a whole, CNN takes the input and uses convolution layer to get the features, and then the size of the whole image is got down to a less dimension, and then we repeatedly use this. Number of convolution max pooling layer is very subjective. It depends on the data set. Sometimes you might have to have a very deep convolution layer, but sometimes it works with a very simple convolution layer. The starting point is 2 convolution layer, 2 max pool layer, and then we get a output, right? We have to flatten it. Instead of 128 into 128, 3, which is 3 represents RGB color. Instead of that, I have to make it in a single dimension. For that, we use flatten layer. Flatten layer completely flattens, and then we're going to use the deep learning. So neural network plus convolution in a whole called as convolution neural network. When it is deep, I mean the hidden layers are more, then it is called as deep convolution neural net. And we have used fully connected network. Basically, when you connect all the neurons to the other neurons, it becomes fully connected, but also the complexity increases. I mean, to run our program, it took us like 5 to 6 hours when using TPUs, using Collab. So it takes a lot of time. So you have to make sure like how many layers you have to use. So these are the parameters you can learn by repeatedly, running the program. But we used a different approach here. We use genetic algorithm to get the parameters and saw that what accuracy they are giving. Coming to our work, this is the sample code. We use TensorFlow because we thought of using PyTorch, but PyTorch uses QBars. So Collab doesn't provide us with that. So we went for TensorFlow, which was much easier for us to understand and also visualize. There's a program, open source program, which visualizes the whole work. We use that to see like at what point our algorithm is focusing. Basically, it's going inside the lungs in the X-ray, and those are the very important points. Starting with the program, sequential, and then coming to the convolution layer. We used, this is a sample one, we used activation function as ReLU. We started using sigmoid and softmax, but we saw that ReLU was giving much higher accuracy. Let's say my input shape is 224 into 224 into 3 RGB, and then we have to convert this into a smaller dimension using pooling layer. You have 2 convolution layer, pooling layer, and dropout. Coming to dropout, what does the dropout do is basically you have neurons, right? You may have to stop them. Let's say I have 100 neurons. Not 100 neurons will be getting me the powerful points, right? Inside the X-ray, I need to focus on something. Not all of them will be working. Some of them might be zero. Zero is not useful here. So we're going to stop 0.25, that is 25% of the neuron in one epoch, and then go to the second one later. On a whole, it gives a probability of 1, saying that all the neurons will be activated once. That's a good way. These are the optimization. The hard work goes into the optimization because it almost increases your accuracy to 15 to 20%. Drop down, we also saw a paper on dropout. So basically, they suggested us going with a smaller value and then continuously increasing it, not more than 0.5. After dropout, we have gone back to the convolution layer again and max pooling layer. We tried with average pooling, which didn't work very well. Then we've gone with the minimum pooling, which also didn't work well. So we came up to the max pooling layer. And then we're going to give one more convolution layer, and then we're going to flatten it. And then it on a whole, it goes to the neural network where same ReLU layer is given and sigmoid layer. The function of ReLU layer is basically when f of x is greater than 0, the value is x. But when it is less than 0, it's 0. But when it comes to the sigmoid function, which is basically 1 by 1 plus e to the power of minus x, it gives a value between 0 and 1. Sometimes this might not be useful. So ReLU is a very powerful activation function, which increases your accuracy, and also softmax function. Let's say my last layer gives me value something as 1, 16, and 0.1. I don't have a scale to measure this value, right? So I have to go to the activation function called as softmax, which makes all this value in a scale that is between 0 and 1. My 1 value might become 0.2, 16 becomes 0.9, and the other value might be close to 0.001. So I know what I can get to know these values. And also we have used binary cross entropy because in this case we had only right? Either it's a COVID positive or a COVID negative. So binary classification. And coming to the optimizers, we had a lot of options to go with the optimizer. Adam, SGG, SG, stochastic gradient, and we had RMS prop. One thing about choosing optimizer is that there's a concept called as momentum and learning rate. You can't really start running late at whatever point you like, because it might not work for one input, it might work for some other input. So you have to also learn these parameters. That's why we use Adam. We started learning rate with 0.01 without using this optimizer to see how it works. It really didn't give a good value, so we increased it, we made it more. It's really hard to get one particular value. It has to change dynamically on every epoch. Epoch is nothing but completion of all the images. Let's say I give around 5,000 images. Once I complete all the images, it's called as epoch. So sometimes I might change my value of my weights in every 10 images, because to decrease the complexity, and it's much faster. So I can also do that. We use like batch of 100, so that after every 100 images, my algorithm backpropped and learned the new value of the weight of the neurons. And to also increase this value much higher, we use the momentum parameter, which basically learns the weighted average weight. So instead of taking all zeros, we started with all zeros, right? Sometimes, it doesn't work. It has to be a bit, it has to be a bit bigger than 0, but not more than 0.5. So this optimizer also helped us to learn that value. And when it comes to the algorithm on whole, the first we started with 224 into 224, which is converted into 222. There's a formula which is basically nothing but my input shape minus kernel size. In this case, my kernel size was 3. My input shape was 224. 224 minus 3 is 221, divided by my stride, which is 1, which gives me 221, and I have to add 1, 222. That's my output here. Same way, when it comes to max pooling, it divides by 2, depending on the kernel size. I gave 2, so it becomes 110 into 110. And these values, 32, 128, is a filter or kernel value that we give to the convolution layer. This usually we start with a lower value, then we decrease it, and we have to come back to the smaller value. This is also very subjective. I mean, we have to try out which works and which doesn't work. We thought it's very good to go with a smaller value such as 32 instead of 16, which is 2 less, and then increase it to 128. And then coming down, dropout was used. Dropout increased accuracy by 1 to 2%, and then max pooling, dropout, and then after that we came to the flattened layer. So when you multiply this value, dropout 11, that is 26 into 26 into 128, which is 3 dimension, is converted into single dimension, which is 86,522, and this is given to the dense layer. Dense layer basically calculates the other weight into the input plus bias. So dense layer is very useful to pinpoint what location I should concentrate. And in my last layer, I only have one put. That is the value between 0 and 1, because I have given sigmoid function. So the value is between 0 and 1. If the value is more than 0.5, that is my threshold. That means that value is basically predicting COVID positive. If my value is less than 0.5, then that means it's a COVID negative. So total parameter you can see. So these are the parameters used. We also have used other images, so that has a different resolution. So at last, even though it's 576 into 576, we converted it into a standard resolution so that it can be used for all. And also after that, we needed something to compare our model with. So we used VGGNet, ResNet. These are the algorithm called as transfer learning. This is a technique called as transfer learning, where you train it with the already trained algorithm. On bottom, you can see the VGG16. This is the model. You have convolution layer 2 in the first thing, pooling, then it goes on. At the last, it detects 10 objects, maybe human, cat, dog, but we have to remove the last layer and make it into only single output. That's a value of 0 and 1, which is assigned to COVID positive and COVID negative. We tried with the VGGNet, ResNet, all this already pre-existed algorithm. These algorithms are already trained on so many of images, maybe close to 1 million, and it has a lot of parameters. So we don't have to train it. We just have to train the last layer. That is like only the last layer, where we remove the 10 output and make it into 1. So it's much
Anand?
quicker. Yes, ma'am. Yeah.
Please quicken up.
Yeah, ma'am. Almost done. Yeah, this is the last section. Yeah. So we used VGGNet and all the others. Then we compared it. We saw that GDCNN gave a much higher accuracy compared to the other ones. VGG was not the latest one, so it gave 88.5. But when it comes to ResNet, which is very powerful, gave around 93.35. That's all, ma'am. Yeah. Further work, we are using GNN to produce data set. Basically, nobody has ever used GNN to produce a image of a disease, because we need to consult doctors for that, because GNNs are not that accurate. If they give around 60% also, that's fine. So we're trying to see if we could produce images by using GAN, which is basically a coupling of a convolution layer and the convolution layer. That's all, ma'am. Thank you.
Thank you so much, Anand. A wonderful job. Your paper was recently published by IEEE, and it was on 21st September 2020, right?
Yes, ma'am.
Congratulations. We are very happy for you, Anand. Okay, so now we'll move on to our next student, Nairika. Nairika graduated from Computer Science and Engineering Department in 2020. She is currently working as a data science intern at WIC. She'll be joining Accenture on the 6th of November 2020. Her future plans is to pursue a master's degree in the United States in the fall of 2021. Nairika's interests are in machine learning, artificial intelligence, deep learning, and data science. Nairika?
Yes, ma'am.
You can start presenting your work.
Yes, ma'am. Thank you, ma'am, for the introduction, and I'd like to welcome all our professors and lecturers from Dayanand Sagar University. So my paper is titled An Efficient Framework to Bifurcate Healthy and Diseased Vegetables and Fruits Using Multimodal Approach. I published this paper along with Dr. Rajesh TM, Dr. Shaila ma'am, and Lavanya ma'am, who's been a great help during this 2 years journey. So these are what I'll be talking about during this session. So moving on to the introduction, we know agriculture is the backbone of India's economy. India is the second largest production unit for growing fruits and vegetables worldwide. But however, our farmers recently are facing a lot of issues, and due to which almost daily 10 farmers are committing suicide. So, and one of the reasons what we focused in our paper was at certain epidemic outlashes, lots of fruits and vegetables have been subjected to diseases due to bacterial and fungal growth, which causes rotting and black spots. So the process of identification and disease detection is currently being done manually by the laborers. This is a very tedious process, and the laborers have to go to the farm at least 3 to 5 days and have to continuously monitoring the growing crops. Now, agriculture is one such field where researchers all over the world are coming up with effective algorithms to tackle real-life problems using various approaches like IoT, machine learning, computer vision, many such processes. So in our paper, first what we're doing is we're acquiring the images using the camera which is placed on the robotic arm. So after which we'll do some basic pre-processing techniques to enhance the image so we can get accurate results in the feature extraction phase. So we'll be enforcing unsupervised learning to differentiate the fruits and vegetables into two clusters. So first, we'll be using the k-means clustering, which helps us to do this based on its color, size, appearance, and features. Later on, we'll be using the PCA algorithm and the SVM classifier to identify the diseased and healthy fruits and vegetables. After which, in our algorithm, we collect the diseased and healthy data sets, and we'll be using a supervised learning technique. Again, that is the k-means clustering, where we train our robot to differentiate between the healthy and diseased fruits and vegetables. At the end, we give a unique identification number so we can compare the results from the PCA algorithm and the SVM classifier with the partition differentiation, what we've done using the k-means clustering, our entire algorithm. So after this learning process is finished, our robot is now capable of identifying the disease produced on its own and then produce a response to the end effectors to pluck the diseased commodity if it's present. So in our background analysis, what we found out from all these papers are it's very effective to use k-means clustering along with feature extraction, because they said the authors have claimed that they have a 20% overall speed up while compared to the other approaches. As you can see, there are a lot of papers and they've used different kinds of algorithms to produce certain results. So the challenges what we faced was in agriculture farms, they have more than one kind of fruit and vegetables grown. And also the navigation of the robot in real-time scenario with the obstacles present. Also, the third point is quite difficult for us to even identify right now, because if the disease occur inside the fruits or vegetables without showing on the surface, it is hard to identify not only by a robot, but also by a laborer or a farmer who's very skilled in the job as well. So we are yet to find sensors or any X-ray vision tools which can help us identify if the fruit or vegetable is rotten on the inside. So our objectives are mainly divided into 4 phases. First is the collection of the data set, and we approximately collected about 6,000 to 10,000 images over the internet. And the phase 2 was the segregation of fruits and vegetables. Here we've used tomato as a fruit, and vegetables, we've taken 2 of them, that is the capsicum and cabbage. The phase 3 consists of the disease detection and identification. So here we mainly identify the disease produced by fungal and bacterial infections. So phase 4 is finally the stimulation of the robotic arms to pluck the diseased commodities. So this is the visual representation of how our model and our robot works. So first you can see the navigation of the robot is done by using a GPS technology. So once when it enters the field, there are all kinds of fruits and vegetables in it. So we are using k-means to identify the fruits and vegetables into 2 different clusters, after which each of the k clusters need to be counted and differentiated further using a KNN approach, where we can count how many vegetables or fruits are there. After which we'll be again using k-means clustering to identify the healthy commodity and the diseased commodity. Further which, if a healthy commodity is detected, there is no movement of the arms and the robot moves ahead. Suppose if there's a diseased commodity, the robot stops and the arm plucks it. This goes on until the robot reaches the end of the field. So some of the basic pre-processing steps we use before giving these images to the feature extraction are as follows. First, we obtain the input image from the camera placed on the robot's arm, and it's in a digital format. Later, we convert that to a grayscale image, and we're using MATLAB for this, and the simple command RGB to gray is enough to convert the color. After which we're resizing all the images which are captured from our robot into 150 cross 150. Later on, we'll be denoising the image. So first, while capturing, there can be any outside external noises, or there can be some dust particles on the camera itself. So we'll be adding salt and pepper noise first, and then we'll be using IM noise for the MATLAB command. After which we'll be using a median filter to remove the noise. So in MATLAB, the command is MED filter2. So after this, we get a pre-processed image. So this is the feature extraction phase for the training phase and the testing phase. So I'll explain this more on with the help of the equations, as you can see in this slide. So first, the pre-processed image is subjected to k-means clustering. Here, the objects which are identified as fruits and vegetables are differentiated based on their well-defined characteristics such as color, shape, and size, etc. So after which you can see the first equation, that is K. K here stands for the clusters which will be identified. Here you can say fruits and vegetables. So f of u comma v is nothing but the image what you're feeding into it. And then you can see a summation of 1 to n and g of x1 comma y1 plus g of x2 comma y2 and so on. It goes to g of xn comma yn. Now you'll be wondering why is there n clusters when there are only fruits and vegetables. Suppose our model comes across an unidentified object. So even though it's grown in the field, so for that we're using n function. So after this, each k cluster is subjected to further analysis, and then it helps us to identify how many number of objects are present in k. So we give that equation term as kn. So that is equal to f of x comma y, which is equal to the summation of 1 to n, a naught plus a1, so on till an. So a naught and a plus a1, so on, represents the individual fruit or vegetable which is present in the k cluster. After this results, we subject this objects, kn objects, into k-means algorithm again, which helps us to identify the diseased and the non-diseased parts of the fruits and vegetables. This is again segregated into two parts. You can see here as KNN, that is the equation what we're building to identify the diseases and the non-diseased part of the fruit or vegetable. So after which you can see f of xn comma yn, which is equal to summation of 1 to n, a naught plus a1, so on till an. So this can either be the healthy part or the non-healthy part. And then again, summation of 1 to n, b naught plus b1, and so on till bn. So this is how we classify them into two separate folders. After which the results obtained from equation 3 is the different types of diseases found in fruits or vegetables. So during this process, we allocate each of the different identified bacterial or fungal disease with a unique identification number in the training phase. So when we run the same algorithm for the testing phase, our model will know what kind of disease does this particular fruit or vegetable have. So the common diseases occurring in fruits and vegetables are due to fungal and bacterial infections. So we've taken black spot disease in tomato, anthracnose disease in capsicum, and alternaria disease in cabbage. So moving on to detecting the spot disease. So we're using color detection using k-means clustering, as I already previously mentioned. Here where the foreground is the part where it contains the healthy pixels. So using this, if the entire fruit or vegetable is healthy, it means that all the pixels are covered with its respective color. However, if there is a disease that occurs, you can see in the background extraction where the disease part is clearly visible on the screen in the other side. So we're also verifying it using PCA. So it's a spot detection. Spot detection can be identified with the help of its 13 features, some of which are contrast of the image, correlation, energy, mean, standard deviation, RMS, variance, smoothness, and etc. So for the experimental result analysis, these are the three outcomes what we got. So if you can see the first image which is placed of the tomato, there are cluster 1 and cluster 2. Here the tomato is infected with spot disease, and in the first cluster, you can see the healthy part of the tomato that has been extracted, and the background consists of the healthy pixel, whereas the foreground consists the spot disease. So here it's been covered by a black mask so that we can calculate if it is a diseased portion or not. So you can see the second cluster which has the diseased portion where that has been highlighted, and the background which contains the healthy pixels has been masked. The same can be done for capsicum and cabbage as well. So in the conclusion, what we've reached is our paper mainly discusses about the disease detection and identification of diseased fruits and vegetables, which is highly beneficial in the model. This model helps the farmers, gardeners, and homemakers to easily identify the disease that is caused due to infected growth of fungal and bacterial parasites. So these are the references which I took to build a presentation, and our paper was accepted in the ICC 2020 conference, and we won the best paper award. Thank you.
Congratulations, Nairika.
Thank you, ma'am.
Very well done. Thank you so much. So now I request our Dean Sir, Dr. A. Srinivas Sir, to please deliver the valedictory session.
Yes, thank you so much, Dr. Jasma. First of all, it was a culmination of all the domains in one platform, and certainly we need this academic and research culture, and it very much needed for a growing university like ours, because we cannot just say we'll just confine to classrooms and do whatever we are given to do. No, I think this kind of interdisciplinary research that we have seen today, it's amazing. I think it's the best platform to see what others are doing and how can somehow align with that. And also, it creates a kind of a healthy competition, because when my colleagues are doing so well and they have presented such good results, it tempts others to get into that brand wagon. And I think this is the very essence of this in-house symposium. It was a very novel initiative triggered by Professor Deshmukh. I am extremely thankful to him because he comes from the IIT background, and he clearly has a vision what a good university should be. So, sir, I'm extremely grateful to you for initiating this, and the results are very obvious. You can see the kind of energies that our presenters have exhibited today. Thank you so much, sir. It was a wonderful initiative. And we had Dr. Baishali, Dr. Monali, Vishwanath, and Dr. Revati. They were so enthusiastic, if they are not good researchers, this enthusiasm would not come out, The very fact that they themselves are very good researchers, they were able to take this along from a definition stage all the way till a conclusion today. I am very thankful to them, and the kind of initiative they have shown, it makes us feel that we should call them again and again for any eventful things like this. So that's that is the hazard of doing things very well. You will be called again and again for doing such activities. Okay, please be prepared. Okay, so we had a student session also, which was very interesting, because I think they also feel we have got a right platform to exhibit our research. So I'm very thankful for the students who have presented, and all the presenters, they just took the best part of their work, whether it is current work or previous work, and they projected the importance of that domain and the results. It's amazing. So thanks, presenters. My colleagues were wonderful. and you have contributed a lot to the ambience of this whole symposium. I'm very thankful to the Vice Chancellor, the Registrar, and all the management for their relentless support. Thank you so much, sir. I think they're not around today, but we'll convey our thanks to them. We will continue this journey. It is just a beginning and a initiation, and I'm very sure such things are going to add a lot to the growth of our university. So thank you all, and all the participants stayed through, to learn and to continue their research. Thank you so much for all the attendees. And finally, I think it has been a wonderful two-day session. So thanks again. We'll meet up on such occasions again and again. Thank you so much.
Thank you so much, sir. Deshmukh sir, am I audible?
Yes, yes. I think Professor Srinivas has summed up the wonderful 2 days that we have had over here. It really has been a very stimulating experience for all of us, and I have thoroughly enjoyed the participation by all the faculty at the School of Engineering. The presentations, the talks were extremely good, and it is an indication of how good research is done at the university, and there is so much more to follow. So there will be other presentations in the days and weeks and months to come. Very special thanks to Dr. Revati, Dr. Vaishali, Dr. Vishwanathan, and Dr. Monali for taking care of all the arrangements. And of course, Professor Srinivas led this whole effort from the front, from the very beginning, from the very conception of this idea, and make it really happen. So great vision, wonderfully implemented over there. Of course, there was nice support and guidance from the Vice Chancellor, Professor Murthy. So we are very grateful to all of them. And most of all, to all the faculty members who made presentations. The chairpersons conducted the session so very well. Sometimes the talks go beyond the time which is allocated for those, and the chairpersons handled it very nicely, very sensitively, and kept the proceedings under control. So I think we have had a very successful day and a half symposium here. I'm sure this is something which will continue in various forms. One of the things that Professor Srinivas has suggested, and I fully support that, is to have regular faculty seminars, and we will be initiating that activity very soon now. There will be a faculty seminar like every month or something like that. So this is something to see. And the student session were really very exciting. So it's wonderful to see young students, even undergraduates, who can contribute so much to frontier research. And I really enjoyed those two talks very much. I have personally enjoyed working a lot with undergraduate students over the years, and I've worked quite a bit with undergraduate students, just like senior students at master's and PhD level. So on the whole, this has been a very successful meeting, and Dr. Manali is coordinating this session. So I will give it back. I will give the flow of the session back to Dr. Manali, and you may conclude the session, Manali.
Thank you, sir. Thank you, Jasma Madam, for chairing this session. And Deshmukh sir, Srinivas sir, thank you very much for motivating us to take this assignment and guiding us through all out this process. And I hope everyone, all the faculty colleagues and especially students enjoyed this session. And I hope to see you all soon, very, very soon.
Thank you very much.
Goodbye, everybody.
Goodbye.
Bye.
Bye-bye. And have a very happy festival. Please enjoy.
Sir.
Happy times. Goodbye.
Bye-bye, sir.